To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time, and the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anritsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anritsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anritsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. beyond testing for a sustainable future. Advancing beyond. Handitsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation No. 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked at Center 2 in Kemenristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge and therefore no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anritsu's business. Anritsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time. And the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times.
Recording in progress.
Good morning, honorable guests, distinguished speakers, presenters, and participants. Welcome to the second day of the 2023 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications, or ICRAMET 2023, with the theme of Empowering Global Progress, Innovative Electronic and Telecommunication Solutions for a Sustainable Future. I would like to welcome our guest of honor, heads of research centers under the Research Organizations of Electronics and Informatics, Indonesia's National Research and Innovation Agency, or BRIN. Also, our keynote speakers, Professor Seto Kenshu from Kumamoto University, Japan, Professor Iyad Dayub from INSA Haute-de-France and Université Polytechnique Haute-de-France, or UPHF, France, Professor Josaphat Tetuko Sri Sumantyo from Chiba University, Japan, and Universitas 11 Maret UNS Indonesia. Professor Asrul Izam Asmi from University Technology Malaysia, UTM. We also would like to welcome our esteemed patrons, Ms. Alice Christiana Tirta and Mr. Gumbira Setiawan from Anritsu Pte Ltd Singapore and Unitronic Jaya, Ms. Mulyana from PT Era Mitra Perdana, Mr. Enjang Ruhiat from PT Serviam Abadi Murni, Mr. Masyuri Wahab from PT Radar Telecommunication Indonesia, Mr. Ivan Pati from PT Mitra Sistematika Global, Mr. Pandiga Haryanto from PT Dynatech, Ms. Dewi Kartiwi from CV Nugarada Abadi, Mr. Dadan Ramdan and Mr. Chandra Dwi Perkasa from PT Nusantara Turbin dan Propulsi. Also, welcome to our presenters and participants. Today we will have 2 keynote talks and 10 paper presentation sessions. In the morning, we will hear a keynote talk by Professor Kenshu Seto from Kumamoto University, Japan, followed up by parallel sessions 9 to 14 before lunch break. Parallel session 15 to parallel sessions 18 will be continued after the lunch break at 1 p.m. GMT plus 7. The final keynote will be brought to you by Professor Iatayu from INSA Hauts-de-France and Université Polytechnique Hauts-de-France. Then we will have the awards announcements for the best paper and best presentation awarded by the Technical Program Committee. At the end of our conference, we will be marked by the closing remark from ICRAMET 2023 Chair, Dr. Yuliar Firdaus, and Dr. Yusuf Nurwijayanto, as the head of Research Center for Electronics, Indonesia's National Research and Innovation Agency, or BRIN. Okay, before we start the second day, I would like to invite you to enjoy our screen capturing session. I would like to request all honorable guests, distinguished speakers, presenters, and all of the participants to turn on your cameras. We will capture the frame 3 times, so I will do 3 times of the signaling. And first, for the first frame in 3, 2, 1. Okay. For everyone who haven't opened your camera, please open your camera. Second, in 3, 2, 1. Okay, and for the last frame in 3, 2, 1. Thank you for all your assistance in this screen capturing session. Without further ado, we will start with our first keynote talk for the day that will be delivered by Professor Kenshu Seto from Kumamoto University, Japan. This session will be moderated by Dr. Natalita Maulani Nursam. I would like to introduce Dr. Natalita Maulani Nursam. She obtained her bachelor's degree in electrical engineering from Universitas Indonesia in 2004 and obtained her master's degree in electrical engineering at Australian National University from 2008 to 2010 and PhD in chemistry from University of Melbourne from 2012 to 2016. She joined Indonesian Institute of Sciences or LIPI in 2011 and was promoted to research professor in Indonesia's National Research and Innovation Agency, or BRIN, for the research group of advanced photovoltaic and functional electronic devices. Her expertise area are solar cell and semiconductor devices. Please welcome Dr. Natalita Maulani Nursam and Professor Kenshu Seto.
Okay. Thank you, Ms. Ardita, for the kind introduction. Good morning, ladies and gentlemen. Again, welcome to the second day of ICRAMET 2023. My name is Natalita. I'm a research scientist at the Research Center for Electronics of the National Research and Innovation Agency of Indonesia, or BRIN. And today I'm going to be moderating this session. So this morning in our keynote session, we will have a keynote speaker, Professor Kenshu Seto from Kumamoto University, Japan. Good morning, Professor Kenshu Seto. It's probably noon in your time.
Yeah, good morning.
Thank you for joining us today. And before we start with your speech, I would like to briefly introduce Professor Kenshu Seto. So Professor Kenshu Seto received his bachelor degree from electrical engineering from University of Tokyo in Japan in 1997. He also received master's and PhD degree from the same university from electronic engineering, University of Tokyo in Japan. From 2004 to 2006, he was a researcher at VLSI Design and Education Center in University of Tokyo. And since 2007 until present, he is an assistant professor at University of Tokyo, Japan. And recently, since 2023 until currently, he is a professor at Kumamoto University, Japan. His research interests include VLSI design and also high-level synthesis and compiler optimizations for HLS. So today, Professor Kensu Seto will be delivering a talk about high-level synthesis, or HTL. HTL is typically used in electronic design automation to reduce hardware design time. However, this process often requires a lot of time because the input software rewrite is necessary. And in his talk today, Professor Kensu Seto will present an automated software code optimization to solve such problem. So before we start, I would also like to remind all of the participants, if you have any question, you can use the raise hand feature in your Zoom menu later on during the Q&A, or alternatively, you can also type in your question in the chat box and I will read it later during the Q&A session. So Professor Kensu, you have around 30 to 35 minutes of presentation, and then we will have 10 to 15 minutes of Q&A. So the time is yours, please.
Okay, thank you. Can you hear me?
Yes, we can hear you well.
So let me start. Okay, so I begin the talk. So the title is Software Code Optimization for High-Level Synthesis. So this is outline of my talk. First, I will introduce high-level synthesis techniques. So high-level synthesis is a technique for generating hardware, digital hardware automatically. Usually, the whole system design, digital system design, start from set of functions that execute in parallel in C code, and we simulate it to verify if the functionality is implemented in the system. We also need to have some system level architecture. So CPUs and DSPs and memories are connected through buses with external memories. And also, we also need to have hardware software partitioning. So given a set of functions that can be executed in parallel, we have to determine which part is executed in CPU or special processors or hardware accelerators. Based on this system level design, we implement system on chips. We also want to reuse IPs, intellectual properties of hardware, as much as possible. So IP library is usually utilized, like ARM CPU core or memory macros or some kind of accelerators. And so here we review some high-level synthesis techniques. So high-level synthesis starts from C or C++ or System C, which is a language, C-level language designed for hardware design. And instead of using traditionally, even currently, we use Verilog HDL or VHDL, which is a hardware design description language called Register Transfer Level language, or RTL. It can describe high-performance hardware, but it is time-consuming to make RTL description or changing or simulating, because details of hardware like clocks or flip-flops have to be described in RTL. Instead of RTL, C program is faster in simulation and easier to describe and modify because it's more abstract than RTL. So starting from C program, by changing the options or directives to high-level synthesis tool, we can generate different architectures easily from the same C program. So HLS is located here. So from C descriptions or algorithm, we generate a hardware description language in register transfer level description. Then we synthesize RTL program into gates and flip-flops, and followed by physical design like layout, floor planning, and place and route of modules. So this is I will explain current status of HLS. We have several common high-level synthesis tools from Intel or AMD for FPGAs, or Stratus HDL from Cadence for ASICs. But basically, the techniques used in high-level synthesis is mature. I mean, algorithms are mature. And based on the techniques, we can translate C program to RTL description automatically. And I will explain this later. And we can generate RTL quickly, like from minutes, from seconds to like 10, 20, 30 minutes. It's very short compared to manual description of RTL by human designer. But we can generate RTL automatically, but satisfactory RTL, like in terms of chip area, circuit area, or performance like clock cycle, or the number of execution cycles often requires optimization of the C program. So just using high-level synthesis tool for a given C program generates a good hardware for very simple C program. But if the C program is complicated, it is not, you need to modify C program, optimize C program. And if we have a complete ideal C program optimization in high-level synthesis, it's good. We are done, but it's not perfect. So we need to optimize C program before high-level synthesis. So we need to optimize C program automatically to reduce design time, and at the same time, enhance hardware quality. So high-level synthesis is used more and more because it's convenient. You can generate hardware automatically from C program. But if the quality matters, you need to understand high-level synthesis internally, and you need to understand source code optimization and the effect of this optimization based on the understanding of high-level synthesis algorithm. So just using the high-level synthesis is basically easy, but designing a high-performance hardware with high-level synthesis, you need knowledge and experience. So I hope I could introduce some of these. So I continue the explanation of high-level synthesis. So high-level synthesis synthesizes hardware from C program. So the C program, basically computation and ordering of computation are fixed. But differently from RTL or Verilog HDL, data path is not determined. What kind of function unit, like multiplier circuit or other circuit, is used is not determined yet. And which register stores which variable in the C program is not determined. Of course, because these tools are not determined, connection of components are not determined. And control circuit that controls these components like registers and function unit is not determined in C code, C program. With high-level synthesis, it generates RTL hardware description language automatically by determining these data paths and control circuits. Okay, so high-level synthesis or compilers use intermediate representation or IR for their optimization. So given as input C program, it translates the given program like C program or Python program or Java program into an intermediate representation, which is used internally for compiler or high-level synthesis tool. A typical example of intermediate representation is control flow graph plus basic block. This is a common data structure used in software compiler. Each basic block is this rectangle represents a sequence of computation, optionally jump or branch instruction at the bottom. And these edges represents a flow of controls based on the branch instructions. We can transform this control flow graph plus basic block into control data flow graph, which mixes control flow and the basic block to generate parallel implementation. Okay. And based on these intermediate representation, we generate, high-level synthesis assumes some kind of hardware architectures, which is called finite state machine, which is a control circuit with data bus, which consists of adders, multipliers, registers, multiplexers, bus and memories, block memories. So given C code, high-level synthesis generates digital hardware automatically assuming these types of architecture. Okay. So high-level synthesis is summarized in this chart. So the input is a C code for hardware design, so C algorithm. And we also give clock period constraints and or this equivalently maximum operating frequency and the number of clock cycles and like some resource constraints. We also have resource library for a functional unit or registers or memories, dual port memory, single port memory, or that kind of things. Based on these inputs, we build intermediate representation like control flow graph plus basic block. And these steps are followed to finally generate RTL description like Verilog HDL. So I'm gonna explain these steps next. So given intermediate, given a C code, we translate input C program into intermediate representation. These graphs are used for the following steps. So high-level synthesis tool includes simple compiler optimizations like strength reduction, changes multiplication operation to simpler constant shift operations, which is much, much smaller in terms of hardware area, or to reduce critical path or the length of the longest path for a signal to propagate. Tree height reduction is sometimes used. So depending on the execution time constraint or chip area constraint, we have to choose which optimization to apply. Basically, high-level synthesis to automate this optimization. And first, okay, based on this, after this simple compiler optimization, which is usually beneficial for always, we proceed to the next step, called resource allocation. Resource means registers or these kind of multiplier, others, and the computational units or memories. So in resource allocation, we determine the types and numbers of resources used in the implementation. So for additions, we can choose like different types of others like carry propagation, other for compact addition, or faster addition, we use carry save other, or etc. So even for single operation, we have different types of hardware units, which is generated by high-level synthesis, given the constraint. And we also have different types of functional unit, pipelined or non-pipelined or multi-cycle functional unit. And we also have a floating point unit. And the memories can be single port, or for high performance, we can have a dual port memory. It's high performance, but more area. And these resource allocations are done basically automatically. So if one want to specify something, we can specify, but otherwise automatically resources are allocated. So if it is not satisfactory, you have to change the allocation manually. Okay, so after allocation or resource allocation is done along with scheduling, we do the scheduling, assign each operation in intermediate representation to each clock cycle, satisfying the clock cycle period constraints like 10 nanoseconds or 5 nanoseconds. And in scheduling, we want to parallelize operations as much as possible to reduce the number of clock cycles. So by changing the scheduling, we can obtain different types of hardware, different chip area, and different performance. So if we have like 2 multiplier and 2 others, we can schedule this. It's a shortest clock cycles. On the other hand, we want to save resources. We can have like this design with reduced resources or reduce chip area, but increase the execution time. Basically, these resources are automatically allocated by high-level synthesis, so you don't need to specify the number of computational unit. And after that, after scheduling, we have a fixed scheduled results. And based on that, we can determine which operations are bound to which functional units. So we have a scheduling result and we have a resource allocation results. Then we map each operation into specific hardware resources. So in this case, we have one multiplier, and these 2 multipliers are executed in different clock cycles. So we can share single multiplier with these 2 multiplication. On the other hand, in the 3rd clock cycle, we have 2 additions in parallel. So we have to allocate 2 others, and each of these operations are mapped to different others. In addition, we have to store these variables to registers, and the registers are shared as much as possible when we can share to reduce the area. But yeah, that's basically the things done in high-level synthesis. So this is the final result of a high-level synthesis. And high-level synthesis controls the data paths, which consists of multiplexers and multipliers and others and the registers. And these are input ports and output ports. These multiplexers and the registers enables our controls finite state machine. These are all generated by the high-level synthesis automatically. Okay, this is a review of basics of high-level synthesis. So next, I will explain importance of source code optimization for high-level synthesis. And as we have seen, high-level synthesis automatically generate RTL, as we reviewed in the previous slides. But in complex C code, high-level synthesis usually generate unsatisfactory hardware in terms of performance or chip area, like huge chip area. So to solve the problem, we need to do some time-consuming code tuning, code transformation, which is usually not easy for non-expert. And this kind of code tuning makes input C algorithm more complex because of the transformation. So if we have automatic source code optimization before high-level synthesis, it's very, very good because we can reduce design time with high-performance hardware. So before high-level synthesis and logic synthesis, I have developed techniques for automatic source code optimization. I will explain next. So basically, we can classify source code optimization for high-level synthesis for optimization across blocks or optimization inside each blocks. So optimization across blocks is like this. So given a complex C algorithm, these complex C algorithms are partitioned into small parts, and each part is implemented as hardware blocks. And some hardware blocks are executed in parallel, and data flows from inputs and outputs in like a streaming manner. So we need to first determine this kind of architecture. If it is automated, it's nice, but usually we have to do it manually currently. And after these architectures are constructed and described in C algorithm, we need to optimize each of these blocks, like using loop optimization and the memory access optimization. Usually, just optimizing single block does not do not make system high performance. You have to consider all of these. So it's not easy, but part of that optimization are automated in high-level synthesis tool. And even that, it's much more simpler than using RTL design because C code is simpler to modify and simulate. So, but some optimizations which are effective in high-level synthesis is not implemented in high-level synthesis tool. So you have to manually optimize these C descriptions because some optimizations are not implemented in high-level synthesis. If you apply these, you can generate better hardware. So I will explain them. So memory access optimization high-level synthesis. One of them is a memory partitioning, which partitions are usually arrays in C program represents data, stores input data or some filter coefficients or output data. If you write data in single array, like array A, it's implemented by a single port memory or optionally dual port memory. So the number of memory ports is 1 or 2. But sometimes, like image filtering, you need to access more than 2 arrays at the same time for high performance. In that case, we partition the local memory into several banks. This is just shows 3 banks, or like we have 8 banks, 16 banks, and we can obtain multiple data at the same time. So this is the advantage, and in this case we have a simple address computation like I+1, but we can have some kind of modular computation or that kind of more complex addresses of arrays could be handled. disadvantages, we have to introduce some multiplexers which increases area of hardware and the delay of hardware. And by we are partitioning the local memory, the size of the total memory is not reduced. So this memory access partitioning is already implemented in the high-level synthesis tool. So if you specify how much or how you partition memories, you can just do it automatically. You have to specify, but after specify the way of memory partitioning, it's automated. Another memory access optimization, which is not implemented in current high-level synthesis tool, is scalar replacement, which is shown here. So we have a sequence of loops usually. So some loop computes some data, and the following loop uses the data, like image data. Naive implementation of these algorithms just allocate a large array of images. This becomes huge memory. But instead of using such huge memory, we can just store data to shift registers, and by reusing the only necessary data from shift register, we can reduce the buffer memory significantly. This is like line buffers, and the line buffer is common in RTL design, but we also can design hardware with line buffers with high-level synthesis. But usually you have to use some kind of library. You have to understand the document and how to use the library for line buffer, which is kind of, you have to do manual rewriting, manual tuning to use line buffers. But I developed techniques to automatically generate these shift registers from simple C code in these papers. So compared to the previous memory partitioning techniques here, this scalar replacement is advantageous. So we have increased memory ports, which is similar to the previous memory partitioning, but differently from the previous memory partitioning, we have a significant reduction of the memory sizes. Disadvantage is that we only have a regular, this can be applied to regular memory access pattern like this. Okay. Next, I proceed loop optimization, which is also effective in high-level synthesis. So basically, in high-level synthesis, we have already automated loop unrolling, which expands loop execution to instantiate each statement. And possibly we can execute this statement in parallel for high performance. But usually we have a dependency in memories, so it is not so simple. But we are combining loop unrolling and the previous mentioned memory access optimization, we can execute in parallel. Another technique often used in high-level synthesis, a very, very strong technique, is loop pipelining. So it compared to loop unrolling, it kind of exploits regularity. So like a processor pipelining, we can generate a pipelined hardware. So each execution of the loop body is kind of executed in this way. And the next loop iteration is executed by separating some fixed iteration interval clock cycles. In this case, 2 clock cycles, another iteration starts and another iteration starts. So it can kind of have some regularities. And differently from loop unrolling, it is usually a small control circuit overhead. For example, if you have n is like 1,000, we have to unroll 1,000 times, which kind of becomes huge code and makes code or state machine complex. But loop pipelining control overhead is smaller usually. But these two loops optimizations are already automated in high-level synthesis. You have to specify how many times you loop unroll how to specify iteration interval. But other loop optimization exists, which is not automated. For example, we have loop fusion. Very simple loop fusion is automated without no dependency between these loops. But usually we have dependencies between these data dependencies. These loops cannot be fused automatically in high-level synthesis. We have like these loops optimization. These are kind of automated recently in the research project, but not in the current commercial high-level synthesis to incorporate these techniques. And you want to combine these different kind of loop optimization effectively to generate high performance and area efficient hardware. And to combine these optimization in singular formulation, polyhedral model is proposed. So we just review some polyhedral optimizations. So it's kind of very formal and complex, and these are not implemented in the current commercial high-level synthesis tool. But this is state-of-the-art compiler loop optimization. Polyhedral model is kind of formal representation of a loop program. So it consists of 3 elements. One is just loop range. So given this input C program, we have 2 statements, S1 and S2, this execution statement. And each S1 and S2 are executed in the nested loop. So the loop range is just how each statement is executed in terms of loop variables, loop iteration. So these loops are executed from 1 to 4. We describe the loop range like this. Next, we obtain schedule of each statement. So S1 is this is a multi-dimensional schedule. This schedule represents the loop structure of this statement. So each statement is represented like this. This is explained later in different slides. Finally, which is also important, is a dependence, data dependence between statements. So like this means S1 with I equal 4. So I equal 4 and J equal 1 is dependent by S2. So S2 when I equal 1 and J equal 4. S2 when I equal 1 and J equal 4 uses the data generated by this specific execution. Maybe this is just an example. Maybe this is detail is different or wrong, but yeah, this is data dependence. So these 3 information captures the input C description, and we transform this schedule. This schedule determines that execution order, and this schedule is translated to this. The difference here is just making this 1 to 0. This changes the schedule or ordering of operation corresponding to loop optimization. And this representation of loops ordering incorporates these optimization. So changing the schedule of each statement corresponds to multiple different loop optimization, possibly. And after this schedule, we can generate a C code for optimization. So these 2 loops are fused into a single loop, which possibly generate better hardware with high-level synthesis. So this is an overall flow of high-level synthesis, a polyhedral model-based loop transformation. After this loop transformation, we also have to apply memory optimization for better hardware. But anyway, this is a loop transformation. Okay, here I just explain detail of how we generate this schedule from original input C program and how we generate C program from the schedule. So this is a reverse process, but this is a kind of detail I skipped. And this is also just example from starting from this original C program and original schedule. By changing these schedules, we can change program. So fusing loops, outer loops, fusing both inner and outer loops, and reordering, changing the ordering of loops. Or we can shift the loop, so execution shifting by constant. Or we can interchange inner loop and the outer loop. That kind of things is done in polyhedral model without violating data dependence. So even if we can change the program, it is useless if the program meaning changes. So we can keep the meaning of the program by keeping this dependence between statements. Okay, so this is a assumption for the polyhedral model. It's kind of limited, but usually many image processing or matrix operation or neural network can be represented by these types of program, which is a linear in terms of loop variables. Okay, maybe. So this is just, I want to emphasize because I did some research on loop fusion. Usually image processing or neural network consists of a sequence of loops. And if we apply HLS naively from a simple sequence of loops, each loops executed in sequentially. So it's very slow. In addition, huge memories are allocated for each temporary images. So by fusing these loops into a single loop and by applying memory access optimizations, we can generate high performance hardware. This is a small caveat in loop fusion. So we can like syntactically fuse loops in like these two loops into single loop, but if the number of loop counts increases, it's kind of useless. Execution time is not reduced. So when we do loop fusion, we have to be careful that the loop count is not increased. Okay, these are some kind of detail, but what I want to present here is a high-level synthesis, a very convenient tool, but we often need a source code optimization for state-of-the-art performance in hardware. Important optimization includes memory access optimization, loop optimization. And I introduced polyhedral model for the loop transformation. Okay, and high-level synthesis tool improves continuously. So if we currently many people using it, but the tool itself improves, so it would be more and more useful. And machine learning techniques to optimize or select which kind of optimization should be applied is already proposed, and I think it will advance. Okay, that's all. Thank you very much for listening.
Thank you very much, Professor Kensuseto, for the very interesting talk. And before we proceed to the Q&A session, I would like to give just a brief summary of your talk. So Professor Kensuseto provides a highlight about the successful application of HLS, which requires understanding of the internal HLS itself and also the source code optimization. And in his talk, he presented several points. The first one, he explained about the current state and development of high-level synthesis. And then he also explained about the source code optimization using C program for HLS, and also the memory access optimization, and then loop optimization, particularly using polyhedral model. So now we only have 5 minutes for Q&A. I would like to invite all the audience or the participant. If you have any question, you can use raise hand, or here we already have one question in the chat box from Dr. Iman Firmansah. There's a question: how to avoid the data dependency in HLS, Professor? Please.
Okay. I didn't explain, but usually, so we have a data dependence. We have to observe data dependence, and so in this scheduling, we have data dependence in the high-level synthesis itself and the loop optimization. I will explain data dependence observing in high-level synthesis. So when we want to, given a C program, we obtain this kind of data dependence graph, which means each circle represents operation and each edge represents data dependence. This arrow shows this operation must be executed before this operation. So when we do scheduling, we have algorithm like list scheduling, like kind of different type of scheduling. So when we do scheduling, we first schedule this operation without data dependence. So these A and B are already input, so we can schedule these two operations anytime. So for example, we schedule this. But to schedule this operation, we have to check if the input operation, which generates data for this operation, is already generated. If these are generated, we check this operation can be scheduled because input data is already generated. So that kind of things is algorithm for scheduling to keep the data dependent. Is that answer question?
Is Dr. Iman, are you here? Do you want to ask for yourself directly to Professor Ken Suseto? I think Dr. Iman is here. Dr. Iman is an expert in FPGA, actually.
Oh, maybe okay. Maybe you mean observing data dependence in source level transformation. This is using in this polyhedral compilation, we use a kind of library, integer set library, to check if the dependency is observed. So I use that library, integer set library, which manipulates these kind of sets or mappings. So yeah, that's important part. Yes.
Yeah. Thank you for the answer, Professor. I think it's already answered the question. If anyone else wants to ask Professor Kenzo, you can directly open your camera or your microphone to ask directly. And maybe while we are waiting for the question from the audience, while you're showing us this slide, actually quite interested with the polyhedral model. Here use this model for loop optimization. I'm just wondering is there any other model that can be used instead of this polyhedral model? And is there any like a weakness or the benefit and weakness of this model, Professor?
Mm-hmm. Okay, that's a good question. So this is kind of has a longer history, like 30 years ago, from 20 or 30 years ago. And this kind of compiler, the state of compiler is LLVM and MLIR. So LLVM is a kind of basic, very famous compiler framework, which is used widely. And they did not adopt a polyhedral model directly. They use a simplified polyhedral model. One of the reasons is that given this schedule after loop optimization, they claim that the final form of C description is not intuitively derived. So there is no one-to-one corresponding. So this just schedule does not give some quick estimate for code size or code performance. So they use a simplified polyhedral model. So polyhedral model concept is very good, but sometimes it's not good for some objectives. Like from this schedule, it is not easy to predict the final form of C description. So they use some different types of simplified polyhedral model, which combined these two. So yeah, that's the question. Is it okay?
Yes, okay, thank you very much. Actually, we already passed the time, but maybe one last question. We have a question in the chat menu from Mr. Muhammad Iqbal. He has two questions, so please provide a short and concise answer. The first one, do synthesis support multi-threading or multi-processing mechanism, and is that possible to replace existing pipelining process? And the second question is, the scheduling will increase overall processing time impacted by contention time. So how to manage this issue?
Oh, okay. For the first question, in the research level, we have multi-threading support. So we have a high-level synthesis tool, LegUp, which is an open source, but it's acquired by some microsemi company, but it supports multi-threading. And multi-processing, maybe Intel high-level synthesis tool support multi-processing. I'm not quite aware. You can check Intel or Altera high-level synthesis. So from OpenCL. And pipelining is kind of, we have different types of pipelining. Small granularity pipelining where operation is like addition or multiplication. So you should use it. So multi-threading introduces some overhead. So you should use for small granularity, you should use existing loop pipelining process. But we have another different layers of pipelining for like coarse grain pipelining. You use data flow and like loops, several loops are executed in parallel in pipeline fashion. That kind of stuff is supported. Okay. But the multi-threading is, some tool support, you have to check. And for the second question, okay. So what is a contention? Okay. So scheduling is, you have a kind of data complex. That will managed by scheduling. Okay, is it true? What do you mean by this contention?
Maybe just overall, the scheduling will add the processing time. So how to address such an issue?
Scheduling increase by contention. And is waiting time for okay. Okay, so yeah, that's a question. Because a simple data dependence can be resolved by clever scheduling algorithm, but usually contention time occurs when, like, if multiple loops are executed in parallel in pipeline, you have a buffer or memories, and if a previous loop generates data in the buffer and the buffer is full, the previous process or loop have to wait until the buffers have a vacant spaces. That kind of things usually, maybe you allocate many buffers and you just reduce necessary buffers. So you have to check what contention is occurred and using time chart, or you have to analyze it. A simple case, it's kind of contention time is reduced. But if it is not satisfactory, you have to analyze the reason. Like, yeah, maybe.
Yeah, thank you for the answer, Professor Kensu. I hope it answered the question, Mr. Muhammad Iqbal. And unfortunately, due to time constraint, we must conclude our session today for the keynote session. We will continue to the next session, but before we finish our session, on behalf of the organizing committee of ICRAMET, I would like to sincerely thanks Professor Kensu Seto for joining us today and for delivering his talk. I think we can learn a lot from your talk. It was very interesting talk. And again, on behalf of the organizing committee, we would like to present a token of appreciation for Professor Kensu Seto. Thank you very much for your time, Professor, and hopefully we can gain some collaboration or have future communication with you. I hope you don't mind. And thank you again for your time. Thank you, Professor.
Thank you for listening and the questions, and I'm very glad to collaborate. So please let me know. Yeah. Thank you so much.
Thank you, Professor. And with this, I would like to conclude our session, and hopefully everyone have a good time and a very meaningful discussion today. Thank you, everyone, for participating. So I'd like to return the session to Miss MC, Miss Adita. Thank you.
Thanks to Dr. Natalita Maulani Nursam. Also, thank you to Professor Kenshu Seto. Now we are going to start the parallel session. Parallel session of 9 will start in breakout room 1, parallel session 10 in breakout room 2, and the parallel session 11 will be held in breakout room 3. As usual, for presenters, I would like to remind you several things. First, to keep the naming convention according to the guidelines, so our host can monitor if any presenters are placed in the incorrect rooms. Also, we encourage you to keep logged on even during the breaks. For the presenters that are in their assigned sessions, please turn on the video for the whole session, including when you are not presenting. Next, please be reminded it is compulsory for presenters to be present at their respective question and answer sessions. Do not forget to fill in the attendance form as the presenter when you are in your own session. And last, please have your presentation slides ready for the question and answer sessions. Also, for all the participants who want to ask some questions during the Q&A, please use the raise hand menu that can be accessed from your Zoom application. The last parallel sessions of 15 to 18 will start both at 1 p.m. GMT plus 7 after the lunch breaks in both breakout room 1 and 2. Please enjoy the parallel sessions.
Good morning, everyone. Good morning, the committee. Is there anyone already joined this session from the committee? I would like to ask something, whether I can start now or there are previous something that the committee need to explain before to the participant. Hello?
Recording in progress.
Tolong ya.
Pak Gali,
Yeah.
we can start the session if
Okay.
the presenter is already joined the meeting.
Okay, so we start now. Maybe the committee will introduce me, or I should do it by myself. Mbak Vita, hello.
Okay. Yes, hello.
Yes. Will you introduce me, or I have to introduce myself, Mbak Vita?
Mas Gali, Pak Gali, please you can introduce yourself.
Okay, so we can start now the session now.
Yes.
Okay.
Yes.
Hello, good morning, everyone. My name is Gali Nugraha Nurkafi. I am from Research Center for Telecommunication, and today I will be your moderator. So in this session, we will have 5 participants here. The first one is Mr. Toto Bahtiar Palokoto. Second one is Mr. Muhammad Hamdani. The third is Mr. Van Pongho. The fourth, Mr. Tinova Pramudia. And the last one is Mr. Bakit Amin Adum. So everybody already in the room, isn't it?
Yes.
Okay. Okay, thank you. And we can start the presentation now. So there are simple rule here. We have total 15 minutes for the presentation and the question and answer session. And we will play the video for the presentation, except you have a problem with your video, and you can present it directly. So we can start for the first presenter. Please, Mr. Toto Bahtiar Palokoto. The stage is yours. Thank you.
Hello everyone, my name is Toto Beater Palokoto. I'd like to present our research called a comparative study in machine learning aided flow traffic generators. This research contains 5 chapters: the introduction, experiment accelerator, method implementation, analysis and result chapter, and then the last one is the conclusion. Traffic generators have become a research topic in recent years. It can be used for testing several network schemes before the deployment. The first study that I mentioned here is an application-level traffic generators with simulating the network traffic when an application is running. This research was using long short-term memory, or that we call LSTM. It shows that LSTM can work well to imitate the traffic generated by an application. The problem is they're using packet capture file, which is having a considerable amount of storage space. If we compare it to our research, a flow-level database is using less storage space. The second study was using an exact database traffic generators that make use of the IP Flow Information Export or IPFIX database, which is quite the same as we use in this research. However, these traffic generators relies heavily on the traffic database. This is problematic if the traffic database is incomplete or unavailable. By using a machine learning algorithm in our research, the problem with database availability can be compensated. So the question is, which machine learning algorithm that should we use? Our study will provide a glance answer. This paper compares traditional machine learning methods, such as linear regression, supervector regression, and Gaussian process regression, and deep learning methods using long short-term memory. One of the important parameters in deploying an algorithm is the execution time. It will determine how good or expensive the computing power that needed. The root mean square error, or RMSE, value provides a straightforward assessment of error in a real-world implementation, which is essential in building a traffic generator model to generate accurate values and further address any outliers. Furthermore, this paper provides a visual representation to ensure that its models follow the pattern of the actual traffic. The IPFix database is acquired through the utilization of complementary visual filter traffic grabber free type version, which import web scraping flow level traffic from the PRTG application at 15-minute interval. 15-minute interval is subsequently aggregated into an hourly traffic data. In this analysis, 3 data input are utilized to forecast one future output. The method or algorithms that mentioned earlier is applied in the method implementation. The parameter mentioned earlier is calculated in the parameter calculation. Linear regression estimates one or more independent variable with a dependent variable. Linear regression is defined by the following formula. Linear regression forecasts time series data, which is y, predictor variables, which is x, with beta as the slope, c as the intercept, and epsilon by the sample. Using all the functions, the mean and the variance are calculated to forecast the result, where y is the observed output vector, f is the unobserved true function, and bracket x means that f values of 0 because of the normalization process, and k is the kernel function. Support vector regression, or SVR, is supervised machine learning that uses the kernel to characterize the relationship between input and output to find a hyperplane with the maximum number of data points, where k is the kernel function, alpha is the optimal value for SVM, and b is the bias. The deep learning algorithm that we use is LSTM. LSTM is more efficient and in processing and predicting data based on a certain time sequence. LSTM algorithm can remembering and deleting old data that is no longer relevant. LSTM itself is a complex algorithm that I don't think I can explain it in a short time, but it generally have a lot of function that displayed in the left side of the slide, where there is a for get function, input get function, output get function, cell input activation vector, the cell input vector state, and the last one is hidden state vector, that also known as the output vector or LSTM unit. The W, U, and B here are the weight matrix and bias vector parameters. All of the methods that implemented were using Keras and sklearn library from Python programming language. To calculate trend and predict time, we're using time library from Python. Experiments were conducted in a computer equipped with the Intel i7 11 Gen and NVIDIA 3060 Ti. RMSE is obtained by calculating the difference from the predicted data, which is P, and the test data, which is T, using this formula where N is the number of observed data. The visual representation was using Matplotlib library from Python. Traditional machine learning algorithms such as LR, GPR, and SPR typically demand a faster training time compared to LSTM methods. Among these traditional methods, LR shows the best RMSE result. All of the traditional model above has faster prediction time compared to LSTM because of their less complex algorithm. GPR takes longer time to train because it generates numerous functions to fit the data sample. LR, on the contrary, has the shortest time training and prediction time because it uses an equation model that requires less complex computation. According to RMSE value, training time, and prediction time, linear regression shows the best result compared to the other traditional machine learning methods. The LSTM method has the lowest RMSE of 0.13, but it also requires the longest training time because of the complexity of the algorithm. Now we will take a look at the visual representation of each method. If we look at the low traffic shown here, the linear regression and Gaussian process regression showing a significant difference in the actual data and the generated data. On the other hand, LSTM and SPR showing less difference in low traffic. But in peak traffic, GPR and SPR far more significant difference comparing to LSTM and linear regression. Also, GPR and SPR generated data is showing a bit shifted to the right. We think that's the reason why the RMSE value of the GPR and SPR is higher compared to the LSTM and linear regression. Histogram of the model residual are also presented to provide additional analysis of the model. The residual are the difference between the generated data and the actual traffic data. All of the histogram shows normally distributed residual, but the LSTM residual histogram is particularly more symmetrical, with its peaks centered at zero value. This indicates that there is a relatively no bias in the model, and it's a good fit for the data. There are, however, a few outliers that deviate significantly from the distribution, which might affect the result of the prediction. The conclusion here, if the database cannot supply the traffic value within the next hour, based on the visual representation of any of the four machine learning methods described in this paper may be utilized for generating traffic data. However, based on RMSE value, LSTM proved to be the most optimal method with its minimal margin of error, but it requires a longer training period. On the other hand, linear regression is a viable option if the training time duration is important, even though it may have a higher RMSE than LSTM. In terms of visual representation of the traffic, all of the algorithms perform well, even though GPR and SPR have a high RMSE. So thank you. That's all from me. Thank you for your attention, and thank you.
Okay, Pak Toto, thank you for your presentation. So it's 9 minutes for the presentation. So we have about 6 minutes for the question and answer session. So everybody who wants to explore deeply about the research that has been presented by Pak Toto, please, you can ask it directly, or you can write it in the chat menu. So please. Is there anyone else? Anyone who wants to asking question here? If there are not yet a question, maybe see, okay, this is from Pak Agus Subekti. The question is it possible to use the proposed model for other traffic database? That's question from Pak Agus Subekti.
Okay, thank you, Pak Agus Subekti, and thank you for Mr. Gali. So the question is it possible to use the purpose model for other traffic database? I would say we only have we only use flow traffic database on this research, so we do not yet explore any other kind of database. But actually, in PCAP using packet capture, the LSTM is quite. We can be sure that LSTM can be used by using packet capture database, but in any other data.
Excuse me, I think you mute your mic, Pak Toto.
Okay. Hello?
Yes. Yes, we heard you now.
Okay, thank you. So if there is a research, if we using a packet capture database and combining the PCAP database using any other application, such as application from Windows using calendar or any other date and time parameter that can be used, but that kind of database is only using not using a machine learning algorithm. So I think that's my answer. The only database that have been used in this kind of research is LSTM, and that then the difference that kind of database is packet capture database. Thank you. I hope that's answering your question. I'm sorry.
Okay, so Pak Agus, is the answer is satisfied you? Okay, thank you, Pak Agus. And I think it's just about one question more. Is there anyone else who want to ask question to the first presenter? If not, I think I have a question for the first presenter, Pak Toto. You mentioned two things that make me interested. Actually, I PRTG user also, and you mentioned about the flow data. My question is, what variable may be related to the network performance that you pull from the PRTG? Or generally, can you explain? Can you elaborate what kind of data that you pull from PRTG and what the method that you use for pull this data? Thank you.
Oh yeah, so the most hardest part of this resource is actually making a program to pull the data from the PRTG. So in the PRTG we use a IP flow sensor that install in the router and in the local and in the what you call it, in the database center. Let's call it that way. Okay. So after that, the database is been pulled to the PRTG application. And actually, if we use only application free tier, we cannot utilize the data because it's only what you call it. There's an error and there is a date that we cannot use, and for as far as I'm concerned, we cannot use the data that's generated purely from PRTG. So we're using a web scrape application to scrape the data from our computer, and we take the data from PRTG, from this PRTG application that installed in the database. That's the okay.
Okay, I see. Basically, you use two methods for pulling the data, right? Actually, there are other thing I want to ask you, but the time is not enough, I think. Maybe we can talk someday about this. I am PRTG user and I utilize PRTG to some of my work also. So thank you, Pak Toto. And the next one, we are going to the second presenter. This is my friend, my colleague, Pak Muhammad Hamdani. Please, Pak Hamdani, the stage is yours. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, Bapak Ibu. Today I would like to explain about our paper. The title is On Modeling a Bottleneck Link Using DummyNet. We are from Research Center for Telecommunication BRIN, and our contributor is myself, Muhammad Hamdani, Rifki Fajar Giana, Ananda Kusuma, and Toto Bakhtiar Palokoto. Okay, for the guideline, the first one, I would like to introduce about the introduction. These two figure is represent this kind of the complex system of the communication and networks. The first one is in a CBT, which means the Indonesia cable-based tsunameter, and the second one is the autonomous vehicles. We know both this system is contain the complex system of the networks. So how to build and improve this kind of the system? The challenge is we have to reduce the cost between the CapEx and OpEx. And we also have to avoid the risk about the failure of the risk. And the third one is high available. We know if we want to build the new one system that complex, these three kinds of the points need to be achieved. And even during the improvement means there is a modifying the system, we have to achieve this kind of 3 points. The solution is we have to provide this system testing. So before we implement or deploy, we have to test the system beforehand. The first one we can do by the simulator, and the second one by testbed. But these two methods have the drawbacks and the benefits. The simulator itself, the benefits is low cost and scalable, but the drawbacks is difficult to associate with the external applications. But for the testbed, as we know, generally in physical, the benefits is easy to associate with the external apps, but the drawbacks is the low cost with only a small scale. But for the scaling up for the scalable one, it depends on the cost. So we try to introduce the virtual testbed in order to improve the physical testbed. We know the virtual testbed is running on the virtual machine, so we can scaling up the nodes or any network devices on the virtual machines. So the previous drawbacks can be changed to be the benefit. So hopefully this kind of virtual testbed can be used for future works. So beforehand, I would like to introduce about the bottleneck links. The bottleneck links is the smallest one of the traffic links. As we know, let's say we try to send the applications, send the data from Jakarta to Bandung, from node A to the node D, but in between the node A and D, there is several devices inside. And in real condition, this one is the ISP scope of work. And during the sending of the application, during sending the data, there is the smallest links, and it can be defined as the bottleneck links. And of course, between the A and D, there is a packet delay. So we have to measure that kind of packet delay. So the proposed method, we use the DummyNet. DummyNet is the software that's running on the free BSD, of course, with the BSD license, and it can simulate the traffic shaping or traffic bandwidth limiting, and also the delay. This system is using the queuing system. So when there is an input packet, the DummyNet will queue the packets and then pass through the packets, depends on the queue configurations. And we can also adjust the delay and the output packet, of course, with the bandwidth limiting as we configure, and also the delay. We also, before we configure the DummyNet, we want to know whether the DummyNet is good enough if comparing with the Mechatronics. So we create two configurations, but the first one is using the Mechatronics devices, the hardware one, and the second one is DummyNet with the software. And we compare 2 points. The first one, bandwidth accuracy, and the second one is packet delay. And the result is the bandwidth accuracy for the Mechatronics is better rather than the DummyNet. We send the packet using the iPerf, and the bandwidth accuracy for the DAMINet, both the downlink and uplink, seems to be better rather than the MikroTik. But unfortunately, for the packet delay, we found that the DAMINet is the worst one rather than the MikroTik. Even on the smallest traffic bandwidth limiting is on the 64 kilobit per second. And we tried to reconfigure the kernel frequency on the DAMINet. Since the DAMINet is using the FreeBSD operating system, we adjust the kernel frequency on the operating system itself from 100 to the 1000. And we found that improvement when we try to increase the kernel frequency. This one is on the until the 600, the packet delay seems to be improved. And we set the traffic target with the 2 megabit per second, and we inject the traffic and we check the packet delay. And it's found that there is many improvement for the DAMINet. Let's say from the 64 kilobit per second, before that it was the highest one, and now it can be improved to be mostly the same with the MikroTik. But on the higher bandwidth, on the 2 megabit per second, it's still the packet delay seems to be worse. About the downlink and uplink seems to be same. So the conclusion is DAMINet is suitable for emulating networks, links in a virtual testbed, especially in simulating bandwidth limiting. However, in the packet delay simulation, it still have a concern of the increasing delay during high traffic due to the kernel frequency and hardware performance. Our future work is we need to analyze deeply on hardware performance of server with several polling rate options in order to achieve appropriate link delay. Thank you.
Thank you, Pak Hamdani, for your presentation. Now we are going to the question and answer session. As usual, if there anyone who wants to explore more, want to know more about what have explained by Pak Hamdani before, you can write it in the chat. Oh, there already question from Pak Muhammad Iqbal. The question is, do the MikroTik and DAMINet utilize same or similar queue algorithms? Because maybe was the reason why the performance result didn't match with each other is about the algorithm used in both aspects. Okay, please, Pak Hamdani.
Okay, thank you, Pak Muhammad Iqbal, for the questions. Okay, for the answer is actually it was same. It was using a FIFO algorithm, first in, first out. So between the MikroTik and the DAMINet, the queuing system is same. As we have presented before, the bandwidth limiting, particularly in bandwidth accuracy, is better, and the performance that we still didn't achieve is on the packet delay. Because on the in MikroTik itself, maybe the hardware is already designed for the network itself, but in servers, let's say that we use virtual machine under the firmware, it's still not special use for networks. So it's maybe the difference that we have to still need to investigate. So let me summarize the algorithm, and the queuing system algorithm is actually same. Yeah. Hopefully it was answered the questions.
Okay, thank you, Pak Hamdani. Pak Muhammad Iqbal, how is it? That already answered your question? or you need more explanation? Okay.
Thank you, Pak.
Thank you, Pak Muhammad Iqbal. Okay. The next question. Is there anyone else who would like to question something?
Excuse me, Mr. Galip. Maybe I'd like to ask some question to Mr. Muhammad Hamdani.
Yes, please.
So, Mr. Hamdani, you mentioned that your conclusion is because the hardware performance on the MikroTik. So, do you have any hypothesis if you use another hardware or another kind of MikroTik, what would happen? What do you think would happen? Thank you.
Yeah, thank you, Pak Toto, for the questions. Yeah, previously we actually our goals in our paper is not comparing between the MikroTik and the Daminet, but the goals is to present the what is it, the real conditions in if we implement the systems. Let's say we use the ISP that contains many router and switch devices that many variants of brands, and we try to represent in one system, which is in this one we use the MikroTik because the MikroTik itself has the capabilities to traffic shaping, and this one the device that we have currently, and as we know, there is another hardware brands that have bandwidth limiting capabilities, but currently we are just only have the MikroTik, and since the MikroTik have these capabilities, we try to mimic the system with the, let's say, on the real condition, real implementation in a CPT, let's say, and we try to compare between this system is can be present in Daminet or not. Is it Daminet can mimic the same as the MikroTik? If the result is same or better, so we can conclude that the Daminet can use to virtual testbed, and as the result for the current result, we confident that the bandwidth limiting process can be used on the Daminet. But for the packet delay, we still need to investigate. And if you ask about the change the hardware itself on the firmware or on the server for the Daminet, we still not sure, since if we comparing with the MikroTik or another network hardware is special hardware that used for the network itself, network only, I mean. But you know, the servers is not only for the network capabilities, but many applications that can run on the server. So our hypothesis is still on the hardware itself. Yeah, if we comparing, let's say we use FPGA to build such kind of the same capabilities as the network devices, another network devices, maybe it will be better. Yeah, thank you, Pak Toto.
Okay, thank you.
Yeah, hopefully it answers.
Okay, thank you, Toto, and thank you for Pak Hamdani for your presentation and question and answer session. So we have to going to the next presenter. The third one is Mr. Van Quang Ho. So, Mr. Van Quang Ho, the stage is yours. Thank you.
Yes. Welcome to my presentation entitled Influences of Random Estimation Error and Energy Converging Non-Linearity on my monoma. My name is Van Quang Ho from Ho Chi Minh City University of Technology, Vietnam. Here the outline of my presentation. First, I introduce the motivation of our work. Then I present the proposed system model of my monoma with carbon energy. Then I present the outage analysis. Next, I present result and discussion. And finally, I conclude my work. Emerging wireless applications provided by 5G and 6G network had the potential of satisfying the demanding communication requirement of a large quantity of users. However, they impose challenges related to sufficient allocation of bandwidth and power resources. Therefore, solutions to improve both spectral and energy efficiency have become imperative. The NOMA improved spectrum utilization and efficiency. Also, radio frequency energy conversion tap into the RF energy available in wireless system can improve energy efficiency significantly. There are two models for energy conversion. The first one is linear and the second is nonlinear. However, the energy conversion circuits consist of nonlinear components such as diodes and transistors. Therefore, nonlinear energy conversion is more radical. Also, channel state information play an essential role in optimization of system design and performance in wireless communication. However, obtaining perfect CSI is challenging. Therefore, it is essential to evaluate the influence of channel estimation error on wireless communication network performance before implementation. Let's consider the system model where ET stands for energy transmitter, IT information transmitter, FR file receiver, and NR near receiver, and all users have multiple antennas. And the communication is divided into two phases. The first phase for energy conversion and the second for normal transmission. And IT, however, energy is signal broadcasted by ET. The deployment of innumerable antennas of ET and IT have to enhance NES efficiency. Also, various antennas as IT enable spatial multiplexing, leading to increased data rate. Furthermore, antenna array processing techniques such as zero-forcing decoding can be employed at multiple antenna receivers to mitigate outage probability. However, the performance of the proposed system model under nonlinear energy conversion and channel estimation error has not been evaluated analytically. Therefore, the paper proposed such performance assessment in terms of system proportion and outage probability. In this system model, it supplies power for the operation of IT in the first phase with a time portion alpha of transmission block T. And IT carry out normal communication to FR and NR in the second phase with the rest of T. We consider the relay fading channel. And in the first phase, energy available at IT is given by this, and IT transmit the power in the second phase like this one. And this power represents the nature of nonlinear energy conversion. In the second phase, IT transmit the normal signal to FR and TNR. Therefore, the receive signal as FR and NR is given by this, where GV is the noise. We model the channel estimation error as this one, where Q has represent estimated channel and Q represent the real channel and S denote the channel estimation error. To stay message decoding is applied, where the MIMO decoding is proceeded in the first phase for recovering NOMA message, and the NOMA decoding is conducted in the second stage for restoring personal message. For the MIMO decoding, we illustrate with zero forcing decoding, and it's multiply the receive signal by the time. Therefore, zero forcing decoding decouple receive signal into MI message sequences like this one. And from this, we can recover the personal message for FR with this SINR. And also, NR firstly recover FR data by proceeding TNR as noise with SINR like this, and TL with SNR like this one. In this work, we analyze both outage probability and system throughput in terms of in low form under channel state, channel error estimation, and nonlinear energy convention. We model channel estimation error as this one, where gamma D represents the percentage of channel estimation error, and we use the parameter to illustrate our result. The first result plot outage probability versus the transmission power of ET, and it shows that exact and asymptotic analysis coincide respectively simulation over the whole region of BE and the log BE, verifying the preciseness of the ROPO formula. And this figure also shows that NLES matches LES for small BE, and OP for LES subsists practically though for NLES SBE in research. The second result shows the throughput versus gamma, and we see increasing gamma reduces the throughput significantly. However, the system throughput improvement with upgrading the number of antenna. This figure shows the throughput versus beta, and the ST of NR is raised while ST of FR rises with rising beta. Also, ST of the ROPO system is radically higher than that of the reference, that means orthogonal system. And also rising the quantity of antenna as the receiver ameliorate the system throughput. Next figure shows the throughput versus FR, and we see both ROPO system and the preference system reach maximum ST for alpha to be optimally selected. And the predominant of the ROPO system in comparison with the preference one, and the ST improve with rising MP. Next, we saw the outage probability versus C, and we see the performance of the receiver improved considerably with increasing power saturation record, and the ROPO system with nonlinear energy convention suffer outage saturation for large C, and the performance improvement agree with the number of antenna. Here, the conclusion of my work. The paper presented a comprehensive analysis of the system throughput and outage probability for ROPO MMNOE under radical operation condition. The analysis considered the effects of NLES multi-antenna user and the CE on the performance. The non-linearity of the energy convention and CEE considerably degrade system performance. The target performance is achieved flexibly and possibly by the drop of parameter. And the ROPO system can avoid a total outage with proper selection of parameter and obtain the best performance with optimum selection of this parameter. Also, the performance is radically improved with increasing the parameter. Finally, the proposed system is superior to traditional driver. That is the end of my presentation. Thank you for your listening.
Thank you, Mr. Van Quang Ho. So as usual, we are going to the question and answer session. So please, anyone who have a question for Mr. Van Quang Ho, please, you can raise your hand or you can write your question in the chat menu, please. Thank you. Okay, so if there are not yet anybody ask a question, I have
Mr. Gal.
Yeah. Oh, please, Pak Taufik.
Thank you.
Please.
Thank you for the. I just want to ask one question for the Mr. Fan. In the implementation, what kind of devices that he used? Thank you.
Yes, thank you for your question. Actually, we just do simulation and analysis. We haven't implemented the system, the real system, yes.
Okay, so you are conducting the research by using a simulation, Mr. Fan?
Yeah, yes.
Okay, noted. Thank you. Pak Taufik, is that answer your question?
Yes, thank you.
Okay, thank you. Okay, maybe the other one, please, if you have a question. Actually, I'm not so familiar with the field that you conduct the research. So maybe I will ask some basic question to Mr. Fan. Okay, this is my question. So how does scavenged energy differ from the traditional energy harvesting methods? Pardon me if this is so basic. Thank you.
Yes. Yeah, thank you for your question. Actually, we apply some mathematical model for the energy conversion. So the energy conversion can be implemented by transfer the radio frequency signal into the DC signal. And then we use the energy stored in the battery to power the communication. So it uses some kind of resonance circuits and some rectifying circuit to convert RF signal to the DC energy.
Oh, okay. Thank you for your answer. And may I ask one more question? Or maybe another one?
Yes, please. Yes, please.
Anyone? If not, I will ask one question more. And okay, this is some other basic question again. So actually, what is the challenge and the integrating the scavenged energy with MIMO and NOMA, as you mentioned in your presentation?
Yeah. So in our work, when we implement the MIMO, then the problem that we have to know the channel state information to detect the signal perfectly.
To detect signal perfectly.
Yeah, perfectly. However, to get that information, we need the good channel estimator. That means it can know exactly what is the state of the channel. However, in the real life, any channel estimation algorithm has some error. So that's why we need to care about the effect of the channel estimation error on the performance of the system.
Okay. So it's more clear now. Thank you very much, Mr. Fan. And there is one more question from my colleague, Pak Dayat. Please, Pak Dayat.
Okay, thank you, Pak Khalid. I want to ask maybe a basic question. Is it possible to implement sparse code multiple access? As I know, sparse code multiple access is one of NOMA. It's possible sparse code multiple access to implement in your research? That's my question.
Yeah, I think your question is almost the same as the question from the first presenter. So we can implement in MIMO in the real system. Actually, some mobile communication system, they had the configuration of 16 by 16 MIMO for 5G or 6G network. But in our work, we haven't concerned about the real implementation. We just focus on the performance evaluation first by using the simulation, and after we successfully verify our system by simulation, then we can move to the next step for the real implementation. Is it clear for your question?
Yeah, I think in my mind, NOMA is have two types, base code and energy base, right?
Oh, sorry.
NOMA has two type of two kind of NOMA. One is base code. Base code is like sparse code multiple access, and the second one is energy base.
You mean MIMO had two advantages, right? One is the kind of multiplexing gain, and the other is the diversity gain, right?
Oh yeah.
That's what you are mentioning.
Yeah, I mentioned about implementation SCMA, sparse code multiple access to energy harvesting. Yeah.
Okay, I understand. So implementing the MIMO, there's so many configuration. Like if you want to explore the diversity gain, that means if you want to improve the performance with respect to the number of antenna, you can use the kind of space-time coding, as you mentioned, right? But in our work, I want to explore the multiplexing gain to increase the data rate. So we transmit the information in parallel. That means instead of transmit one information stream, we get the data rate R. Then if we transmit multiple data stream, then we get the n time data rate of the as compared to the conventional communication with the single antenna.
Yeah, okay. Thank you, Mr. Tan Quang Ho.
Yeah, thank you for your question.
Okay, thank you, Pak Dayat, and thank you also for our presenter, Mr. Van Quang Ho. Thank you for your time and thank you for the fruitful discussion. And we are going to the next presenter, the fourth, Mr. Innova Pramudia. So the stage is yours, please.
Hello everybody. Assalamualaikum warahmatullahi wabarakatuh. My name is Innova Pramudia. I will present work of our team, transmitter and receiver design for visible light communication system with off-the-shelf LED towards its implementation possibility for vehicle-to-vehicle or vehicle-to-infrastructure communication. This presentation contains 4 sections. First, introduction to system design, then experiment result, last is conclusion. First section is introduction, spectrum grounds, is one of the challenges that arise as a result of the growth of radio communication technology due to its limited spectrum availability. Visible light communication is a solution of the problem above by using light-emitting diode LED to transmit data and photodiode to receive the data. VLC has a great potential for use because of its speed and broader spectrum. In this research, we present a simple VLC system using off-the-shelf market LED with a bitrate 1 megabit per second while changing the distance up to 200 centimeters. Moreover, the transmitter can be used for the LED up to 100 watt, enough for the higher power LED such as automotive headlamp or road light. We hope this simple VLC help to rapid implementation of VLC in vehicle, especially autonomous vehicle or electric vehicle that generally use digital communication as maybe CAN bus. First section is next section is system design. This is LED that we use off the shelf market LED Crispo 10W COB 3000K, and this is voltage current characteristic graph of the LED that we use. This LED has voltage current linear region above 26 volt. The brightness of the LED is directly proportional to the current flowing through the LED. Since the input signal is voltage based, so we need to our signal around linear region. Therefore, biasing is needed to ensure the voltage that LED received is within this linear region. To achieve this condition, a non-inverting summing amplifier is utilized. This is circuit of our transmitter, and this is equation of transmitter that we use. By inserting value from the table, we get final equation like this. We call output of summing amplifier is VG. Therefore, however, the op-amp operation amplifier does not have enough current to power on the LED, so we need MOSFET with a common drain, or we call source follower configuration, to power on the LED. This is equivalent circuit of common drain configuration, and this is its equation. This is final equation of voltage gain of following MOSFET. As we can see, the higher value of GM and Z out, the gain of the MOSFET is near to 1. Next is system design of receiver. This is circuit of our receiver, consists of trans-impedance amplifier, high-pass active filter, and comparator. Trans-impedance amplifier is convert current from the photodiode to a voltage, and then high-pass filter will block DC bias and low noise signal from ambient lights. Yeah, usually around 100 and 120 hertz. It depends on the country. Next is comparator. The output of comparator we name it VO2. Is 3.3 volt when VO1 is higher than Vref. Otherwise, the value is 0 volt. This is next section, experiment result. This is response frequency of transmitter, just transmitter. From the graph, we can observe that cutoff frequency for VG is 14 megahertz. Cutoff frequency of VLED is 2 megahertz. The difference is because of LED that having high internal capacitance that reduce the response frequency of the system. And this is signal transmitter captured by oscilloscope. Channel 1 in voltage input, channel 3 is VG, channel 3 is VLED. From minimum, maximum, and amplitude value of VG and VLED, we can calculate its ratio, their ratio. Ratio of this condition is 0.9, so we can calculate that gain MOSFET of source followers MOSFET is in this system is 0.9. It close to 1 as next is experiment result from frequency response transmitter and receiver combined. We can see that cutoff signal at 50 centimeter is around 1.7 megahertz. For the other distance is 0.5 megahertz. To increase the distance, we can increase the gain of the amplifier at receiver side or use higher power LED at transmitter side. Next is transmit data without Manchester encoding. Let's focus on blue signal. The VOUT1 signal before comparator. As we can see, at 100 centimeter, midpoint value is negative 1.72 volt. At 200 centimeter, midpoint is negative 0.95 volt. The value of Vref must be around midpoint of the signal. In this case, when the distance is changed, we need to reset Vref of the comparator. This is not applicable for V2V or V2I, where the distance is changing from time to time, vehicle moving. So it's not applicable. Next is a signal transmit with Manchester encoding. As we can see at the blue signal, the midpoint is around 0 volt. Yeah, this is 0 volt. So we don't need to reset or changing the value of Vref, just stick at 0 volt. So this condition, we can implement a system to a vehicle. Next is experiment result. This is the transmission test with baud rate 1 million, and this is system delay for our system around 3 microseconds. Conclusion: this VLC system able transmit data with bitrate 1 megabit per second with distance 200 centimeter. Enough for short range communications such as parking gate or maybe charging station or toll gate. By utilize this MOSFET, we can use higher power LED. By employing Manchester encoding, this is possible in scenario involving varying distance, especially vehicle communication. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh, Mr. Tinova. Thank you for your presentation. Okay, I think we just have time for one question for the fourth presenter, Pak Tinova. So I will give you a chance for one participant to ask question. So please, is there anyone who would like to ask something to Pak Tinova? Okay, then maybe I can ask one short question, because you mentioned about this experiment actually will be used further for the vehicular communication. Am I right?
Yeah, you're right.
Okay, so the experiment itself resulting that the Livy communication result 1 Mbps and 200 centimeters distance. So is there any movement that you plan for the next experiment, maybe? Because this is one static, isn't it?
Yeah, we actually literally right now, we're planning to use automotive headlight, car light for our experiment because our goal is for V2V and V2I, and using another maybe such as FDM to improve the speed and higher quality of photodiode with lower capacitance to increase the data rate.
Okay, so the headlamp of the car is have a more power than the device that you use in this experiment.
Yeah, of course.
Okay, so there will be a different result, of course. So thank you for Pak Tinova for the presentation, for the discussion. Very interesting. Wi-Fi for vehicular communication. So we move to the last presenter. We have Pak Bakit Amin Adum. So the stage is yours, sir.
Good morning to everyone. My name is Bakit Amin Adum, and I'm from Chad. Today, I would like to present our research paper entitled Federated Meta-Learning for Task Offloading and Resource Allocation in Mobile Edge Computing for Internet of Things. These are my partners. I have divided my presentation into 5 sections. As you know from the literature, meta-learning and federated learning are not new, but recent advances in gradient-based optimization bring them back into a spotlight as promising solution for faster learning. Young et al. Investigated a task offloading mechanism based on federated reinforcement learning in mobile edge computing. The algorithm's effectiveness were determined by evaluating model laws at different learning rates to determine the change in learning laws. But this algorithm requires training from scratch. In order to avoid training from scratch and to determine the customized models for heterogeneous data set, meta model is adopted to overcome the statistical heterogeneity problem encountered in federated learning. The researcher Finn et al. Proposed a gradient-based algorithm called model agnostic meta-learning, which directly optimizes learning performance over model initialization. Another work proposed by Liang et al. Proposed a meta-learning basic task offloading algorithm that trains a general deep neural network for different make task scenarios and can quickly learn to adapt to a new task. This algorithm addresses the limitation of federated learning but requires the transfer of all data, resulting in the disclosure of personal data. To overcome this limitation, a federated meta-learning was implemented and quickly became the subject of some research. It should be noted that not all of this work addresses task offloading and resource allocation at the same time in the context of mobile edge computing. So generally, the previous solutions are innovative. Task offloading and resource allocation in mobile edge computing based on federated meta-learning have not been demonstrated. In this research, we propose a solution for task offloading and resource allocation in mobile edge computing for Internet of Things using federated meta-learning. We can recall that federated meta-learning is a machine learning technique that allows multiple devices to learn a shared model while keeping their data locally. This is done by sharing knowledge from one device to another without actually sharing the data. Federated meta-learning can be used to enable joint resource management in mobile edge computing in the following ways. It can be used to select a subset of devices to participate in the joint resource management task. This is important because not all devices have the same resources or capabilities. So by selecting the best device, federated meta-learning can ensure that the joint resource management is performed effectively. It can also be used to allocate resources to different devices participating in the joint resource management task. This is important because different devices may have different resource requirements. By allocating tasks in the way that is fair and efficient, federated meta-learning can ensure that all devices are able to participate in the task and that the task is completed effectively. It can also be used to schedule tasks to different devices participating in the joint resource management. And this is important because different tasks may need different resource requirement. By scheduling tasks in the way that is fair and efficient, federated meta-learning can ensure that the task is completed on time and that the resource is used, in the most optimal way. In addition to this application, federated meta-learning can also be used for other type of application in the mobile edge computing, such as load balancing, caching, and security. In our case, we consider a system with a local mobile edge computing server. The local mobile edge computing server are placed at the user periphery. There are also a subset of IoT devices. Each IoT device has a task that is assumed to be atomic, that means cannot be divided. Tasks are executed locally or downloaded from the local mobile edge computing server for processing. The unloaded task is processed by the central processing unit. The task requiring unloading must be transmitted to the central mobile edge computing server and processing. To avoid bottleneck at the local mobile edge computing server level, each server is only responsible for a certain number of IoT devices, where a generalized model is obtained after aggregation to enable new users to use the model directly, thus reducing the learning time. If your local mobile edge computing server obtained, it is global model. The process is iterative until the better model is found. for more collaborative and to have the same high performance model for all devices. The general model obtained is then sent to the central mobile edge computing server to obtain a general model after a global aggregation. The generalized model obtained is then sent to the local mobile edge computing servers, which is in turn dispatched to IoT devices. The learning processes for finding the meta model on each IoT devices will be based on the notion of model agnostic meta learning, as it has a number of similarities with federated learning. The algorithm is simulated and several tasks are carried out. The aim is to vary the epochs and the numbers of customers. We can recall that an epoch is the number of times the algorithm sees the entire data set. Each time the algorithm has seen all samples in the data set, the epoch is completed. So in our case, the algorithm is evaluated using the MNIST data set, where 50% of the data is randomly selected for training set, and the remaining data is used for the tester set. Each IoT device divide the data set into a support and a carry a set with a support set containing only one sample example for each class. So here in this figure, we have the accuracy considering 5 epochs. So the result of the local meta model of each IoT device with a different iteration show that the accuracy continues to increase during the first iteration and then gradually becomes stable. As each model needs to be iterated for 5 rounds locally, the meta model for the batch of 50 customers only needs 50 rounds to complete conversions. By varying the epochs to 5, 10, 15, and 20, we observe that the epochs variation does not impact the models. So the model agnostic meta-learning algorithm allows rapid generalization. So we don't need to go to several epochs to decide. Here we have the losses considering 5 epochs. The losses, you can see that the losses decreases to 30.3% during the training phase and 29% during the test phase. With 100 customers, the losses decreases to 38.8% during the training phase and 36% during the test phase. With 150 customers, the losses decreases to 45.5% during the training phase and 43.4% during the test phase. Since losses are an indicator of performance, increasing the numbers of customers will increase the losses in both the training and the test phase. This slide deals with the time consumption by varying the number of customers. The time consumption of 50 customers is much less than that of 100, 150, and 200 customers. Due to system overload, the time consumption with 50 customers consume less, which is within our expectation. It can be observed as the number of customers increases, the algorithm requires more time to compute the different training rounds. This slide compares our algorithm with the existing models. These comparisons reveal that the proposed models predict the performance with more accuracy than the existing models. So in this research work, this study presented a solution for task offloading and resource allocation in mobile edge computing for the Internet of Things using a federated meta-learning approach. The paper introduced the FedMeta-D algorithm, which leverages federated meta-learning to optimize task offloading and resource allocation decision for Internet of Things devices. The algorithm's effectiveness is evaluated using the MNIST dataset, and the results indicate improved performance in the test phase compared to the training phase. The advantage part of the proposed approach is that it allows us to learn from the experience of all IoT devices, resulting in more robust and accurate models. Considering 20 epochs, the accuracy during training is 91.5% against 92% obtained with the tested data. In addition, accuracy continues to increase during the first 10 iterations and gradually becomes stable. Moreover, the performance evaluation involved the comparison of the proposed approach with the existing model methods. This comparison reveals that our approach predicts the performance with more accuracy than the existing models. This approach can effectively fulfill the demanding performance of wireless communication. Thank you for your attention.
Thank you, Mr. Bakit Amin Adum, for your presentation. So we just have time for one question only for this session. So please kindly ask question for any participant here. So please. Is there any question? So if there are no questions, I will ask one question to Mr. Bakit. So I'm really interested about the MEC offloading schema here because in several papers that I read about the vehicular communication and Internet of Vehicle, the role of MEC is really important. So you are utilizing federated meta-learning to manage the data and task offloading to all infrastructure and adopt the MEC for this schema. So actually, I would like to know what is the background for the MEC offloading schema using the federated meta-learning. Is there any other method for doing this task offloading and that offloading schema? Thank you. Mr. Bakit. Mbak Vita, is there?
Yes. Apparently, Mr. Bahit is not here yet.
Okay.
He has trouble with the
I see.
internet. So maybe Pak Nasrullah Army can help to answer. Or we will forward the question to Mr. Bahit later.
Oh, okay. So previously, Mr. Bakit is already present, but he has some trouble with his connection. So he's now disconnect again.
Yes.
Okay.
We are sorry for this.
Okay, no problem. Thank you for your information, Mbak Vita. So is Mr. Nasrullah Army can represent Mr. Bakit for answering this question? If not, as the Master of Ceremony suggests that we can forward this question later to Mr. Bakit. So Mbak Vita, maybe if there are no question and answer session for the fifth presenter, we can close the session, right?
Yes. Okay. We can close the session because it's already limit. The time is already. Yeah. Okay.
So it's behind the schedule, right? Okay.
Yeah.
Thank you, everyone. Thank you, ladies and gentlemen, for your attended in this session. Thank you, especially for Mr. Toto Bahtiar, Pak Hamdani, Mr. Fan, Pak Tinova, and not forget Mr. Bahit also. Thank you for all discussion here. I hope that we can meet again in another occasion to discuss further about many research and technology that involve in many field that already discussed in this session. Maybe one session is not enough for understand that many research that has been presented here. And once more, thank you. And I will give back the stage to Mbak Vita. Thank you, Mbak Vita. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you, Mas Karis.
We are really behind the schedule, isn't it, Mas Dayang? So you should start at 10:35 actually. Pardon us.
Okay. Okay. From the committee, we can start the session now. Mas Dayat can start the session now. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Indra Kurniawan, as a moderator in this session. This session will talk about related with control system, mechatronics, and robotics. We have all excellent presenters from University Merdeka Malang and BRIN. Before we continue to our discussion, let me check our presenter. For the first presenter, Pak Bagus Martinus, are you there?
Yeah, I'm here.
Okay. The second presenter, Ibu Astri, are you join with us?
I'm here.
Okay. Third presenter, Bapak Muhammad Adityo.
Yes, I'm here.
Okay. And the last presenter, Bapak Eka Mahendra.
Yes, I'm here.
Okay, I think all presenter already joined with us. So let's start with first presentation. Will be presented by Bapak Bagas Martinus. Bapak Bagas Martinus, please stand yours.
Assalamualaikum warahmatullahi wabarakatuh. From greeting and good morning for everyone. I'm Bagas Martinus from University of Malang. Today I will presentation our paper. The title is Hand Gesture Recognition Based Control System using Computer Vision for Transport Robot. Me as a first author, and Professor Atio Kitagawa as a second author, Pedikantara STMT as a third author, and Senior Sibari STMT 10 as a fourth author. Today I have a four table of content. The first introduction, second material and method, third result and discussion, and fourth conclusion. Okay, the first content is introduction. We know that currently the world has entered the era of Society 5.0 from the industrial era 4.0. This is evident through the role of human in harnessing for technological innovation available today, like AI, IoT, robotic, and many things. Control systems are one of the aspects in the field of robotics that are significantly influenced by the changing era. Creating control system for a robot that are more accurate, user-friendly, and as intuitive as possible. One form of experiment in control system in the field of robotics is the use of hand gesture as a method of human-computer interaction. The combinating of hand gesture and computer vision has become one of the technological innovation in control system. Okay. The second content is material and method. This research involves many previous studies that have been proposed and published in journal form as references in this research, including first from research by R. Vasavi and et al. In the title Painting with Hand Gesture Using Media Prep. The second from research by Haris Kumar and et al. With the title Gesture Control Robot Using Image Processing. The third from research by S. Nurbudiman et al. With title Pengenalan Gestur Gerakan Jari untuk mengontrol volume di komputer menggunakan library OpenCV dan Media Prep. The last from research by Ali Ebed et al. With title Python-based Raspberry Pi for hand gesture recognition. Okay, and the first computer vision in our research, we use computer vision method. The next media prep hand framework in our research, we use a computer vision method that utilize the media prep hand framework library. The next computer robot in our research, we use a transporter type robot as a medium for carrying all the command given. Okay, the next is block diagram system. We can see on the screen block diagram system for the research divided into two parts. First, handler mark system, and the second is transporter robot system. On the part of handler mark system, we can see hand gesture is input data which will later be captured by the camera and will be processed on the laptop using the media web library, and the data will be sent using the internal Bluetooth on the laptop. Then in the transporter robot part, the HC05 Bluetooth module a recipient of input data from the laptop and forward into the microcontroller, and in the microcontroller input data will be processed, which is then used to drive to this motor as wheels and servo motor as arm and claw on the transporter robot. And the next is schematic system. This is a schematic system of our research. We can see it on the screen. The camera capture hand gesture and the result of the camera capture are displayed on the laptop screen in the form of hand gesture, which function as data input are sent to the transporter robot. And we can see the detail part of the transporter robot. Okay, the next is flowchart system. Our research work system is divided into three parts. First, communication. Second, handler mark. Third, robot transporter. When the program starts, the Bluetooth on the laptop tries to connect to the Bluetooth module on the robot transporter. If the two Bluetooth are not yet connected, the Bluetooth on the laptop will continue to repeat until it is connected, and if it is successfully connected, the system will continue to the next section. The next section, the camera will try to read or capture on hand image. And they perform palm detection and the mark 3D hand key point on the palm. If the handler mark doesn't appear, the process will again detect the hand image. However, if the handler mark is successfully given, then the process will continue. The next is the process continue by identifying a handler mark for the right hand or left hand. If using the right hand, the finger of function will be applied and the data obtained will be used to drive a DC motor. If you use the left hand, the range gesture function will be applied and the data obtained will be used to drive servo motor, and this can be done repeatedly to move the transport robot as desired. Okay, the next is third part is result and discussion. We carried out two tests, and the first test handler mark for DC motor, and the second test handler mark for servo motor. And the first test is handler mark for DC motor. The purpose is to determine whether the right hand handler mark with the finger of function can control the movement of a DC motor, and the second to assess the effectiveness and efficiency in the term of delay. Okay, first I want to explain about the finger of function. On our research, the finger of function is used to generate a list containing number integer with line 5, which represents each detected finger on the hand. Based on this test, this element has a value of 0 or 1, with the 0 indicating the finger is not lifted and the 1 indicating the finger is lifted. And this is and the next is a 6 hand model on the right handler mark. The first is A model for forward motion, B model for backward motion, and C model for turn right motion, and D model for turn left motion, and the A model for rotating motion, and the last model is a stop motion. Okay, and this is a result for handler mark for this motor. On handler mark model, A is A forward motion, like I said before, as on the On this test, each list element has a value of 0 or 1, with 0 indicating the finger is not lifted and 1 indicating the finger is lifted. And the data input is 0, 1, 0, 0, 0, and the expected result is forward motion, and the test result on trial to 1 until 5 is success. So the all result for all the landmark hand model were successfully or 100% success. Okay, and this is the test which was carried out 17 times with a distance of 2 meters between the robot and the laptop from a distance of 2 meters until 34 meters. And from this table, it is found that the average delay is around 0.476 seconds, and at a distance of 32 until 34 meters, the input command cannot be sent. Okay, and the second test is hand mark for servo motor. The purpose is to determine whether the left hand mark with the range gesture function can control the movement all four servo motors. And second, evaluate the effectiveness and efficiency in terms of servo motor movement or degree and delay. Okay, the first I want to explain about the range gesture function. The range gesture function in MediaPipe hand enable to detection and recognition of various hand movement involving specific range or orientation of each key point. Determine two key points on the hand mark is used to define the range of value, length, or distance to be detected in pixel, utilizing the X horizontal and Y vertical value range of each predefined key point. And this value will later be converted into degrees. The input data in the form of degrees will be sent a microcontroller to be processed as an input command for each servo motor movement. Okay, and this is a model illustration of the left hand mark using the range gesture function. For example, to move servo 1, use the X value from the range of key point and mark number 4 and 2 on the thumb. And to move servo motor 2, use the Y value from the range of key point and mark number 8 and 5 on the index finger, and so on according to the table description. And this is a hand mark test for a servo motor with a total average error of 3%. And this is a delay test. The test method used is the same as the test for delay on the DC motor, but the result of the delay test for servo motor show 0.467 seconds, and at a distance of 32 under 34 meters, the input command cannot be sent. Okay, and the last is conclusion. And gesture recognition using the computer vision method with the utilizes of the MediaPipe framework has been successfully implemented as a control system for a computer robot. The first, the hand mark with the finger up function on the right hand use control DC motor with a success rate of 100% and average delay of 0.478 seconds. And the second, hand mark with the range gesture function on the left hand used to control a servo motor with a success rate of 97% and an average total error of 3% and an average delay of just 0.467 seconds. And that's all for me. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Bakas, for the presentation. Any other question? Yeah, Mr. Oka, please.
Okay, thank you, Mr. Jayak. Okay, I have several questions. The first is, do you need to be online or connected to the MediaPipe server to recognize the gesture? And if it can be run offline, does it need specific hardware requirements? For example, must use a powerful microprocessor like Jetson or like that, or can it be implemented on a slow microcontroller like Arduino Uno? And the last question is, are the gestures predefined or customizable by user? For example, we can create our own gesture like love gesture or something that not usual. Okay, thank you.
Okay, thank you for the question. Maybe this research, I think, is not need online device, and this is just media pipe hand in our research, just using library. We just input the library on the program, and maybe for offline, we can using Arduino Uno. Yeah, and maybe for next question for the hand model, maybe we can modify and we can combine any model hand model for the data for the robot movement. Yeah.
Okay, thank you, Mr. Bagas.
Okay, thank you.
Okay, there are any other question? No, I think one question is enough. So thank you for Mr. Bagas and Mr. Oka. So we move to the second presenter, Ibu Asri, please.
Hello, everyone. My name is Asri. I'm from Research Center for Artificial Intelligence and Cybersecurity, BRIN. Today, I would like to present a paper titled Transformer with Time Factor Representation for Remaining Useful Life Prediction of Lithium-Ion Batteries. As motivation, lithium-ion batteries are used in many electric devices such as smartphones, laptops, and other power tools. Since we use the battery continuously, their performance may decrease, reducing capacity and power, and the damaged batteries may harm the users. So it is important to monitor the remaining useful life of the battery. RUL is the duration of the battery lifespan until it reaches a threshold set at 70 to 80% of the initial capacity. The RUL is illustrated in this figure by the blue line. By developing an accurate RUL prediction system, users can have a scheduled maintenance to avoid unexpected failures. RUL prediction systems is developed from the battery charging and discharging cycles data. We use data-driven methods such as LSTM and transformer, and then the performance is evaluated using some evaluation metrics. There have been many deep learning models implemented for RUL prediction, such as CNN, DNN, and LSTM. LSTM is the popular one because they effectively handle time series data. However, LSTM also has a limitation. When the input sequence lengths get longer, it may result in vanishing gradients. So to deal with this limitation, we propose a method using transformer with time factor representation, or we call it time to fact, and exploiting the multi-source input data. We summarize our proposed method as follows. First, the original transformer method consists of encoder and decoder network with attention mechanism, but we modified the structure and we only use the encoder layer. We use the time to fact to capture the sequential order information within the data, because unlike the LSTM that has the ability to remember previous inputs for long period of time, it is not the case for transformer. Transformer requires information of time when processing the battery data. So we use time to fact to produce additional features representing time. Then third, we employed the transformer with multi-head attention instead of regular attention, because we use multiple data sources as the input to the prediction system. Our architecture of transformer-based method with time to fact for battery RR prediction is illustrated in this figure. First, the input sequence consists of the voltage, current, temperature, and capacity data from the battery data. Second one is the time to fact layer. So the time to fact is applied to the input sequence, producing the time features. And then this additional time features is concatenated with the original input sequence to be inputted into the encoder layer. The third one is the transformer encoder layer. This is to model relationship in the capacity degradation from historical battery data. This encoder layer comprises of multi-head attention and followed by the residual connection and normalization layer, and then the feedforward layer also followed by the residual connection and normalization layer. So we use the multi-head attention because it is suitable for the multivariate time series data. And the fourth is the output prediction. We implement the another one feedforward network for producing the prediction. We use battery data provided by NASA. This data is publicly available at the NASA website. We use 4 batteries from the dataset: B5, B6, B7, and B18. These batteries underwent the process of charging and discharging process. The battery dataset is pre-processed. We select the P, I, and T from the charging cycles, and we select the capacity data from the discharging cycles. We choose 10 samples for each PIT and a scalar value for the capacity data, forming the 31 dimensions of PITC. And since the PITC has different range of data and units, we perform a min-max normalization by converting the data into the range of 0 to 1. And then to create a labeled dataset like input-output pairs, we use a sliding time window approach. We use a sequence length of 5 to 10. Then we also perform the leave one out cross-validation with ratio 2:1:1. For example, if we use B18 for testing, then we use the remaining 3 data, B5, B6, and B7 for the training and validation. And this process is repeated 4 times, so we have the 4 test results. We perform LSTM and transformer model base. And for all models, we set the same hyperparameters as follow. So as we can see in the table, the structure of each model for LSTM, the input sequence is fed to the LSTM, and then 2 layers of feed forward, and then get the output. And for transformer, the input sequence is fed directly into the encoder layer, then average pooling, then 2 layers of feed forward, and then get the output. While for the transformer with time factor representation, the input sequence is first fed into the time to fact layer, and then when producing the time features, they concatenated into with the input sequence, then fed into the encoder layer, average pooling, 2 layers of feed forward, and then get the output. This is the results of aerial prediction using LSTM and transformer models. if we look at the graphical results here, a transformer with time to effect produce prediction more closely to the true values, especially for battery B6 and battery B18. Meanwhile, if we look at the table, the prediction error results shows that transformer with time to effect always better than the standard transformer without the time to effect. And in some cases, transformer with multiple heads better than the single head model. And from the results, we can conclude that the best model is achieved by the transformer plus T2P2 attention heads. We also investigate the performance of LSTM and transformer method in a longer sequence. If we look at the table, the result shows that when the sequence gets longer, actually the error rate also gets higher. This has happened for both models, but if we look at for transformer model, the MAPE value is consistently smaller compared to LSTM. Next, we also investigate the performance of LSTM and transformer on their model complexity. The number of parameters in LSTM is affected by the input size and the hidden nodes, while the transformer, the number of parameters is affected by the number of attention head and head size. At first, we only implement the LSTM with 32 hidden units. This LSTM has 13,000 plus parameters, which is not comparable with the transformer plus T2V2, which has the 27,000 plus parameters. So we employ another LSTM with 60 hidden units that has this 31,000 plus parameters. However, the results shows that having large parameters does not always improve the performance. And if we compare to the baseline LSTM, transformer plus T2P1 improve the performance by 13.4%. The transformer plus T2V2 improve the performance by 16.4%. And the transformer plus T2P3 improve by 11.8%. So in this case, the transformer plus T2V2 still has the lowest MAPE. To conclude, we have proposed a method using transformer with time to effect architecture exploiting multiple source input data, which are VITC for battery area prediction. We evaluated our proposed method using NASA lithium-ion battery datasets, and the results show that a transformer plus T2V2 has the smallest error rates, which improves the MAPE by 16.4% compared to baseline LSTM. For future directions, we would like to emphasize that while good performance is achieved in our results, their robustness has yet to be evaluated. That's all from me. Thank you.
Okay, thank you very much for this presentation. Any question from participant? You can type your question in chat box or raise your hand using raise hand function. No other question. I have one question for who Asri. Actually, I'm not expertise in AI or machine learning. I have a basic question, how to deploy your model in the real application or a real board. In my mind, you train a lot of data set in high-performance computing, and you get this result, you get this model, and how to deploy your model in the real application. Thanks.
Yes, thank you for the question. So yeah, actually we already implemented this model into the dashboard system using the Raspberry. So how we deploy it? After we train the model, we save the model into some like a pre-trained model. So we have the model saved into our computer. So that model we can call it when we employ it into the Raspberry. Then so we just test it with some other data call that model, because actually this model doesn't have too large parameters. So yeah, we can just call the pre-trained model.
Is there any specific computer with like REM size or CPU size? Is there a minimum specification to deploy your model?
Right now, I think we can not really. We don't really have a specific one. I mean, because it's not too large. So yeah, we can deploy it in our laptop, just a standard laptop.
Maybe the last question. As your presentation, you mentioned about 4 input like voltage, current, and temperature, and so on. Can you describe about a resolution of the sensor? I think in the real application, voltage, current, and temperature is sensing by a sensor. Is right?
Mm-hmm.
So you can you describe about specification of sensor like accuracy, resolution to satisfy with your model?
Okay. Actually, I'm not really sure about the sensor itself. Yeah, because we use the public data set, and yeah, I'm sorry, I don't really know the specification for that.
Okay, thank you, Bu Astri, for your presentation and your answer. I think any other question from participant? No? Okay, thank you again. So we can move to the third presenter, Mr. Adityo, please.
Yes. Greetings, my name is Muhammad Adityo, and in this opportunity, I would like to present my research, which is titled The Precise Temperature Control Strategy for Laboratory Scale Fermentation Process. But first things first, this paper presents a precise temperature control strategy for a laboratory scale fermenter system. The proposed method utilizes actuators employing a hysteresis on-off cooling mechanism and a proportional derivative control algorithm enhanced with a range time proportional heating control. The objective of this control strategy is to achieve a stable point temperature of 28 to 30 degrees Celsius within the fermentation chamber, with a maximum of steady-state error allowed is 1%. Experimental results demonstrate the effectiveness of the proposed control method in accurately regulating the temperature inside the fermentation chamber. The system achieves the desired temperature within 3600 seconds when cooled with a set point of 30 degrees Celsius, but takes 5 times longer with the lowest set point of temperatures, with a maximum overshoot of less than 0.3 degrees Celsius or 1% from the operational set point, and a steady state error of 0.25 degrees Celsius. Future research can further enhance the stability of the fermentation process by incorporating optimal tuning methods. The precise heating control strategy developed has practical implication for the laboratory scale fermenter, contributing to improved process efficiency and product quality. It also provides the foundation for potential application in larger scale industrial fermenter. So let me talk a bit for fermentation. This is a fermenter. It is 20-liter fermenter that we have in the National Research and Innovation Agency under the Medicine Research Organization. It is quite old, about 20 years or more. And the problem with it is the controller has broken, and there is no contemporary solution or ready-made solution for this type of product. So the fermentation itself is a process to maintain microorganism growth and metabolisms, and there are multiple parameters involved in this, such as the dissolved oxygen rate, the temperature, the pressure, and also the air flow rate. But in this research, we only focus on the temperature control itself. And for the reference, I have referenced other works by Ritonja et al., which propose simple and inexpensive process for a batch reactor bioreactor temperature control, which only use a one actuator, heater actuator. And also we reference from Wang et al., which uses a multi-point control to limit the min-max temperature. However, in this experiment, we haven't quite implemented the multi-point actuator. We only implement the multi-point sensor. So we have two temperature probe sensor that is put in the bioreactor chamber or the fermenter. And also that two temperature probe is also integrated with other sensors such as the dissolved oxygen and the pH sensor. And we developed this to optimize the fermentation process. And the working principle of the fermenter used in the experiments is shown in this graphic. So for the heating itself, it is done by mainly by the flowing water here. The water is heated by the heater here. The heater itself is controlled by PD controller, and then when the water is heated, it goes through a series of solenoids and pipes to the bioreactor jar or the fermenter jar. And the fermenter jar itself has multiple layers. So the inner layer where the reaction happens, and then insulated with an outer layer which houses the heat exchangers in order to be able to capture and release heat from and to the water itself. So after the heated water is sent to the heat exchangers, and then the heat is absorbed by the fermenter, the spent water then exits from the chamber through this set of pipes towards this set of solenoid. And this, when the water itself can be either recirculated here, so the water can be heated again, or if the fermenter needs a quick or a rapid cooling action, the water itself can be dumped, so a supply of fresh cold water can just continue to flow here and then just be dumped towards here in the water out valve, which controlled by the hysteresis logic. And the control algorithm proposed in this experiment is shown in following figures. There are essentially two control blocks here, which is the PD controller and the hysteresis controller. So the PD controller itself can be expressed by this mathematical equation, which is basically just a basic PD mathematical equation. And then for the hysteresis itself can be expressed with this mathematical expression. So this is when the hysteresis can either output 0 or 1, but depending on the where the error of the system correspond to the whether it's in the lower limit or the upper limit in the hysteresis, which is represented by A or B here. So the upper limits only trigger the change from 0 to 1 in the hysteresis system. So the B only trigger the 0 to 1 system, and the lower limit, which is the A, only trigger the change from 1 to 0. And the experiment setup, we did 2 experiments with set points used are 28 and 30 degrees Celsius respectively. And the parameter observed are the usual performance parameters, which is time to steady state, maximum overshoot, and steady state error. And then we hand tune the PD controllers and insert the gain parameter, which is Kp equals to 2 and Kd equals to 10. And also we inserted the hysteresis parameters, which is A, the lower limit, at the plus 0.1 and B equals to plus 0.2. And here is the result of the experiment. For this one, the set point is 30 degrees Celsius, and we reach the time to steady state in 1 hour 40 minutes, and the maximum overshoot is 0.3% relative to the set point. So it's about 0.13 degrees Celsius. And then the steady state error is plus 0.25 degrees Celsius. There is a bit of oscillating temperatures, which is to say that it is according to the characteristic of the PD controller itself. So the result is within the desired parameters. Also, this is the result of the other experiments. We use the 28 degrees Celsius as a set point, and it reached the steady state in just over 6 hours and 30 minutes, with the maximum overshoot of 0.65%, which is about 0.18 degrees Celsius. And the steady state error itself is plus 0.25 degrees Celsius. So in conclusion, the performance characteristic for the proposed control system is such: for the time to steady state is between 1 to 6 hours. And then the maximum overshoot itself is less than 1%. And the steady state error is plus minus 0.25 degrees Celsius relative to the set point. So that's it for my presentation. Thank you very much.
Thank you, Mr. Aditya. And there a question from participant? No question. Okay. I have a very basic question. Why PD control, not PID?
Okay. Thank you, Mr. Dayat, for the question. Why do we use PD control instead of PID or PI? So it is just basically a trial and error, because essentially when we try to retrofit the controller, we didn't have any documentation or whatsoever for the old controller. And basically, since the company that made the controller and the fermenter jar has since gone out of business, so we just have to use that trial and error method that corresponds to some local or the first-hand or second-hand account of past experiment done with that fermenter. So essentially, we arrive at the conclusion that the PD controller is what is the closest to what the controller is supposed to be to use in the experiment.
Maybe the second question, have you plan to connect your fermenter to the internet, like IoT?
Currently, there is no plan to attach or connect the system to a larger network with such as IoT and such, because there is some concern that the security, because there is some proprietary data that essentially the operator right now, which is the Organization of Medicine Research, is not allowed to share.
Any other question from participant? No question. Okay, thank you, Mr. Aditya, for your presentation and your
You're
answer.
welcome.
Okay, we are going to the last presenter, Mr. Oka, please.
Hello, everyone. Thank you for joining me at this ICRAMET conference. My name is Oka Mahendra, and I'm a researcher at the Indonesian National Research and Innovation Agency, or BRIN, from the Research Center for Smart Mechatronics. I'm here to present our paper titled Fluid Recognition Through Active Grasping of Two-Finger Gripper Using a Soft Skin Sensor. With our co-authors are Muhammad Arifin, Rian Putra Pratama, Aris Munandar, Catur Hilman Baskoro, Ista Eka Yulianti, Indra Sakti, and Muhtadin. This is the outline of my presentation. I will start with the introduction, followed by the proposed system, experiment design, result and discussion, and conclusion. Let me start with the introduction. The motivation of our research is to create an autonomous harvesting robot that can detect, recognize, and pick fruit safely and accurately, to detect or classify the fruit. As we know, vision-based methods have limitation in recognizing fruits in complex environment, such as in dark or cluttered condition. So we propose to use tactile sensing, similar to the mechanoreceptors in the human hand. Several studies have explored the use of tactile sensors to replicate human capabilities. Funabasi et al. Introduced a method for object recognition using 3-axis tactile sensor. However, it needs additional sensors, complex mechanic, and more computational power. Furthermore, the objects tested were general, not specific for fruits. Zhang et al. Utilized bending and force sensor on the gripper in their fruit classification method, but only one axis and using simple split validation, not cross validation. So we propose a method to recognize fruit based on the active grasping of a two-finger gripper integrated with a soft skin sensor. The gripper has the advantage of simple mechanic and electronic, low computational power, and good fruit recognition result. This study has 3 main contributions. First, gripper design and its active grasping methods. Second, the method for collecting data and classifying the fruits. And third, analyzing the importance of perpendicular and tangential sensor data. Okay, I will explain the proposed design in the next slides. This is the picture of the proposed gripper. This is the gripper. It is made of ABS plastic. And this is the sensor. This is the sensor, which consists of a Hall effect sensor. And this is the aluminum stand. Okay, this is the two-finger parallel gripper proposed in this research. The gripper is a custom 3D print made of ABS plastic using a single actuator. A servo motor is used here, and we use a sensor with a permanent magnet in a soft silicone encapsule. We also build the sensor visualization using a desktop application. Okay, let's see the gripper in action in this video. The gripper moves to open and close its arms. And if we touch the sensor here, we can see in the visualization on the GUI that the circle is getting bigger as we increase the pressure on the sensor. The center of the circle also can move in the X and Y directions. Let's see the movement of the gripper when squeezing the fluids. Okay. The gripper moving to squeeze the fluids. Okay, let's see if we place the orange in the center of the gripper. Okay, we will place the orange. Yes, the gripper squeeze and release. Okay, and the same movement is applied to the Apple II. Okay, the gripper squeeze and release. Okay, I will now move on the block diagram of the proposed gripper. Okay, this is the block diagram of the hardware design. The gripper is controlled by an Arduino Uno microcontroller module. The microcontroller is connected to the servo and the PC, using serial UART and connected to the sensor using I2C. From the laptop or PC, we can read the sensor data, command the motor, and furthermore, do the fluid classification. This is the flowchart of the firmware in microcontroller. The loop begins by reading the sensor and the actuator data. Then the microcontroller waits the grasping command from the PC, executing grasping and continue looping until the stop command is executed. Okay, this is the active grasping method we propose. Initially, the gripper moves slowly from the maximum stroke. After contacting the outer surface of the fluid, the tactical sensor records the initial touch. Furthermore, the gripper continues with a pressing movement of the 5 millimeters relative to the fluid size. Then the gripper pauses for its movement for approximately 2 seconds before finally releasing the fluid. With the grasping method, then the data were collected, pre-processed, and evaluated. I will explain them in the next slides. This research involved 4 fruit variants. There are Washington apple, Manalagi apple, Fremont orange, and Wakam orange. We collected 10 samples from each fruit, capturing data from various angles, resulting in 60 samples per variant. 60 samples per variant, and a total of 240 data. This dataset is split into training and testing as shown in this table. This is the time series of the data from the sensor. In this picture, the black line dashes divide the graph's state from the Washington apple. We divide the time series data into 4 steps: A, B, C, and D. A is the gripper start moving. B, the gripper touches and squeezes. And C, the gripper pauses for about 2 seconds. And then D, the gripper releases the fluid. After the data are collected and pre-processed, we use 3 machine learning classifiers. Those are random forest, support vector machines or SVM, and K-networks. In our research, key-fault cross-validation is implemented. The parameters used are K is 5, shuffle is true, and random state is 1. In the next slides, we will explain our result and discussion. The main research question in this research is whether the gripper can detect the type and variety of fruits. If so, how can we improve its accuracy? Okay, this is the result of our experiment shown as confusion matrix for fruit type classification. The random forest technique achieved the highest accuracy. The random forest achieved the highest accuracy compared with other classifier. With classification result of 85% for apples and 93% for orange. This is the result in the classification of fruit variants. Random forest continued to perform the most accurately with accuracy of 86%. Okay, this is the summary of our gripper accuracy. The random forest method delivered the highest accuracy with 88% for fruit classification and 86% for fruit variant classification. These results are enough to show that the gripper is capable of mimicking human hands' ability to recognize the fruit. The next question is how to improve accuracy. Okay, let's see the contact pattern of the fruits. This picture shows the contact pattern of the apple and orange. The contact pattern for apple has a bigger green circle and tends to sideways from the center position. In contrast, the position of green circle for the orange is almost centered. With this fact, adding more information for x-axis and y-axis could potentially enhance the accuracy of the model. Okay, we will conclude the paper in the last slide. We developed a method for identifying different types and variants of fruits using a two-finger parallel gripper with an active grasping technique. The collected data were trained and tested using 3 machine learning classifiers. They are random forest, SVM, and k-neck pores. When the highest accuracy is achieved by random forest classifier. This result confirms the ability of the gripper to mimic human hand capability to recognize fruits. In the future, we aim to increase the number and diversity of the fruits using more advanced machine learning method and more sensors. Okay, this is the end of my presentation. Let's continue with discussion. I invite you to share your ideas and feedback for our research. Thank you for your time and attention.
Thank you, Mr. Oka. Any question from participant? Because we have a limit of time. I think one question. No question. I have a question. What is advantage from your design compared if we use webcam or computer vision? Hello, Mr. Oka.
Okay. The advantage if we use computer vision, gripper versus computer vision. The gripper sense the texture. The gripper can sense the texture, the skin properties, the skin surface properties of the fruit that the computer vision or camera cannot detect the texture, hardness, ripeness, or other skin properties of the fruit. And the second, the gripper can detect in dark environment when the camera cannot detect in dark environment. But overall, this is not replace the computer vision, but to complement the computer vision. Okay.
The second question is about limitation of your design. Is for a specific fruit like apple, orange, or about durian fruit?
Yes, of course, it's more difficult if the fruits have irregular skin, such as durian or pineapple. But we developed the creeper to be adaptive. So if we touch the fruit, it will stop and not force the creeper until the fruit's damaged. We can sense the tactile data from the sensor, so we can adapt the size and the shape of the fruit.
Okay, we have a question from Mr. Rao. How do you deal with replacement that is not always in the same place or point?
Okay, this creeper is designed to combine with the other sensors such as camera or proximity sensor like ultrasonic or other sensor. So if the fruit is away from the creeper, we can use other sensor to manage the creeper touch the fruit. I think that.
Mr. O, are you there? Is the answer is satisfied with your question? Okay. Okay, any other question? I think our time is up. Finally, we reached the end of the discussion. From the last, Ms. Vita, if we have a photo session or not, or we can close discussion.
Photo session already captured, Mas Dayat, so Mas Dayat can close the session for this.
Okay.
Yeah, thank you.
Okay. Finally, thank you for very much from presenter and audience. See you in the next conference. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anbitsu's business. Anbitsu was founded in 1895 the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time. And the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anritsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anritsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors, and check weighers help assure products have good shape and specified mass and are free from contamination. With optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anritsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. beyond testing for a sustainable future. Advancing beyond. Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and society.
Beyond testing for a sustainable future. Advancing beyond. Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Elektronika dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kamen's Tech Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anbitsu's business. Anbitsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anbitsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anbitsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time. And the mobile industry has used Anbitsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anbitsu provides testing solutions to many fields of daily life. Manufacturers use Anbitsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anbitsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anbitsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anbitsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anbitsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. with optimized line operation using comprehensive inspection and operation data. In environmental measurement, along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anditsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology, Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Electronica dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anritsu's business. Anritsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time, and the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anritsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anritsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors, and check weighers help assure products have good shape and specified mass and are free from contamination. with optimized line operation using comprehensive inspection and operation data. In environmental measurement. Along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anditsu is advancing into new areas for a future beyond testing, to create a sustainable society. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond. Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions: science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Jurnal Electronica dan Telekomunikasi or JET is a journal published by Pusat Penelitian Elektronika dan Telekomunikasi LIPI. JET presents high-quality articles on the latest research and development in the field of electronics, telecommunication, and micro or nanoelectronics engineering. JET provides a platform to share research in the areas such as digital signal and image processing, network theory and circuit design, radar and sonar technology, antenna and wave propagation, wireless and optical communication, microelectronic system, electromagnetic and electronics materials, emerging and advanced fabrication technology, and so on. JET is indexed by internationally renowned indexers such as DOAJ, Google Scholar, Mendeley, and etc. JET is also ranked as Center 2 in Kemendristek Green accreditation system. There are 2 JET editions published every year, and all of them are available in open access to support global exchange of knowledge. All submissions in JET are accepted online, and each submission will be blindly reviewed by at least 2 peer reviewers. Most importantly, all submissions are free of charge, and therefore, no article processing fee applies. For more info, please visit www.journalet.com or visit our social media accounts.
Can you imagine? What we call communications is just part of the electromagnetic spectrum composed of countless radio waves, visible light, X-rays, microwaves, UV, and more, flooding the Earth. Everywhere. These invisible communications convey information at tremendous speeds. For example, over 10 gigabps for 5G wireless and over 400 gigabps for wired backbone networks. At this speed, 15 hours of 4K video can be sent in just 1 second. Although communications are invisible, they spread everywhere through society. Testing means capturing these invisible communications. Testing has long been the core of Anritsu's business. Anritsu was founded in 1895, the year Marconi successfully demonstrated the world's first wireless telegraph, marking the birth of modern wireless communications. To start, Anritsu developed and manufactured wireless telegraphs, and then diversifying to meet the progress in communication technologies. Communications have evolved dramatically since development of the Internet in the 1980s. And Anritsu has grown into a global company, leading test and measurement business for optical and digital communications. Mobile phones have also seen explosive growth during the same time, and the mobile industry has used Anritsu test solutions right from the first generation. 5G smartphones are now becoming popular in many countries. Anritsu provides testing solutions to many fields of daily life. Manufacturers use Anritsu test solutions to evaluate transmission and reception characteristics of their smartphones, communications modules, and IoT devices, as well as to test connections using our base station simulators. Anritsu testers are used by manufacturers and test houses for conformance tests. On mass production lines, Anritsu wireless testers speed up inspection times. Easy-to-operate wireless LAN testers support evaluation of IoT devices. Engineers installing and maintaining mobile base stations use Anritsu spectrum analyzers to evaluate radio wave power, frequency coverage, and interference signals. Anritsu solutions support data center installation and maintenance, as well as development and manufacture of optical modules and active optical cables. Our network monitoring solutions support operations by helping visualize and diagnose network conditions. In automobiles, our test platforms help ensure that in-vehicle emergency call system signals meet required functions and standards. We are also a player in food and pharmaceutical quality assurance. On production lines, X-ray inspection systems, metal detectors and check weighers help assure products have good shape and specified mass and are free from contamination. with optimized line operation using comprehensive inspection and operation data. In environmental measurement. Along with camera monitoring, values from on-site sensors are converted to IP for integrated data management at control centers. Our high-performance devices are used widely by manufacturers of communications, industrial, and medical equipment. And now, Anditsu is advancing into new areas for a future beyond testing. By creating synergies with new partners, seeking infinite potentialities for communications and exceeding conventional wisdom and limits. Beyond testing for a sustainable future. Advancing beyond Anditsu.
National Research and Innovation Agency, a synergy in an orchestra. Established through the Presidential Regulation Number 78 of 2021 about the National Research and Innovation Agency. To enhance science and technology's contribution to the national development and to improve the research and innovation ecosystem in Indonesia. The National Research and Innovation Agency is a government agency that is directly responsible to the President of the Republic of Indonesia. Consists of 7 deputies, supported by 12 research institutes, have 85 research centers, Executive Secretariat, Executive Inspectorate, Center for Data and Information, Center for Technology Services, and Polytechnic Institute of Nuclear Technology Indonesia. Through the 3 directions, science and technology resources mobilization, providing a favorable research ecosystem, building an economy foundations based on research. The presence of National Research and Innovation Agency is to achieve Indonesia's goals as a developed country in 2045. Also to make Indonesia as a global reference for sciences, bringing advantages on science and technology development, policy making, and societies.
Good afternoon, ladies and gentlemen. Welcome to the parallel session 16 of ICRAMET 2023 with topics antenna devices and techniques. First of all, let me introduce
Recording
myself.
in progress.
My name is Marcelina Ayuda Krisnanti Titasari, and you can call me Marcelina. I'm a researcher from Electronics Research Center of National Research and Innovation Agency of Indonesia. And in this session, we will have 4 presenters. Before we start, I would like to take a moment to confirm the presence of our presenters as I call out each presenter's name. For the first presenters is Mr. Said Al-Zarani from University of Tabuk, Saudi Arabia. Good afternoon, Mr. Al-Zarani.
Hello, I am here. Yeah.
Okay, thank you. The next one is Mr. Aditya Inzani from National Research and Innovation Agency of Indonesia. Are you here, Mr. Aditya Inzani?
Yes, I'm here.
Okay. And our third presenter is Mr. Topik Teguh Estu from National Research and Innovation Agency of Indonesia. Good afternoon, Mr. Topik Teguh Estu.
Good afternoon, I'm here.
Okay. And our last presenter will be Mr. Pratikno Muhatmanto. Good afternoon, Mr. Pratikno.
Yes, I'm.
Okay. Thank you very much for your confirmation. Before we start, I will read some rules for all the participants and presenters for this session. To all presenters, please keep your video on until the session finish. We will screen capture by the end of the presentation or when all the participants present. The second one is please fill out the attendance form during the session. Our co-host will send the link through the chat box. For the presenters, please have your presentation file ready in order to answer some questions from your slides. The time for each presenter is 15 minutes long. Your video will be played, then you will have question and answer session after your video. So please make sure you are presenting during the question and answer session. For the participant who wants to ask questions, please use the raise hand function or write down your question at the chat box. Okay, now we can start for the first presentation from Mr. Said Al-Zarani from University of Tabuk. Mr. Al-Zarani, your video will start now.
Hello, everybody. This is Said Al-Zahrani from University of Tabuk, Saudi Arabia. And the title of this paper is 38 gigahertz wideband and high gain stacked antenna modeling for 5G applications. The overview outlines here of this presentation start by introducing the objectives of this antenna design, and then mentioning some previous work related to this topic, and I will present the proposed stacked antenna design with its results. After that, I will conclude my presentation. So our goal here for this design basically to target the millimeter wave 5G frequency bands from 34 gigahertz up to 44 gigahertz using one single element of antenna. And this antenna should has the following characteristics. First, achieve actually ultra wide bandwidth with high gain across the bandwidth, and also achieve omnidirectional pattern with simple structure and compact size. So some related work here, for example, this paper they use one single element to achieve 5.8 gigahertz of bandwidth and gain of 7 dBi, and the area they consumed is a 12 by 15 millimeter square. However, this design, even though they achieve very good bandwidth and gain, actually, the design, in our opinion, is a little bit complex. All right. So this is one example of 38 gigahertz antenna design. This is second one, which is using the T element dimension, as you can see here. So they achieve a bandwidth of 2 gigahertz with gain of 10 dBi, and they consumed, the consumed area here is 12 by 10 millimeter square with relatively simple configuration, as you can see. So the drawback here is having limited bandwidth, with quite, compared to our design, they use more area. They use more area, actually. So this is second example. Third example is here. They use an array of 1 by 4 antenna array. All right. They achieve 7.5 gigahertz with gain of 9.76 dBi. And the consumed area is a little bit high, which is 26 by 5 millimeter square, with complex configuration, as you can see from this design structure. All right. So this is our proposed antenna design. We use basically 2 layers of microstrip. The main layer here has two conductors, the ground and the batch antenna. All right. And second one is having like single cover from one side, right? Both of them are Roger material with epsilon r equal 2.2. All right. They are separated by a distance of 100 micrometer using plastic material as a spacer here, as you can see. All right. So you can say we use 3 layers of dielectric, the lower layer of Roger, and then we use an air as a dielectric, and then another layer of Roger material. All right. Note here, the ground is on the as a ring here, right? So the size of this antenna is the batch antenna 5.97 by 5.08 millimeter square. All right. Here is the detailed dimensions of the proposed stacked antenna. The total size of the antenna, which is the ground plane, which is 9.05 millimeter by 9.17 millimeter. All right. This is the top view of the proposed antenna. Now we're going to start to introduce the result, starting by the S11. As you can see, you have here 2 traces, which is the solid one and dashed one. The solid one is for the proposed structure, and the dashed one for the conventional structure without the upper layer. All right. So as you can see, the bandwidth here is improved. The solid line start the lower frequency band start from around 34 up to 44 gigahertz. All right. So compared to the conventional one, we see some improvement. Second here, which is the gain, and also we compare the conventional with proposed one. As you can see, the gain here is improved by a lot, actually, since the maximum value of the gain that achieved is around 8.5 for proposed one. For the conventional was is around 7 dBi. All right. This is for the gain. And you can see here also the radiation pattern. We achieve here omnidirectional results. And you can see the elevation here, plane, and the maximum gain here around 8.5. Here the 11 here for the upper trace. All right. And here the azimuth plane, as you can see, is uniform across the all angles. And here the 3D of radiation pattern at 38 gigahertz. All right. Here the performance summary and conclusion. So compared to other state-of-the-art design, you can see the difference here in the bandwidth, mainly in the bandwidth. All right. So we achieved 10 gigahertz of bandwidth for this design, while the best design here is achieving like 5.2 gigahertz. The size of the proposed antenna is 9.1 by 9.2. So compared to the nearest design to the bandwidth that we achieve, they have even higher size. Okay, so related to the gain, we achieve maximum of 5.8, right, which is better achieved gain compared to other design, except for number 5, which is they achieving maximum gain of 21 because they use an array structure to boost the gain value. All right. So in summary, we actually achieve the 10 gigahertz of bandwidth with very good gain using only single element at 38 gigahertz, and the efficiency that we achieve is above 90% across the whole bandwidth. Thank you so much.
Thank you very much for the video, Mr. Al-Zarani. For all participants, anyone has question? If not, maybe I want to ask you a question, a brief question, Mr. Al-Zarani. Oh, sorry, there is a question from the chat box. Wait. So there is a question from Ms. Kurnia Paranita. Are there any limitation when the antenna is configured into an array, perhaps the side loop effects or mutual coupling between antenna elements?
We haven't tried yet, but we plan to do like an array structure. I think it is doable to do an array like 2 by 2 or 4 by 4, whatever. We can, but we have to use like one single bandwidth, one single ground plane, and we can duplicate the batch antenna in the above.
Yeah, the question is there any limitation or the effect when you array the antenna?
we haven't. The question when we use an array, but we haven't used an array, right?
Oh, okay. So you haven't tried before.
Yeah.
Okay, thank you very much for the answer. Is there any other question from the participants? Okay, if not, so we can thank Mr. Al-Zarani for the video and the presentation. Next, we will move to our next presenter, which is Mr. Aditya Inzani Wahdiat. Mr. Aditya, your video will start now.
Hello everyone, my name is Aditya Inzani Wahdiat, researcher at Research Center for Electronics, BRIN. I am pleased to present my research on new and innovative methods for improving the performance of microstrip antennas. So today, I want to present my research on axial ratio beamwidth enhancement of circular polarized microstrip antenna using periodic conducting structures. The agenda for today's presentation, I will explain about the background of the research, the antenna design process, and we continue with the enhancement of 3 dB and axial ratio beamwidth, result of the research, and conclusion later at the end of the presentation. As you may know, microstrip antennas are widely used in a variety of applications, including radar, wireless communication, and satellite communication. Indonesia is a country with a vast and diverse archipelago. Wide beam satellites antenna offer solution to this challenge. With wider beamwidth, the satellite can cover a large area with single antenna. But the antenna needs to be lightweight and easy to fabricate, and microstrip antenna is suitable types for its application. However, the traditional microstrip antennas have a narrow 3 dB and axial ratio beamwidth, which can limit their coverage. So we need microstrip antenna that have a wide 3 dB beamwidth and a wide axial ratio beamwidth. But it's very uncommon to have both characteristics in one antenna. The primary objective of this research is to enhance the 3 dB beamwidth and axial ratio beamwidth of circular polarized microstrip antennas. This is our proposed antenna. It's using circular patch with perturbation to generate circular polarization. And around the radiator, there are a series of conducting structures connected to the antenna ground plane. Our previous research demonstrates that the periodic conducting structures have the ability to widen the 3 dB beamwidth more than 130 degrees. But it has the downside. It's reduced the axial ratio beamwidth significantly. So to overcome this issue, we add ground slot to enhance the axial ratio beamwidth. The antenna is designed using Duroid 5880 with permittivity of 2.2 and thickness 1.575 mm or around 20 mm. The dimension of the antenna or the radius of the patch with 2.22 GHz resonant frequency could be easily determined by calculating the thickness and the permittivity of the substrate. Perturbation segments implemented to simplify the generation of 2 orthogonal modes to generate circular polarization, of course. The perturbation area also can be calculated and could be simplified into length and width. This is the result of S parameter and axial ratio. We can see that the antenna has very good return loss at 2.22 GHz and a very good axial ratio around 1 dB. But if we see the radiation pattern, we see the normalized directivity here. The 3 dB beamwidth is only around 80 degrees, although it has very wide axial ratio beamwidth. So in this research, we want to enhance the 3 dB beamwidth without sacrificing the axial ratio beamwidth. We studied several configurations to see the effect of periodic conductive structures. We used 4 configurations to investigate the 3 dB beamwidth and axial ratio beamwidth. The periodic conducting structure of 4, 12, 18, and 24, each with separation of 90 degree, 30 degree, 20 degree, 15 degree of conducting pose. And besides the configuration, we also did some characterization on conducting pose height or PH, conducting pose radius or the PR, and the conducting pose space from the edge of the patch, the gap here, the PS. In our previous research, we demonstrate that the number of conducting structures and the height significantly increase the beam width of 3 dB beam width. More number of conducting structures can make the beam width higher, with optimum value around lambda over 4, or in this case, it's around 34 or 35 millimeter, the optimum value. Now let's see what's happened with the axial ratio. The axial ratio at 2.22 gigahertz is good when the height of the structures is around lambda over 4, the 35 millimeters. The more structures we add, the more higher the axial, the more structures we add, the more better the axial ratio is. Small number of conducting structures increase the axial ratio significantly. Like you can see in the 4 posts here, the axial ratio is very bad. It's because the rotating current at the patch from the circular polarization is now coupled to the vertical conducting post. So in this case, the 24 configuration have the best axial ratio of around 1 point something. And we also study the metal post radius on the left side and the space distance between the radiator and the conducting post on the right. There are optimum metal radius for maintaining the axial ratio. In this case, around 1 to 3 millimeter radius, and the distance between the radiator and the conducting structure must be very near, or the axial ratio will be increased. This is the optimized antenna using 24 configuration conducting post. We can see the S parameter and axial ratio is still very good at 2.2 gigahertz, still very good. So we can say that adding 24 conducting structures that connected to the ground plane of the antenna has little effect on S parameter and axial ratio, only on the beam width. And as I said earlier, the addition of conducting posts could enhance the 3 dB beam width. Now the 3 dB beam width is around 190 degrees, but the axial ratio beam width is decreases because of the vertical conducting post. You see here is only in 60 degrees of axial ratio beam width. To overcome the problem, we modified the antenna once more to have a ground slot in order to increase the axial ratio beam width. So we introduced ground slot so that the axial ratio beam width will improve. We try to characterize the radius of the slot, the starting point of the slot, the SLR, and also the width of the slot, or in here is SLW. Here are the slot radius characteristic, the starting point of the radius. As we can see, as we increase the radius, the axial ratio beam width decreases at all V axis, V0, 45, 90, and 135. So the optimum radius is when it's very near the conducting structures, the lower value. But the changes in slot width, the slot width doesn't affect much on the beam width, but it has effect on uniformity. We can see at the 9 millimeters, the beam width is uniform at 2 axes, at V45 and V0, and V90 and V135. It's uniform. So this is the final and optimized dimension for the proposed antenna. We use the radius of 31 millimeter with 9 millimeter of width slot. This is the result of proposed antenna. As we can see, the addition of conducting posts and ground slot don't have significant effect on S parameter and axial ratio. Even the axial ratio now is much better when we add the ground slot. As you can see here, is near 0 dB. And here's the 3 dB beam width and axial ratio beam width. We can see that the axial ratio beam width increases almost 60% to almost 90 degree of axial ratio beam width because of the addition of the ground slot. And we can also see the increases of the axial ratio beam width make the 3 dB beam width decrease. Now the 3 dB beam width is only 130 degree. One thing we should also see in this graphic, the 3 dB beam width and the axial ratio beam width have uniformity of the radiation pattern. So it's good because if the antenna is rotating, it still have the same beam width at all axes. And here's the gain comparison of the antenna. Since the antenna with only conducting posts shows very wide 3 dB beamwidth, the energy is spread out. That makes the gain reach almost 1 dB, the red one. And the proposed antenna has gain to 3.5 dBi at 2.2 gigahertz, the blue one. Here we see the E-field distribution to show the right-hand circular polarization of the antenna. On the left is the distribution at the surface of the patch, and on the right is the E-field from the very top of the conducting structures. Both shows the rotating field of right-hand circular polarization. The presented table compares the performance of various antenna configuration. The inclusion of conducting posts significantly widened the 3 dB beamwidth here, as evident in case 2. However, this comes at the cost of reduced axial ratio beamwidth from 100 something into 53. To overcome this, we incorporated a ground slot in case 3 to enhance the axial ratio beamwidth. And we can conclude that a series of conducting structures surrounding the antenna was demonstrated to significantly widen the 3 dB beamwidth and improve the axial ratio. However, the use of conducting structures narrow the axial ratio beamwidth due to the vertical current induced from the patch antenna. The addition of ground slot improved the axial ratio beamwidth by up to 60% and produced a uniform axial ratio beamwidth in all v-axis. This technique enabled the realization of compact antennas with wide 3 dB beamwidth and wide axial ratio beamwidth. Thank you all for your time and attention today. I hope you find my presentation informative and engaging. Thank you.
Thank you very much, Mr. Aditya Insani, for the presentation. Is there any question from the participant? Okay, if not, maybe I want to ask you one question, Mr. Aditya. What is the material for the metal? I don't think that I've seen it in your presentation lately. Thank you.
Yes, so we are now still exploring several types of metal because it's just only simulation, because we want to fabricate it, and probably we are using a very simple bolt, long bolt, or even a 3D printer. So we are still exploring some of the metallic type of material.
Okay, thank you for the answer. I can see like the Miss Intan Paramudita want to ask question. Okay, Miss Intan, you can ask the question. Miss Intan, do you want to ask a question to Mr. Aditya? Oh, okay. Oh, sorry.
I think that Miss
Kurnia Paramita. Miss Kurnia Paramita. Yeah, Miss Kurnia Paramita.
Yes, thank you, Miss Marcelina, for the chance you give to me. I will ask to Pak Adit. I'm now designing an antenna for ground penetrating radar applications. Do you have any suggestion for me regarding beamwidth setting technique to regulate object penetration depth to get accurate detecting result, Pak? My antenna types is Vivaldi and the polarization is linear polarization. Thank you, Pak Adit.
Okay, well, I never done any GPR application before, so I don't know what is the specification of the antenna. But in my research, this is just to explore how to make the beam wider using conducting structures. Yes. So if you want the GPR to have wide beam width, then maybe you can use this technique.
Oh. this technique is make the beam width wider.
Yeah.
Wider.
Yes, it can be reached to up 180 degree.
Okay. Thank you very much, Pak Adit.
Is that enough, Ms. Kurnia? Okay. Thank you, Pak Adit, for the answer. The next question is from Bapak Ken Paramayuda.
Thank you for your opportunity. So I would like to ask about your consideration of having a higher or wider beam width with a lower gain instead of a higher gain with short or smaller beam width, because what I understand is that for satellite communication maybe higher gain would be better. But I want to know about your consideration of having this kind of characteristics. Thank you.
Yes. Well, first, this satellite will be in the I think it will be the low orbit. So because Indonesia is very wide, the first objective is to get a wide beam width first, and in this research we do that, and after that maybe it's possibility to make the gain higher again, but well, we can get the wide beam width and wide acceleration beam width in this research first.
Okay, thank you.
Okay, thank you, Mr. Aditya, for the answer. I think there is one more question from the chat box. Oh, she deleted the question. Okay, so that's all from Mr. Aditya. Thank you very much for the presentation and the answer. Our next presenter will be Mr. Pratikno. I'm sorry. Our next presenter will be Mr. Topik Teguh S2. Mr. Topik Teguh S2, your video will start now.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you for your coming to my presentation. An honor to meet you here. Let me introduce myself. My name is Topik Teguh S2. I am from Bandung, Indonesia. Today, allow me to present my research paper entitled Directive Beam Metamaterial Inspired Transparent Polydipole Antenna for Millimeter Wave Application. My research paper presentation consists of 7 outlines. The first outline is introduction, followed by what is the metamaterial, and then transparent antenna material, and then design transparent polydipole antenna, and then design modified circular split ring resonator purpose of unit cell, and then simulation research and analysis, and a conclusion. Wireless communication is crucial in daily life with increasing usage requiring higher bandwidth and data rate. Fifth generation system offer faster speed and capacity, particularly with millimeter wave band. Infrastructure, including antennas, need to support higher bands. Future systems may integrate on surfaces like glass windows, vehicle windscreen, and virtual reality headset. Transparent antenna allow visible light passage without significant impacts, while compact antenna increase visibility with less conductive area. What is the metamaterial? Metamaterial are artificial composite structure, meaning that they are made up of multiple material that are arranged in a specific way to achieve desired properties. The constituent material of metamaterial are not commonly found in nature. Instead, they are often synthetic materials such as metals, plastic, and ceramic. Metamateria can have negative permittivity and negative permeability in the same region of the electromagnetic spectrum. Metamateria can support backward propagation and negative refraction of electromagnetic wave. Metamaterials have the ability to manipulate electromagnetic wave in a variety of ways. For example, they can be used to focus, bend, or even clock electromagnetic radiation. Metamaterials have numerous potential applications, including creating invisible clock, enhancing the performance of antennas and communication devices, improving medical imaging through LEDs and devices like super-resolution microscope, controlling sound wave through acoustic metamaterial, and harvesting energy from sources like solar or electromagnetic wave. Figure 1 shows the classification quadrant metamaterial. Quadrant 1 is for natural materials. Quadrant 2 is for electric plasma. Quadrant 3 is for metamaterial, and quadrant 4 is for magnetic plasma. Each quadrant has different properties and support different types of wave. Material used in the design is using ITO material expressed resonator on a glass substrate. Indium tin oxide, or ITO, is a transparent conducting oxide used in electronic devices like flat panel display, touchscreen, and solar cell. ITO material has a sheet resistance of 6 to 8 ohm per square, a thickness of 185 nanometer, and a transmittance of higher than 84%. While glass is the substrate material with a relative permittivity of 4.8 to 5.6 and a Tangen loss of 0.001 to 0.003. The objective of this study is to develop a design transparent metamaterial antenna with indium tin oxide on a glass substrate. The proposed design aims to operate at a frequency center of 28 GHz with a bandwidth of 3 GHz. The FET is intended to have a directional beam, and the S11 parameter should be less than or equal to minus 10 dB. The slide shows the design and mathematical theory of the faulty dipole antenna that has been optimized using CST at a frequency of 28 GHz. The slide shows the design and mathematical theory of the circular split ring resonator. The stage of circular split ring resonator modifier and the dimension of the unit cell that has been optimized using CST at a frequency of 28 GHz. Figure 3 shows a simulation of the transform circular split ring resonator unit cell formation stage, with blue line indicating the S11 and S21 response, red line indicating S11 S21 response with a circulator, and black line indicating the proposed circular split ring resonator unit response. While figure 4 present a simulation of the permittivity and permeability of the transport circular speed resonator unit cell formation states. Figure 6 display the planar flooded dipole combined with a metamaterial structure at the back of the antenna. Comparison of S11 response of the antenna with and without unit cell is shown in figure 7. The antenna without unit cell is operated at 28 GHz with S11 of minus 25.43 dB with 24.1% bandwidth, a slightly wider bandwidth. Figure 8 and 9 show the comparison simulation result of antenna radiation pattern at E-plane and H-plane with and without unit cell. The radiation pattern at E-plane undergo directional change in their radiation pattern due to the addition of DNG unit cell. It shows that implementing the unit cell at the back of the antenna change the antenna properties from omnidirectional to directional beam. A conclusion, a design and simulation antenna of 28 GHz millimeter wave antenna have done using a glass substrate material and an ITO-based conductor resonator. Frequency operation at 28 GHz. Designed for the dipole antenna has result S11 of minus 25.44 dB with bandwidth 6.9 GHz. A proposed unit cell has result of S11 of minus 0.07 dB, S21 of minus 38.41 dB with permittivity is negative 0.01 and permeability is negative 485.65. Combination antenna and unit cell has result S11 of minus 25.81 dB with a directive beam. Although I would like to thank for Research Center for Telecommunication at National Research and Innovation Agency, or BRIN, and Faculty of Electrical Engineering of University Technology Malaysia, who help support this paper for design and simulation. May be enough for my presentation. Thank you.
Thank you very much to Mr. Mr. Topik Teguh S2. Is there any question from the participants? If there is no question, I want to ask you one question, Mr. Topik. As we can see that you simulate with one ring for the CSRR. Is there any effect if you use more than one ring, like maybe double or triple, something like that?
Okay. The placement of unit cell CSRR may be for 2 or 3, and placement in upper or side of the antenna. It can improve oxygen beam. It means the placement of the unit cell have significant impact on antenna performance. Maybe for design must be a careful to placement of the unit cell. Maybe.
Okay. So you haven't known the significant effect of the single or double ring for the CSR. Okay. Okay, maybe next time we can try in another simulation. Okay, thank you very much, Mr. Topik Teguh Estu, for the presentation and for the answer. Our next presenter will be Mr. Pratikno Mahatmanto. To Mr. Pratikno, your video will start now.
Good morning, everyone. My name is Pratikno Mahatmanto. Today, I will present our research entitled Design of C-band microchip fractal antenna combined with pyramidal horn. The author of this paper is Pratikno Mahatmanto, Mr. Dedi Irawadi, Mr. Hidayat Gunawan, Mr. Nugroho Widijatmiko, Mrs. Dinari Niken Sulastri Sirin, Mr. Supriyono, Mr. Yanuar Prabowo, Mr. Ansari Akbar, and Dr. Catur Apriyono. This is our outlines. Consists of introduction, antenna design, result, and conclusion. Introduction. Indonesia is an archipelago country across the equator. The territory of Indonesia that runs from the western end of Aceh province to the eastern end of the province of Papua necessitates a specific communication connection. Satellite communication is the best solution for sharing information. It can connect coastal area, mountain area, rural area, and urban location without blank spot. Accurate information of weather and climate for tropical area like Indonesia is needed, leveraging the availability of every 10 minutes of Earth image data from Himawari 9 remote sensing satellites. Meteorological and climatic information for Indonesia can be generated. Himawari 9 remote sensing data can generate the following information: rainfall rate, sea surface temperature, cloud top temperature, weather prediction, prediction of the direction of volcanic ash distribution, and prediction of fire hotspot, etc. A reception ground station is required to receive Himawari 9 remote sensing data. Specification for this ground station reception follows C-band receiving antenna with LNB and DVB-S2 receiver. The DVB-S2 receiver converts the data into IP packet and sends them to a computer. And the CAN-CAS professional client unencapsulated the data for storage in the computer. This study proposed a new design of receiving antenna with 2.4 meter diameter parabolic reflector, a 3.8 to 4.2 GHz horn antenna with microstrip feeder. The gain of the antenna at the center frequency is more than 30 decibel isotropic. For reception of Himawari cast, a linear polarization of the antenna is designed. A new design of fractal microstrip antenna paired with a flat horn is proposed for the receiving antenna. A microstrip antenna offers physical advantages such as being thinner, smaller, lighter, cheap production cost, and capable to yield linear and circular polarization with a single feeding distribution. A fractal model microstrip antenna generates a broader antenna working bandwidth than a single patch microstrip antenna because it can direct the radiation pattern in one direction. The flat horn is utilized to maximize the gain of the proposed antenna. A simulation of a horn antenna combined with a parabolic antenna is performed to generate a total gain that can meet required powering budget for satellite communication to ground station. This research proposed a new design fit antenna in a Himawari cast receiving antenna system using the fractal microstrip antenna combined with a flat horn. The previous research in 2022. The first image is high-gain inverted trapezoid microstrip patch antenna combined with flat horn. The second figure is the C-band horn antenna fed by rectangular microstrip patch. The third figure is the design of circular polarization microstrip patch antenna combined with conical horn. The antenna design, fractal microstrip antenna design, pyramidal horn design, and combined with antenna and parabolic reflector configuration design. The NPC H220A substrate is the primary material used to create microstrip antennas. The substrate material is 1.6 mm thick, 2.17 dielectric constant, and 0.0005 dissipation factor, and 0.035 mm laminate copper cladding. Aluminum was used to build the flare horn. The parabolic reflector is made of aluminum and has a diameter of 2.4 meters. Figure 1 shows the front view of fractal microstrip antenna, which shows a square patch fed by the microstrip line technologies. A rectangular ring encircle the patch and connect the ground plane to the flare horn part. Figure 2 shows a patch section of a microstrip antenna with a collection of fractal design. There are 4 levels to the fractal structure. The concept of the current division inspired the slot repeating square shape. Stack 1 has 3 squares, stack 2 has 6 squares, stack 3 has 12 squares, and stack 4 has 24 squares. Figure 1 depicts the partial ground plane as seen from behind a microstrip antenna. Table 1 describes the size of each parameter in the fractal microstrip. Pyramidal horn. The first figure is E-plane view of pyramidal horn. Figure 2 is H-plane view of pyramidal horn, and figure 3 is combined microstrip fractal antenna with flare horn. And table 2 is parameter of pyramidal horn. This is the antenna prototype, the fabrication of microstrip fractal antenna and pyramidal horn, and combination of microstrip and pyramidal horn as a feed antenna. Parabolic reflector in figure 1 shows the feed antenna designed in conjunction with a parabolic reflector. The table 3 describes the size of each parameter in the parabolic reflector. Simulation result of a fractal microstrip antenna, a fractal microstrip antenna combined with pyramidal horn, and a combination of feed antenna and parabolic reflector. The simulation results include parameters for return loss, radiation pattern in the E-planes and H-plane, and the gain of the antenna. Figure 1 in this slide show comparison result of the return loss between microstrip fractal antenna and combination of microstrip fractal antenna with pyramidal horn. With -10 decibel as a return loss threshold, the operating frequency for the microstrip fractal antenna is between 2.62 to 5.67 GHz. It yields 3.05 GHz bandwidth. On the other hand, a fractal microstrip antenna paired with a pyramidal horn yields 2.13 GHz bandwidth, with the operating frequency between 3.73 to 5.86 GHz. Comparing return loss of the microstrip fractal antenna and the microstrip fractal antenna with a pyramidal horn shows that the fractal microstrip antenna has a larger working bandwidth than when paired with a pyramidal horn. By combining a fractal microstrip antenna with a flare horn, it will degrade return loss as lower frequency, particularly between 2.5 until 3.5 GHz, and yield better return loss in the higher frequency. The E-plane radiation pattern of microstrip fractal antenna and the microstrip fractal antenna paired with pyramidal horn is shown in the figure. A fractal microstrip antenna is wider radiation pattern, but a pyramidal horn antenna serves as a rectifier, resulting in a more directed radiation pattern. As shown in the figure, where the radiation pattern power of the fractal microstrip antenna is between -7 decibel and 4 decibel in all directions. There is an anomaly in the 250 degree until 250 degree direction, where the radiation pattern power drops to -16 decibel because the source point is located in that direction. In this figure, the radiation pattern becomes more directional once the fractal microstrip antenna is paired with the flare horn, with the main focus point of the emission pattern is one direction and the magnitude roughly 9 decibel. The H-plane radiation pattern of the microstrip fractal antenna and the microstrip fractal antenna with pyramidal horn is shown in the figure. The fractal microstrip antenna is a wider radiation pattern with a radiation pattern power ranging from -7 to 4 decibel in all directions. The pyramidal horn antenna has a high directional radiation pattern. Therefore, when the fractal microchip antenna is paired with the flare horn, the radiation pattern becomes more directional, with the main focus of the emission pattern pointing in one direction, like in the figure 1. This is the image of the parabolic antenna. The left image is a combination of the feed horn and the parabolic reflector, and the right image is the simulation result of the gain. It produced 13.8 decibel. Gain antenna result. Since satellite reception needs very high antenna gain, a parabolic reflector can be used to increase the gain of the antenna. The focal point distance between the feed antenna and the parabolic reflector is an important element to consider. In the prime focus configuration, the feed antenna is located in the center focal point of the parabolic reflector. The next step is to find the optimal distance from the feed antenna to acquire the highest gain value. In Figure 1, this shows a parameters image of a parabolic antenna system focal point. The best results are obtained at a focal length of 650 mm with a consequent gain of 30.8 decibel. Gain antenna result. The antenna gain of a fractal microchip antenna, with a pyramidal horn, and a feed antenna combined with a parabolic reflector are compared in Table 4. The gain of a microchip fractal antenna is 4.18 decibel. The gain of microchip fractal antenna with a pyramidal horn is 9.18 decibel. The gain of a microchip fractal antenna with a pyramidal horn and 2.4 meter parabolic reflector is 13.8 decibel. The conclusion: the current distribution method in multi-level array distribution is used to create a fractal microchip antenna in the shape of a tiered box. The suggested fractal microchip antenna has an operation bandwidth of 2.62 GHz to 5.67 GHz and a working range of 3.05 GHz. This fractal microchip antenna is paired with a pyramidal horn with a directional emission pattern to boost the antenna gain. A fractal microchip antenna and a pyramidal horn are combined in the proposed feed antenna. The combination of these two antennas can produce a gain 9.18 decibel. To meet the requirements of a ground station receiving antenna on the C-band frequency channel, the simulation was extended by combining the proposed antenna with a 2.4 meter diameter parabolic reflector. The gain produced by this combination is 30.8 decibel at frequency of 4.148 GHz. The suggested antenna return loss simulation radiation pattern in the H-plane and H-plane. The antenna gain are thought to be suitable for use as receiving antenna at ground station. This research supported by BRIN and Universitas Indonesia. This is our reference. Thank you for your attention.
Thank you very much, Mr. Pratikno, for the presentation. Is there any question from the participant here? Okay. Ms. Fon Octaviani, you can ask the question.
Okay, thank you very much. Miss, usually we use waveguide adapter for feeding of the horn antenna, and then your purpose of this research is to increase the gain of the antenna by using a feeding antenna using fractal structure, and then how much the increasing of gain between using the waveguide adapter and your proposed method, the gain enhancement between using your purpose with the conventional feeder.
So, can I share presentation? My presentation.
Mr. Pratikno, can you speak louder? We cannot hear your voice.
So in microchip fractal antenna, the gain we in simulation we get 4.18 gigahertz, and after we combine the microchip with the pyramidal horn, we get 9.18 decibel, 9.18 decibel, and we can see that the difference between the adding the pyramidal horn and without pyramidal horn is about 5 decibel. There is adding the gain 5 decibel.
Have you compared your result when you using a pyramidal horn using a feeder by using a wastegate adapter?
We not compare with the pyramidal horn in direct in the product production or in field in the drone station, but we know in the some brochure we can get the gain of the pyramidal horn is most 15 decibel, like that.
Okay, it's enough. Yeah. Thank you very much.
Thank you, Mr. Pratikno, for the answer. There is some questions at the chat box. The first one is from Mr. MITDS Nukuhai. What are the reasons or methods underlying the selection of each antenna parameter? Maybe you can answer this question first, Mr. Pratikno.
I think the reason of the method underlying the selection of the each antenna parameter is we try from the fractal antenna microchip we
Recording in progress.
Okay, thank you. And then the next one, we have a friend from Saudi Arabia, Mohammed Al Tahir. Mr. Al Tahir, are you here?
Yes, I'm here.
Okay.
But unfortunately, I'm facing the same problem that my laptop, the camera webcam is not working very well. So
Okay.
I will use, not only my voice.
Okay, I understand.
Yes,
No
I'm
problem.
here.
Thank you. Yeah. So let me confirm again. The next one, the last one is Miss Khair Ol Nisa. Are you here? No? Yeah, we get information you are absent. Okay, it's okay. So now we will have 4 presenter, and I think all of you already know the regulation and the rule of the presentation. You will have to play your video presentation, and then after presentation, please stay tuned until the last session, because the last session will be we will have some photo session, and after this session finish, then we will have the last activities for this conference, which is keynote speech. Okay, we can start for the first presentation with Mr. Yumiguno. Mr. Yumiguno, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Thank you, ladies and gentlemen. First, let me introduce myself. My name is Yumiguno from the National Research and Innovation Agency, and today I would like to present our research title, An Analytical Approach to Uninterrupted EFE Video Communication Simulation and Finding. This paper is presented at the 2023 International Conference on Radar, Antenna, Microwave, Electronics and Telecommunication. This presentation will explain the background of the research, problem statement, objective, and simulation and preliminary result, and then conclusion. Okay, let's begin with the background of the research. UAV, unmanned aerial vehicle, have been implemented for at least 2 decades in the military. Technology advancement has widened its application even to commercial use. UAV can use mission, hyperspectral remote sensing, IoT platform, and assisted emergency network in disaster. Alap-alap prototype 1 provided by the National Research and Innovation Agency is the latest series developed in UAV. We can be utilized for aerial photography or real-time video surveillance mission for urban, suburban, and rural area. Key technology in UAV application is the research of wireless connectivity of real-time video to ground controller, and critical design element, SNR, and link budget for efficient video communication. Critical for ensuring effective communication. From this figure, we can see this main aerial vehicle and this ground controller, and we use the air-to-ground canal communication. So link budget, very important. Can analyze the reliability of UAV communication link, ensure stable high-quality video transmission, and analysis inform critical analysis signal quality, estimate range, determine reliability, and we can calculate the adjust transmission power, modify antenna alignment, and update frequency band. And problem statement, and the problem statement focus on the fundamental component wireless communication system, which consists of transmitter and receiver connected through a wireless canal. Three phenomena in wireless canal that significantly impact the communication quality are highlighted, and path loss, the wing, and multi-path fading. This phenomena can degrade the signal received by a UAV or ground station, leading to potential communication failure. And then 3 key technology or areas that central its effectiveness to ground canal communication, throughput, the amount of data that can be transmitted successfully, range, the maximum distance over which communication can be maintained, robustness, the system ability to withstand or quickly recover from difficult conditions like signal interference loss. SNR and link budget consideration are one of important element in design UAV video communication. And next objective, in the figure we can see the block diagram, this onboard UAV and this on-ground UAV, ground controller, and methodology and contribution. This methodology applied just calculating the link budget using formula, and contribution, analysis and simulation based on the data, get simulation, bit error rate, and packet error rate. Assumption and coverage just only use the additive white Gaussian noise Kana model, and or FDM basic modulation, just only have modulation, Gerben, and cyclic traffic limitation. This research does not conduct validation track flex testing, but analysis perform calculation using formula at MATLAB simulation. And next, link budget calculation. We have the video transmitter parameter from frequency, bandwidth until the antenna height, and this value. After that, we can calculation from the formula, and we get the sum of value and distance between the UAV antenna and the gaseous antenna, effective isotropic credited power, silver gain, path loss, signal level, link margin, noise margin, and anti-signal to noise ratio. And then we can collect data connecting distance from SNR. Distance we can calculation from the 10 kilometer until 100 kilometer, and then this value SNR. And next, link budget simulation, we use the OFDM CISO parameter wireless canal using the EWGN modulation using the KPSK effective size 256, Gerben 1/8, and cyclic prefix 1/4. And this block diagram we use the only modulation pilot, Gerben, and cyclic prefix. And next, simulation and preliminary result and calculation and analysis of relationship between range and SNR. From the screen, we can see the figure, and 10 kilometer, the SNR value 24.65 dB, and 50 kilometer 10.97 dB, and 104.94 dB. This is a trend where the signal strength weaken as the distance increase. And next, analysis and simulation of the relationship between range and bear. This is bear, this is range, and 10 kilometer bear value of 2.79 times 10 to minus 168, and 50 kilometer bit error rate 2.85 times 10 to minus 7, and 100 kilometer bit error rate increase 6.2 times 10 minus 3. And next, packet error rate analyzing using KPSK modulation, and this packet error rate in percent, and its range 50 kilometer register 0.03%, and 100 kilometer 99.83%. And conclusion, this study examined video transmission in UAV embracing a 2G communication line outside transmission and OFDM modulation using KPSK. Initial simulation at 10 kilometers saw excellent video transmission quality with SNR 24.95 dB and minimal bit error rate 2.79 times 10 to minus 100 XT. However, as the transmission range increased 50 km, SNR value 10.97 dB, bit error rate of 2.85 times 10 to minus 7, and packet error rate 0.03%. And 100 km SNR value 4.94 dB, bit error rate increasing to 6.2 times 10 minus 3, and packet error rate 99.83%. There was a decline in SNR and an increase in bit error rate. This research offers insight into the challenge of FM modulated air-to-ground communication for UAV, especially for high-quality video in line of sight scenario. Future research will validate by conducting flight tests in real environment and looking for a way to increase the power of UAV video transmission over longer distance. This my reference, and thank you. At the end of the presentation, we'll sincerely appreciate the research organization of Electronics and Information for the support and substantial contribution to this research, especially for advancing our degree by research. Thank you for your attention. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for your presentation, Mr. Yomi. It's a great presentation. So I would like to ask from the audience, is there any comments, response, or questions regarding the presentation from Mr. Yomi? There will be around 2 or 3 minutes. So, okay, Mr. Yomi, I have several questions. Firstly, this is related to the key findings, relationship with the distance and the quality of the signal. Can you highlight again?
Okay,
Yeah.
Mr. Malik. I will try to answer your question. Maybe what's the primary objective of my research? This right, Mr. Marlin?
Yeah. Maybe you can share your slides again? Do you prepare your slides?
Oh, sorry,
Not the video.
I am not prepared.
Okay. Yeah, maybe you can explain. Can you get it? Or maybe another one. I have another question. You said that in the page 14 regarding about the limitation, there is a limitation, acceptable limitation regarding the distance and the quality, and we can see from the conclusion that increasing the distance decrease the signal to noise ratio, right? So there is around 4 decibel signal to noise ratio. Okay, so what is the limitation, acceptable limitation for that one? I mean, is it 1 decibel? Is it acceptable or not? I mean, from some applications, the signal processing maybe around 60 decibel is quite acceptable. Less than that, the signal will be very bad. Okay, but according to your result, 4 decibel, is it okay, or what is the limitation, acceptable limitation?
Okay, Mr. Malin. From our calculation and simulation, I think from the SNR parameter and calculation from distance, various distance from 10 kilometer until the 100 kilometer without the noise. But using the adaptive white Gaussian noise AWGN. So the simulation calculate the maintained signal quality at distance 50 kilometer with SNR 10.97 dB and bit error rate 2.85 times 10 minus 7 indicate acceptable video quality. But however, a distance 100 kilometer from my calculation, the signal quality significantly decline because the SNR value just only 4.94 dB and bit error rate 6.2 times 10 minus 3. I think that's all.
So in the simulation, did you there was no noise, right? So this is free noise simulation. Okay.
Yes.
So when we want to consider the noise or the environment conditions in the simulation, so what kind of noise? Wind or weather, humidity or something? Is it possible to simulate?
Maybe I think the possible simulates. I think the multipath scattering. Maybe the from the building, from the tree. I think that, but our research here and our calculation, this research, this only the real condition. This one Kana model, adaptive white Gaussian noise, I think.
Okay, great. I think I quite understand. It is quite interesting research. So yeah, we are waiting for your further research, particularly for the experimental result. And again, I would like to thank to Mr. Yomi. We can give some applause for your presentation.
Okay, thank you, Mr. Malik.
Yeah, thank you again. And then we have another one. Miss Bella, are you ready?
Yeah.
Yeah, time is yours, please.
Good afternoon, ladies and gentlemen. My name is Bella Miliana Astril. I'm a master student from Bandung Institute of Technology. Today, I'm honored to present our research on image super resolution using ESR-GAN, a preliminary experimental study. First, we will proceed to the first section of the outline, which is the abstract. The ongoing progression of technology has led to substantial advancement in image and video quality. Not all visual content maintains a high standard. Diverse factors contribute to the degradation of image and video quality. Super resolution techniques offer a solution to restore a compromised quality in image and videos. Enhanced super resolution generative adversarial network, or ESR-GAN, is one of super resolution techniques. Next, we move on to the introduction section. Along with technological advances, the quality of image and videos continues to undergo significant improvement. Higher image and video quality undoubtedly result in more captivating visual experiences. However, not all images or videos maintain high-quality attributes. Various factors can contribute to image and video quality deterioration, such as image or video compression process. Nevertheless, the compromised quality of image or videos can be rectified by employing super resolution techniques. ESR-GAN stands out as a cutting-edge deep learning techniques in the realm of video super resolution. This paper is preliminary experimental study, and the findings from this process will be further applied in subsequent research on video compression super resolution. Next, we move on to the super resolution section. Super resolution is an image or video processing technique aimed at enhancing the resolution of images or videos to a higher level. Super resolution can be applied in various fields, including medical imaging, augmented reality, satellite imaging, and video conferencing. Furthermore, the demand for higher video quality, also known as super resolution, continuously increases. Several studies on video super resolution were conducted by Yang et al. 2022, Kepler et al. 2016, He et al. 2021, and Sajadi et al. 2018. The measured value used to determine the quality of super resolution is called PSNR. PSNR is usually obtained by comparing the original image with the compressed image under test. The PSNR value measured in decibels can be calculated using this formula. Next is Structural Similarity Index Measures, or SSIM. SSIM is also employed to determine the similarity between two images. The SSIM value can be calculated using this formula. Next, we move on to the method section. The primary objective of this research is to reconstruct low-resolution images into high-resolution ones using the ESR-GAN method. The block diagram of this experiment documented in this figure. First, low-resolution images are used as input, then the ESR-GAN method is applied to these images to fill in missing details. The output is high-resolution image. And this is the visual representation of the block diagram that encapsulates the architectures and components of the ESR-GAN. RRDB's blocks are specifically designed to tackle the challenging task of learning the differences or residuals between low-resolution and high-resolution images. In essence, they function as powerful feature extractors that allow the network to understand and capture intricate details that are essential for enhancing image quality. Complementing the RRDBs are DINS blocks, a critical component within the ESR-GAN architecture. DINS blocks are convolutional blocks that possess a unique capability. They accumulate and combine the outputs of all preceding convolutional blocks. It means that the output of each convolutional block is not isolated, but aggregated and added to the input of all subsequent convolutional blocks. Convolutional layers are adept at capturing intricate spatial patterns. At the same time, the Leaky-Rayleigh activation functions introduce non-linearity and helps preserve valuable information that might be lost in traditional activation functions. The output of the last step is high-resolution image. This is the architecture of the bicubic. The architecture of the bicubic working process is a method used to enhance the resolution of an image. It begins by taking a low-resolution image as input, which serves as the source of the image whose resolution is to be improved. Each target pixel in the resulting image is selected, and an interpolation region is defined in its vicinity. Bicubic interpolation coefficients are computed within this interpolation region, and the actual interpolation process is performed by combining pixel values within the interpolation region. Next, we move on to the result and discussion sections. In this research experiment, 24 distinct images have been included, grouped into 3 distinct resolution and dimension categories. Each image has been subjected to the application of the deep learning approach, ESR-GAN, and 3 non-deep learning techniques. For image with first dimensions, non-deep learning techniques such as bicubic, bilinear, and lensless tree consistently outperform the deep learning method ESR-GAN in terms of PSNR, indicating a better preservation of pixel-level image quality because PSNR measures how close the generated images are to the original ones in terms of pixel quality. Similarly, the SSIM values support this trend, with ESR-GAN exhibits lower scores than traditional techniques. For the next 2 image dimensions, the PSNR and SSIM results for the deep learning method ESR-GAN continue to lag behind those of the non-deep learning techniques, regardless of the variations in image dimensions and resolution. One important aspect to note is that PSNR primarily measures the similarity in pixel intensities between the generated and original images. In contrast, SSIM goes beyond pixel-level comparison and considers the structural characteristics of the image, offering a more comprehensive assessment of image quality. The critical questions arising from this finding is why ESR-GAN consistently produce lower PSNR and SSIM values than non-deep learning techniques. The explanation lies in the nature of deep learning-based image enhancement and its impact on image characteristics. ESR-GAN, a deep learning-based method, enhances image sharpness and clarity. It can be effectively reconstruct low-resolution images into visually sharper and clearer counterparts. However, this improvement often comes at the cost of differences in color and brightness compared to the unreconstructed images. These differences in color and brightness contribute to the lower PSNR and SSIM values for ESR-GAN. This is the image results for the first dimension. As we can see, the ESR-GAN result is more better than the others. And this is the images results for the second dimension. The results of ESR-GAN are significantly better than others. And this is the image results for the last dimension. As we can see in this result, it becomes apparent that ESR-GAN excels in enhancing low-resolution images, resulting in visually sharper and clearer outputs. As can be seen in ESR-GAN architecture before, there are several layers of convolutional blocks that take low-resolution image as input and are responsible for enhancing the resolution of the image. These convolutional blocks use convolutional filters to extract essential features from the low-resolution image and produce an image with higher resolution and sharper details than the original image. It is important to note that images with higher PSNR and SSIM scores do not always translate to superior visual perceptions by humans. ESR again demonstrates its ability to generate visually pleasing results even when its PSNR and SSIM scores are comparatively lower. These conditions highlight the limitation of solely relying on quantitative metrics like PSNR and SSIM, as they may not fully capture the qualitative aspects of image quality that are essential for human perception and satisfaction in various image enhancement applications. Next, we move on to the conclusion section. ESR GAN is capable of producing superior outcomes in preserving image details and structures. The result may exhibit brightness, contrast, or texture variations compared to the original images. As ESR GAN enhances image sharpness, PSNR only measures the similarity in pixel intensities between the generated and original images, and SSIM compares the structural characteristic of images through structural similarity. ESR GAN may excel in enhancing the details and texture of an image qualitatively. This can lead to visual disparities in pixel values of the image that quantitatively decrease the PSNR and SSIM scores. In conclusion, I would like to express my sincere gratitude to the audience for their time and attention. The findings and insights shared today are a testament to the collaborative efforts in our field. I hope that the insights shared today will inspire further research and innovations in our field. Thank you.
Okay, thank you, Ms. Bella. Are you master student now?
Yes, I'm a
Okay.
master student at
Good.
Institute
Thank you, joining for this conference. Good experience. So before we have several questions from me, I already have question from the audience from Mr. Iman Firmansyah. How small the pixel resolution for the allowable input image?
Actually, we do not limit about how small the dimension or resolution can be as input, because the smaller the input, we can see how better the method for increasing its resolution. So there is no limit.
Okay. So any response from Mr. Iman? Do you have any other comments? Oh, okay. Right then. So I have another question. Do you have your presentation now? Can you show slides, result, and discussion?
Wait.
Yeah, my question is, maybe I missed your presentation. What is the stands for of ESR GAN? GAN, I know the GAN, but I don't know ESR.
Enhanced super resolution.
Enhancement?
Enhancement super resolution.
Super resolution GAN. Okay.
Yes.
Now, your method, is it supervised or unsupervised machine learning? Did you use?
Actually, it's supervised machine
Supervised.
learning. Yes.
Right. So,
But we do not train the model because we use a ready-to-use model. So about the training or evaluation for the model, it has been done before. So we just use the model that is ready to use.
oh, like transfer learning. Okay. So, any reason why do you use image super resolution? I mean, the term super, it's look like really higher super resolution. So, because your result, it is not really, I mean, accurate, right? So maybe you can show any reason for that.
In my presentations,
Yes.
and as in the picture in my presentation before, we call it super wide because compared to the other non-deep learning technique,
Mhm.
it's more better than that. So we call it super resolution because
Mhm.
other non-deep learning technique, the result is more like blur and not really clear. So
Mhm.
our ESR GAN is more clear than other method.
Okay, so there are two parameters you use, right, to evaluate the performance, which is the SMNR. I forget the name. So when you compare with the other deep learning, am I not mistaken from the table you shown, the value always lower than others. Is it the lower is better, or I don't understand?
Actually, the more ESNR value is the better, but in this case, because ESR GAN that we use is make the difference of the original image and the result. So because PSNR and SSIM compare similarity in pixel, so there is a difference in pixel color. Then the result is not high.
So according to the table, your method is better.
According to the table about PSNR and SSIM, is not better,
Not better.
but we
Okay.
focus on the visual representation.
Okay. Okay, this is the conference paper. Usually there are some improvement from the reviewer. If you don't mind, is there any comment from the reviewer before in order to improve for the journal, maybe? Any idea?
Sorry, can you repeat again?
Yeah, I mean, is there any idea for you and your research team in order to improve your methodology, particularly from the table? Because when you show only the result from the image that you say your image result reconstruction is better than the other deep learning, but the table shows that it is not better, so it's like contradictory.
Because for further research, we will use this for video compression to enhance the video compression resolution. So the value of PSNR and SSIM, we think it not really matter because what we focus is the visual representation for the image or the video compressions in the further research.
Okay. Okay, thank you. I think time is enough. Thank you, Ms. Bella. Thank you again, and her applause. And then we have another one from Ms. Yosi from University of Indonesia. Time is yours.
Good morning, everyone. Today, Ayosi Rahmawati will present the findings of my research on palm fruit ripeness characteristic specification using pre-space measurement method. I want to express my gratitude to the ICRAMET organizing committee for granting me this opportunity. The outline in this presentation consists of introduction, methodology, result and discussion, and conclusion. First, the part of introduction. Indonesia is the world's largest palm oil producer with an area of 16.38 million hectares and a production of 46.8 million tons of crude palm oil or CPO. Oil palm fruits is rich in oil, making it the most grease-producing fruit among others. Therefore, palm oil is processed as raw material for cooking oil, margarine, the cosmetic industry, and etc. Next, detection method of oil palm fruit. It is important to harvest oil palm fruit when it's ripe. There are two methods of analysis, destructive and non-destructive. Destructive method reduce the oil content due to physical contact. Non-destructive method, either visual or non-visual, utilize physical and chemical properties. Non-visual methods include fluorescence, microwave, inductive, and thermal sensors. Generally, non-destructive methods are visual, examining morphology, color, and physical characteristics to determine the level of maturity. Next, methodology. In this research, non-destructive methods will be used involving non-contact feature through the FSM to determine the transmission coefficient of electromagnetic wave from oil palm fruits, which contains electrically sensitive material in the form of N as parameter, which is denoted by S21. In this measurement, the hardware used consists of the M5230C PNA-L vector network analyzer of PNA that operates at a frequency of 300 kHz to 13.5 GHz and source power 0 decibel milliwatts, which is equivalent to 1 milliwatt. A horn antenna that operates at a frequency of 9 to 12 GHz, and a personal computer or PC to monitor the result of the S21 data measurements. This computer will serve as input for digital signal processing, allowing to detect the maturity of oil palm fruits. For more details, the S21 data processing stage can be seen in figure 2 below. First, arrange the S21 data into a fast Fourier transform or FFT vector in the frequency domain. Then generate the transmit signal SG and convert into a discrete vector S21N with N as many as the number of S21 data, that is 201 points. Then perform FFT calculation from SGN. Next, carry out convolution with key equal ones via equation SR key, where letter SR key will be the input of the FFT. The final stage, namely determining the received signal with FFT, which is expressed as the following equation, and letter SRN becomes the output of the inverse fast Fourier transform or EFFT. Next, free space measurement. Free space measurement is a manually operated tabletop model that can be upgraded to the automated free space system. The FSM is invaluable in the lab for testing inhomogeneous material, curved material, and material that cannot be measured precisely. Very accurate measurement can be made quickly, ideal for research. The properties of electromagnetic material are shielding, absorbing, metamaterial, and dielectric. Characteristics of electromagnetic that can be measured, such as surface resistivity, radar absorption, celerity parameters, magnetic permeability, and dielectric permittivity. Next, fast Fourier transform and inverse fast Fourier transform. Two methods are employed to process S21 data using FSM, FFT, and EFFT. FFT is an efficient algorithm for computational tasks related to the processing data. In radar system, FFT is commonly utilized to transport data from the time domain to the frequency domain. FFT operates under two conditions: when n is even, expressed as 2n, and when n is odd, expressed as 2n plus 1. Equation 1 represents the general formula for FFT, while equation 2 defines X key when n is either even or odd. Where X key is an FFT in the frequency domain with a certain key value as specified, apart from that, n is the amount of S21 data output from VNA. Meanwhile, Xn is the result of an VNA data, which is in the time domain, with Wn being a factor which can be expressed as a to the power of negative j times 2p over n. In equation 2, N over 2 in sigma appears so that when added up, the value of N will remain the same as the value N used in the S21 data. The FFT function is the opposite of the FFT, used to convert the data as key in the frequency domain into the time domain. In FFT, there are also two conditions, namely when K is even, expressed as 2K, and when K is odd, expressed as 2K plus 1. Equation 3 is general equation of FFT, and equation 4 is Xn when K is even and odd. Next, sample measurement of oil palm fruits. Figure 5, sample measurement of oil palm fruits A, unripe, B, ripe, and C, overripe. Result and discussion. It can be seen that the magnitude value changes according to difference in maturity level and follows the condition under which the measurement is carried out. At the raw maturity level, the magnitude value is low. The mature maturity level has the highest average magnitude value with an average value for 0.542 decibel milliwatt. Meanwhile, the overripeness level has a average magnitude value of 2.747 decibel milliwatts. Lower than the overripeness level because the overripe fruit will increase free fatty acid and reduce the oil quality. Figure 6, receive signal magnitude. Part A is real, part B is imaginary. However, imaginary transmission coefficients are often neglected because they relate to the energy absorbed by the material and are considered part of the energy that is lost or changed form. Conclusion: free space measurement of FSM method was used to detect the ripeness of oil palm fruits. The result indicates that unripe fruits have a lower magnitude transmission coefficient than ripe fruits. This is because raw fruit has a low water content, so the transmission level of electromagnetic wave is also low. Ripe fruit shows a superior oil quality compared to overripe fruit, as overripe fruit contains free fatty acid, which decrease the overall oil quality. For further research, modeling will be carried out to obtain the level of oil content contained in oil palm fruit so that its maturity is known. Thank you for attention. Good morning all. Thank
Okay,
you.
thank you, Miss Yosi. Good presentation and good research as well. It's quite interesting. And then, do I have a question from the audience here? You can raise hand or check in the box. Okay, Miss Yosi, I have several questions regarding your research. So my imagination is when you want to apply your systems, will you use your system, bring your system to the research, the palm oil field, or just put it on a station and then the palm oil will be flow in the conveyor, and then you put your system sensor on the conveyor belt? Which one is the methodology when you want to apply?
Okay, thank you for your question. I do experiment about palm fruit ripeness characteristic specification using free space measurement method. I will use the data to the result of this research can be a basis for knowing the ripeness characteristic of oil palm fruit from their electromagnetic properties to be used in ripeness detection model. And the next step is needed, which projects the transmission coefficient into the electric permittivity value contained in the fruit.
Okay, so let me confirm again. Let's say your theory already validated, okay, in the experiment, laboratory experiment.
Yes.
And then what kind of plan will you apply, whether you want to bring your system to the palm oil field, okay, or just put it on the station when there is the conveyor belt, the palm oil fruits go flowing on the conveyor belt, which one you want to use on the applications. So yeah, you can, I mean, compare with the literature or compare with the other methods already applied. Do you have any idea in the future for that one?
Okay.
Yeah.
The data in this research, I will to use palm fruit ripeness characteristic specification, and I will to using the data radar FMCW to detect the palm fruit ripeness. So I must to knowing the characteristic of the palm fruit in unripe, ripe, or overripe.
Okay, so you're using microwave, right? And then
Yes.
the methodology, what you call this free space measurement. And
Yes.
there is a gap between your horn electrodes
Yes.
and then the fruit itself. Any relation with the distance, any effect on there, or you just just as small as possible? Or what do you think?
Okay. I do measurement the palm fruit ripeness using free space measurement. I don't using the factor of range
Distance, range,
about
okay.
the object. I will using the stay on object, and I use the horn antenna directivity to object
Okay.
the
Okay.
oil palm fruits.
Okay, so currently at the moment you didn't consider it yet, right?
Yes.
So yeah, I believe there is some effect. So I would like to suggest to you that perhaps you have evaluate what is the best distance between the horns, and then you can evaluate whether, let's say, you get the 10 centimeter distance is the best way, and then how you can apply at the conveyor belt or at the palm fruit field. Okay, and then my last question is, your results show that the ripe fruit, palm oil fruits, is higher than the unripe, right?
Yes.
Any threshold value between the unripe and ripe? Yeah, we can say, okay, higher is ripe, perfect ripe. But what is the threshold value? Any consideration for that previously?
Okay. I don't have the threshold about the ripeness of the fruit. This research, I want to know the sensitivity frequency of the ripeness of the fruit.
Okay.
So I don't have, I don't know about the threshold. This is just to know about the frequency sensitivity to ripeness the fruit.
Okay. So before you use your palm oil fruit, this is the ripe, this is unripe. How did you consider this is the ripe or unripe? Whether is it based on visualization or other tools that show this is ripe, this is unripe?
Oh, I know the ripeness of oil palm fruit just for visual
Visualization, okay.
visualization, just
Okay.
visualization. So I in research know want to know about the characteristic of the electric of
I see, okay.
ripeness of palm
Okay.
fruit.
As I know, the microwave system is very high cost, very expensive, right? So, and one of the main factor in the accuracy measurements, maybe you remember that yesterday, one of the Bob Patron company, they show that they replaced the coaxial cable by using the optic cable. So there is a effect when you change, there is a cable movement, your measurement will be affected. So there will be some, it's my suggestion to you, because when you want to know the ripeness, when you didn't know you don't know the threshold itself, then statistically you have to make sure that your measurement is accurate. Okay.
Okay, thank you for suggestion. Thank you.
Yeah, thank you. Very good research. So thank you, Miss Yosi. Let's give her applause for the presentation. And then we can go further for the last presentation from this session. Is the sorry, I forget the name. Where is the list? Oh, Mr. El Tahir, I'm sorry. Yeah, Mr. El Tahir, are you ready? You can go.
Yes.
Yeah, please.
Assalamu alaikum, everybody. I am very glad to make a presentation for our paper, which inshallah will be presented in the coming conference. The paper title is Rapid and Efficient Facial Landmark Identification by Light and High Resolution Network Using Artificial Intelligence. I'm Dr. Muhammad Al Tahir, lecturer at Jazan University in Saudi Arabia, and I have many co-authors with me. In this paper, we have take images, either still image or frames from video, from a face image. Landmarks points are identified. We choose a BOI, point of interest, from the landmarks points. Based on the landmark points, we segregate the ROI, called as a block of interest. And on the ROI, we applied cuckoo searching methods to identify most important part of the face to be considered for our experimental evaluation. There are total 86 landmark points, and point of interest are chosen based on active region of interest of human face area as shown in the. But in this block representations, we have take into consideration of 5 parts: 2 eyes regions, 2 lips, and 1 nose region for feature heat map. It is obvious that heat map based approaches are well known for their exact accuracy in landmark position prediction, and TINI, excellent resolution networks, may accomplish quick estimations. The TINI high resolution networks thrown have been successful in connecting feature maps of varying resolution, because the fusion block is constantly a fair in completion. But the SORM does not make use of powerful output module seen in high resolution network. We propose an entirely novel design called SORM to address these issues. Using multi-resolution feature maps and an innovative fusion block, SORM Plus improves in 2 ways. First, it reduces the processing timing of its output module. Secondly, the incorporation of SORM greatly improves baseline techniques while keeping the latest and exactness at the cost of computation. We have used workflow dataset in this study. It has total 7,500 images of training purposes an additional 2,500 images for testing. The dataset contains a total of 98 landmarks and include comprehensive feature labels like large poses, expressions, illuminations, occultations, and blur. But in addition to that, we utilize 300 wheel dataset that is commonly employed dataset for face alignment, about 3,000 training images, 670 validation images, and 619 test images are included. A total of 86 landmarks have been accurately documented in the collection. A total of 550 photos make up common subset of the validation data, while 140 images make up the difficult subset. We have achieved an experimental outcomes as shown in the following table. Table 1, experimental outcome of accuracy workflow dataset by enemy metrics. We have achieved the experimental outcomes as shown in the following chart. Figure is the statistical evaluation result chart of workflow by enemy metrics. We have achieved an experimental outcomes as shown in the following table. Table 2, evaluation result of a statistical chart of MSE loss detections. Graphical representation of MSE loss detection chart is as follows. The figure is the statistical evaluation result chart of MSE loss detection. The conclusion, however, the methodologies applied herewith can be incorporated in predicting human pose estimation, identification of particular face from social networking sites like Twitter, Facebook, and other media. So our next step will be focusing on the aforementioned area. These references. Thank you very much for attending and giving us the chance to present our presentation. And thank you very much again. Assalamu alaikum.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you again, Mr. El Tahir, for your presentation. Quite interesting. And then, do we have questions again from the audience? Okay, I have a simple question. From your study, what is the application? Are you going to apply for the video in the CCTV or just photo or something? You said that from social media?
Yes, we can take a social media as a case study. By identifying the landmarks from the faces, we can identify who is this guy or who is she, and so on. And we also, it can be applied in the driver, that while they are driving in the street and so on, as an example.
And from your study, did you use video or just a photo, static data?
Photos only,
just
only
photo.
photos.
Okay.
Only. Yes.
So from your methodology, can you consider the sex of the people, whether it is woman or man from the face, or maybe emotion like sad, angry, or just face topography?
Yes, we are taking the photos or images as a case study and as example, and we cannot identify this guy or this man, he is sad or not, but we can helping in identifying people, that in the social media by their photos or images.
So it's just detect the face, right?
Just detect the face, yes, based on the landmarks, that by these 5 features like lips and that and nose and so on.
Okay. So in order to detect like eyes, nose, if I'm not mistaken from your slide, you were using Coco search method, right?
Yes.
Coco, or what is it? Can you explain a little bit more? Because I didn't see from your slides.
Yes, it is. I did not mention because that it's one of the methodologies for the searching. We are dependent on it in our experimental and to be applied, that in the data set to helping us to identifying, that the images based, that on the feature as I mentioned in the paper.
Okay, I see. So I don't have any comments. So thank you so much from your presentation and your answer. From the audience, any comments and response again before we close? So I think that's all. Thank you so much for your attendance, for your presentation at this this session. Before we close, we would like to take your photo. Okay, I think Miss Leah or who will take the picture from the committee?
Yeah. Kalau complete. Okay, pictures already taken, Pak. So you can.
Oh,
close
already
the
taken.
session.
Okay, thank
Yeah.
you so much. Thank you.
you.
So before we close, I would like to remind you again one thing. The end will be 3:15, and then the keynote speech will be 3:30. Currently, the editor will send you email regarding your manuscript. We are in the process of proofreading. So once you get the email, please respond as soon as possible because we would like to submit all the manuscript to the IEEE for the proceeding. So thank you again. I would like to appreciate for all of you. Have a nice day. Thank you. See you.
Thank you, Mr. Maris. Thank you. Assalamu alaikum.
Recording in
include
progress.
classification, recognition, prediction, and part approximation. Generative Adversarial Network. A generative adversarial networks, or GAN for the short, developed by IDN Goodfellow in your research in Montreal. GANs are networks that specialize in generating data for this framework used to two networks. The generator, which learns to transform the input into synthetic data, while the discriminator receives real data and generate data, and try to learn to differentiate these two sets. The training of this network is done simultaneously and competitively, with the generator training the discriminator so that it cannot differentiate real data from fake data. In order to train this network, we create a dataset. And for this model, the database was generated using a CAD formula equation. Initialized, we generate 500 frequency sample in a range from 1 to 30 gigahertz, and we chose the row 2, row 3 substrate with a relative of 3.0 and the thickness 1.75 millimeter. For this value, the ordered parameters of the microstrip antenna were calculated using the formula CAD. The data set was composed of 7 antennas characteristics. This is begin the frequency, thickness, relative permissivity, and antenna width, antenna length, directivity, and bandwidth. GAN model.
The configuration of the GAN model used this work is as follows. The discrimination model has a corresponding input layer of size 7, the characteristics of the antenna. 3 follow connector layer of size 512, 256, and 128, and an output layer of size 1 corresponding to binary classification. The generation model has one input layer of size 100 corresponding to the latent space, and 3 fully connected layer of size 128, 256, and 512, and on layer output of size 7 corresponding to the 7 characteristics of these samples. The model was trained on a dataset with 100 samples during 5,000 epochs. For the MLP model, the following configurations were defined as input layer of size 3, corresponding to the 3 characteristics input, 3 fully connected layers of size 512, 256, and 128, and an output layer of size 4 referring to the 4 parameters that must be calculated. And this MLP model was trained on dataset with 100 samples during 2,000 epochs. Numerical experiment and result. After completing this training of the GAN and MLP model, the following procedure was carried out to evaluate this model. The first, we generate new random sample using the GAN model. Among these samples, we took data corresponding to frequency, thickness, and the relative permissivity. Then, we paste these values to the MLP model in the CAD formula equation and obtain the antenna width, antenna length, directivity, and bandwidth. Based on this result, we carried out a comparative analysis between GAN and MLP models and generated with the expected and calculated by CAD equation. And in this figure, show you the result of the antenna width value, calculated by CAD formulas represented by blue circle, with respect to the width values generated by the represented GAN model by a circle in red, and MLP model represented in gray circle. Analyze the frequency band, we observe that from 1 and 5 gigahertz, the data generated MLP and GAN very close expected values compared to the frequency band. This leads us to the conclusion that there is a great degree of similarity between data points with this range. Result, length of the antenna. This figure presented the comparison between length of the expected antenna and tools generated by GAN and MLP models. As we can see, for this frequency range from 1 and 30 gigahertz, both models that we want to generate a data similar to this expected. And some samples, the GAN had a better approximation, but MLP model has a better performance. It can be seen in this figure that both the antenna obtained by the MLP and data generated by the GAN are close to the expected values. When analyzed the frequency band 1 to 30 gigahertz, the speeds are small different between these bands. The MLP network showed superior performance compared to the GAN. And the next, a result bandwidth of the antenna. Is evidence that both the data obtained by the MLP and GAN exhibit a high degree of similarity with this expected value. As the frequency range increases, we continue to see good similarity in these values. Notable In figure with the frequency 100 of this 1 to 10 gigahertz, both models deliver a favored result. Assessment for error obtained in this dataset. For each of these comparisons described in this result figure, we obtain a set of errors to evaluate this model occurrence. In the case of the antenna width, the average relative error, MRE, research a value 3.25%, a high value when compared to the error values obtained by MLP model, 0.6%. In all these comparisons, the MLP consistently outperformed again. This can be attributed to the fact that the MLP learns to compute the set of pictures from the input data, wherever in the case of the GAN, its focus is on learning to synthesize new data from the straight set. For the conclusion, in this article, we propose and analyze two neural network models for the patch antenna design, and both GAN and MLP show excellent results in data generation. The GAN model proposed was able to learn the relationship between the characteristics of the antenna and their respective geometry, thus create a realistic synthetic sample that meet the established performance requirement. And the MLP model, as expected, also delivered outstanding results, as it could obtain output characteristics from input data, even outperform the GAN's result. Thank you everyone for your attention.
Okay, thank you, Sylvania. Is there any question for Sylvania? Or if not, I want to ask a very simple question because the time is very limited. Between the GAN and MLP, which one is fastest when you do the comparative analysis? And then how complex is the patch antenna you use in this your work? Thank you.
Okay. For the MLP model, it's more faster than GAN for train. But when you compare for this trend, it's not too more longer for to train the GAN. And for when I compare the MLT and GAN results, the GAN, the MLP is better than GAN, but it's more different and more different. The model to train into to use, because MLP is more simple and just do input in enter, and MLP calculate all this, but they get more complex for this because they can model to try to understand what is characteristics and the train to generate this data. And when you use for the this training, you use always characteristics for the GAN, and the GAN is kind of try to understand and all these calculation and try to generate a new data.
Okay. So thanks, Sylvania, for the presentation. It's very informative presentation. Miss Pauline, maybe we can move to the next presenter, okay? Because there has a keynote speaker after this session. So Miss Pauline will ask the next presenter, if you don't mind, Miss Pauline.
Okay.
So we go to the next presenter. Thank you, Sylvania, for this presentation.
Good morning, everyone. Thank you for the chance you give to me to show my research with the title Artificial Periodic Structure for Bandwidth and Gain Enhancement of Vivaldi Antenna Used in GPR Application. My name is Kurnia Paranita. The abstract of this research, Vivaldi antenna was designed for ground penetrating radar application which can work well at 2-band frequency. The antenna is made with FR4 substrate and then copper material with a thickness 0.035 millimeter. The basic antenna dimension has 69 multiple 69 millimeter. To improve the performance of the antenna, an artificial periodic structure made of copper was added which aimed to widen the bandwidth, increase the gain, and reduce the antenna side loop level. From the simulation result, that the additional of 1 multiple 6 single structure APS can effectively widen the antenna bandwidth to 30% wider than the basic Vivaldi design, and then increase the gain 9.7% decibel, and then reduce the side loop level 5.5% decibel. Go on to the next introduction. Ground penetrating radar requires an antenna design with wide bandwidth, high gain, and compact size, so it is easy to carry everywhere. The next, so far the antenna used for GPR application are limited to detecting objects at shallow or deep depth, so it is less efficient to use antenna for different purposes. And then the last, in antenna design for GPR, many techniques and methods are used to meet shallow and deep penetration requirement, include configuring array, adding reflector, adding dielectric lens, and then adding slot to pads of the antenna. The intermittent problem of this research, configuring antenna into array, the purpose is to increase the gain. The other method is adding dielectric lens and then installing reflector near the antenna. The purpose is to increase directivity, and then we installing additional slot of the parts of the antenna to widen the bandwidth. And then in this result, we adding artificial periodic structure. The contribution of this paper is enhanced bandwidth, increase gain, and suppress side loop level. Here the basic design of the antenna, and then this is the value of dimension of the basic antenna. Next, this is the IPS design. The basic APS design, there is LO and LI, length outer and length inner. This is the gap, and this is the width. Then the modification we use for LO and for LI. The realization of the antenna, this is 1 multiple 6 single layer APS, and then this is the 2 multiple 6 single layer APS. Here is the result. We compare basic antenna design, simulation, and measurement result. From this graph, we know that the measurement result is better than simulation result. And in this measurement, we use VNA that has a limitation work in, it is below 6 gigahertz. So the measurement result is until 6 gigahertz. Here is the design antenna with adding APS, adding 1 multiple 6 single APS. We know that the widen bandwidth is from 1.3 gigahertz until below 6 gigahertz. And then this is a 2 multiple 6 single APS. This is the graph. We can compare the basic antenna and then the antenna with adding 1 multiple 6 single APS, and then the blue one is antenna with adding 2 multiple 6 APS. Here the summary of the gain and half power bandwidth performance result and bandwidth within bandwidth result. Design 1 is the basic antenna. Design 2 is antenna with adding 1 multiple 6 APS, and then the third design is 2 multiple 6 single APS. The return loss, the base return loss is the second design, and then the set loop level, the lowest set loop level in second design too, and then the half point bandwidth. Design 1 is the narrow beam, and then for the gain, the base one is design 2. Summary of bandwidth performance. Bandwidth, the video bandwidth is achieved by the third design, 1.79 gigahertz, and then in the second band, the second and third design have the same bandwidth. It is 1.28 gigahertz. Then we go on to the conclusion. In this result, Vivaldi antenna was designed for GPR. It can work well at 2 bands, and then in the antenna design, artificial periodic structure material was added and was placed on the right and left side of the antenna. The aim is 3. The aim are 3. The first is to widen the bandwidth. The second is to increase the gain, and then the last is to suppress the side loop. By adding 1 multiple 6 single APS structure, the gain result will increase by 9.7%, bandwidth widened by 30%, and a decrease in side loop level is 5.5%. Meanwhile, the addition of 2 multiple 6 single APS structure has the effect of widening the bandwidth by 35% greater than the basic antenna design. From it all, the best design achieved is antenna with 1 multiple 6 single APS. Here our reference. And then thank you for your attention. I'm sorry for many mistakes.
Okay, thanks, Ms. Kurnia, for the presentation. It's very informative presentation. Is there any question for Ms. Kurnia? I'm really sorry. We just need one question for this session. Is there anyone want to?
Pak Yuyu nih.
Oh yeah, Pak Yu, go ahead, Pak Yu.
Okay, thank you. This very interesting, yes, for your antenna. And have you applied in the GPR system your antenna?
Now I'm still design and fabricated it, and then I measure in the chamber room maybe for the next, it will release in object to measure to an object, Pak.
Not to
Yes.
not to GPR system, no?
Yes, in GPR system. For the next work, maybe for my supervisor asked me to implement this antenna to measure object underground, maybe for the logam.
Metal, yeah, metal.
Yes, metal object first, and then we will try to make many layer, such as in
So ITS have the sandbox, yeah,
soil.
sandbox for the GPR measurement.
Yes.
Sandbox, you have? Yeah,
Yes,
okay.
in media. In a media with sand, and then litter, and then soil like that, Pak.
Yes, yes, yes. Better
Yes.
you saw the GPR system, yes, I think, yeah. Okay.
Yes.
I think this is
Yes.
enough for the ultra wideband, because ultra wideband more than 25% bandwidth, yes, and you have 35%, yeah, 35%, yeah. I think
Yes.
enough for
Yes.
the GPR. Thank you, Pak Aditya.
Thank you, Pak Yuyu,
Yeah, so.
for your advice.
Okay. Welcome.
Sorry, mic.
Mute Pak Adit.
Okay, we already heard from 5 great presenters today. Thanks for all presenter, and I would like to thank all the participants also for their attention and participation. Thanks for your time. I hope to see you at the next conference. Don't forget, there's still one keynote talk that will be presented in the main room. Thank you all.
Recording in progress.
Okay, ladies and gentlemen, we have completed the 18 paper presentation sessions. I would like to thank all of the presenters, session moderators, and also participants for the fruitful discussions. We hope that it can aid you in your next research endeavor. We have come to our final keynote talk, which will be presented by Professor Iyatayu. This keynote talk will be moderated by Dr. Agus Subekti. I hope that Dr. Agus Subekti is already here with us.
Yes, I'm here.
Okay. First, I would like to introduce to you about Dr. Agus Subekti. He obtained his bachelor's, master, and PhD all from the Bandung Institute of Technology in Indonesia in 1998, 2001, and 2016, respectively. He joined the Indonesian Institute of Sciences, or LIPI, back in 2005, that now has transformed into the National Research and Innovation Agency for Indonesia, or known as BRAIN. Currently, he leads the research group of electronic systems and signal processing. His current research interests includes cognitive radio, vehicular communications, and machine learning. Please welcome Dr. Agus Subekti and also Professor Iyatayu.
Okay, thank you, Ardita, for the introduction. distinguished participants, ladies and gentlemen, and our distinguished keynote speech, Professor Iyad Ayub. Thank you for joining with us in this afternoon or in the morning in another space. Hopefully you are in a good condition. Before we start our distinguished keynote speech from Professor Iyad Ayub, let me introduce Professor Iyad Ayub. This talk is towards 6G standardization, use case, and emerging technologies application to intelligent transportation system. Professor Iyad Ayub is a professor at Université Polytechnique House of France. Bonjour, Professor Iyad Ayub.
Yes, bonjour, Dr. Agus. Thank you very much for this. Yes, for
Okay, let's
me.
introduce a brief introduce. He got his, I believe that is mistype. I believe that Professor Iyad Ayub graduated from University of Valenciennes, and he got his master also in France, and bachelor in Syrian University, and currently he is a professor of communication engineering and head of telecommunication technology intelligence system department at Université Polytechnique House of France. And before he was a young professor at Concordia University and member of National Council of University in France from 2007 until 2014, and then he has also various job in private sector, I believe, and his research interests include telecommunication and ITS. Professor Iyad Ayub, I think you may introducing yourself more, and hopefully everybody will enjoy that. 6G is very important topic after now 5G in the market. So I believe that everybody wants to know what will happen next technology, because that's technology from 4G and 5G and 6G is very fast, and we will contribute more especially in the research. What is the key technology in the future? We would like to hear from Professor Iyad Ayub. The time is yours, Professor.
Thank you very much, Dr. Agus. I'll first share my screen, and please let me know if everything is okay.
Yes, it's perfect.
Yes. Okay. Thank you so much for ICRAMET and to invite me for this conference. Actually, I would like to give a talk on 5G and beyond, or what we now call clearly 6G. In particular, I will go towards 6G through new use cases, and these new cases will allow us to understand why we need more and more data rates, why we need less and less end-to-end delay, and why we need 100% of transmission, sure transmission with maybe zero probability of errors. So first of all, I will of course introduce you my institution, where I come from. Actually, I am a professor at the IEMN, which is Institute of Electronics, Microelectronics, and Nanotechnology. This huge institution is located, as you can see here, in 5 areas. The mother, lab, or the father lab, as you want, is located in Lille, Villeneuve-d'Ascq, and we have 4 other buildings in the north of France, in the region Hauts-de-France. Actually, our activities are, are clearly here. You can see 9 flagships. Okay, directly we are directly related to, as you can see, telecom UHD, transportation, IoT, and also all the intelligent layers leading to the fabrication of our own sensors and own composites. The institution is divided into 5 departments, sorry. I will just so materials, micro and nano biosystems, nano optoelectronics, and acoustics, in addition to our departments, which I'm leading since 2 years. So the presentation, the presentation will be as follows. As I said, in order to better understand why we go towards 6G, knowing that we are not fully now in 5G. I will go through use cases. This is better. Then I will present the evolution in the standardization organizations, in particular in the 3GPP organization towards 6G, and I will present current and future enabling technologies for 6G, in particular the millimetric wave communications. Why? Because I will go through this enabling through new use cases which are now considered for maybe standardization actions in the next few months. And at the end, I will present one demonstrator, which reflects directly these new cases. Now, of course, why ITS? I think that ITS, in particular, vehicular communications and also telemedicines, are the 2 concrete use cases, the 2 concrete applications, which will, of course, include a couple of use cases, and which will require actually very strong constraints. So let us start by vehicular communications. Everybody now knows what is V2X. It's a kind of communication from vehicle to everything surround, and everybody maybe also understand now how V2X support the global vision of ITS communications. What is the global vision of ITS? The choice of ITS is, again, just to focus on realistic use cases or group of use cases. So ITS, as you can see, the green color, that does mean, smart and clean, if I can see, way of communication between all equipments which may facilitate our life. So ITS, in addition to vehicles, of course, we have rails, we have maritime, aeronautic, and also smart cities. And the green color is to say further, I mean, clean, less pollution, less power consumption, and safety also. So regarding the nowadays problems related to ITS, from the root side, okay, we will be, I mean, fast here. We will go quickly. We know that we are suffering from a safety problem on our roads today. We are suffering also from the congestion and the influence of this congestion on the productivity of the society, and also from the pollution and all environment issues. So just to give you some statistics from the I mean World Health Organization, 1.35 million deaths a year because of these problems. And you can see here, I mean, most of them, unfortunately, they are either children or young people. So again, the I mean, economic cost of these problems is really very tough. Here, the NREX gives the statistics last year regarding the highest traffic daily times by city in the major cities in the world. And here we have, of course, the economic cost. Okay, I will not detail. Everything is here. You can see we lost a lot because of these issues. So this is why the organizations, standardizations, I mean the standardization organizations try to face these problems. So by maybe defining, first of all, new use cases or group of use cases. In the case of vehicular communications, as you know, we have a couple of this group of use cases, starting by autonomous driving, through platooning, collision, and emergency, etc. So just to give an idea, regarding the smart autonomous car, you know, this is the famous Google car. And regarding this use case, autonomous driving, the autonomous driving can be done through either a remote driver. This driver is, driving this car wirelessly, of course, or through smart applications or embedded applications on board, or downloaded applications through the cloud. I mean, in the both cases, of course, I mean, the radio interface must respect strong constraints in terms of, first of all, high data rates, end-to-end latency, and equality of services. In particular, I mean, zero or maybe close to zero probability of errors. Otherwise, we have, critical problems. This is why, starting, from now, we will split communications into two categories. First, no critical communications, and the second one, critical communications. Before these use cases and before this, applications and new applications and new services, we used to be aware of no critical communications. And for this kind of communications, the constraints were, really less strong than now, because no problem if we do some errors, no problem if the communication is deleted, and no problem if we don't have real-time reaction when an event is going on. So now to better also understand another use cases, platooning, why we form Platon, it is just to maybe save energy, to be environmentally maybe friendly. So for forming a platon of vehicles or of trains, we will see later, we have the pilot, I mean leader of this platon, and members belonging to this one. So while doing that, we must allow a vehicle to join us or to leave us. And when joining a platon, it should be aware of the environment in order to, I mean, in order to not maybe doing an accident here. So on the other side, while forming a platon, this vehicle, for example, must be aware of this one, and in that case, it should be in self-driving mode in order to stay here and not to follow the leader. It's just an example. So here you have this video, and you have U-Blocks products, and we can see some of crash prevention group, cases, use cases with the driving assistance, with the awareness of the environment, and how, can this one maybe will react smartly in order to avoid an accident. So anyway, I will maybe stop here. I will not go through this use case, which will, apply computer vision and real-time transmission to this one through, this computer vision, in order to, force this vehicle to stay here and not to come and to face this one. Okay, so to do a resume on that, we have, of course, this critical communications, which will need, of course, real-time quality of service, reliability, less and less latency, and more and more intelligence. So on the other side, the other side, ITS, other side terrestrial, we have also a train. And here in Europe, a train or railway, becomes, railways become really the major transportation mean for people. So let us explain something. The only wireless system operating now for rail is the obsolete GSM version railway. So this one is already finished. Why? Because no fabricant will produce equipment for GSMR anymore, and in 2027 this one is completely stopped, dead. So with a similar manner to vehicular communications, railways and the trains are going also towards automated, driverless, and autonomous trains. And it is a reality, actually. And some new use cases are now clearly, not only in the literature, but they are discussed inside organization standardizations. So how to go towards T to T, train to train, train to infrastructure, and also communications intra-trains. So all these type of all these use cases require, of course, the same thing. That same constraints like in vehicular communications. More and more data rates, high reliability, low latency, and in addition, this is more or further complicated compared to vehiculars, resilient to technology. Why? Evolution. Because the life duration of a train is at least 30 years. So in 30 years, as you can see, we can we can see at least 3 generations. This is why what is prepared for railways should be resilient to the evolution of generations and of communications. So in Europe, the FRMCS is actually fully, under full consideration, future railway mobile communication systems. So in 2 words, the FRMCS has been launched 9 years ago, and the one of the objectives, in addition to create a technology independent and resilient, they have also and they are also preparing new use cases, and we will discuss the enabling wireless technologies, enabling us to reach these new, to realize these new cases. In particular, driverless train, virtual coupling, and decoupling. Today, if you take the train from Paris to Amsterdam or to Brussels, in the north of Paris, we will, in a small town, Arras, for example, the train will be split into 2 trains. One will go to maybe Amsterdam, and the other one will go to London. So this decoupling is done physically in the downtown and in the gas station, but this requires that the old train will go through the downtown and it will stop, and it will contribute to further pollution and to further energy consumption. So this is just one of these use cases. So virtual decoupling, that does mean a train while moving, it will be able to do this splitting without going through towns, for example. So I will now, it's okay, just the major project in Europe for this translation, for this shift to the rail as a major mean of transportation. The project is Shift to Rail, and the vision, it's, by the way, an undertaking between public and private partnership sector, and the challenges for European countries are the following. How to converge to one single European railway area, what we can call SERA. So main objective of this SERA is here in green color, model shift from road to rail to achieve a more competitive and resource efficient European transportation system and more resource efficient transport system. I will just give you an example. Since last July, no way to find a plane from Paris to Bordeaux. I mean, the ALO has been voted, and for distance less than 300 or 400 kilometers, no way to find a plane now. The connection between these cities must be by trains. So, like that, I mean, we can understand now what does it mean an adaptable communication systems. Adaptable communication system, and it's by the way new conception of communication. Adaptable, that does mean resilient to technology and to the generations. Secondly, diversity of solutions. And I mean, what does that mean? Realize a specific function. We have all the functions here. And this interface radio is between these functions on board and the same, on the infrastructure. We have different possibilities either through Wi-Fi or 5G and beyond 6G or satellite communications. And we have, by the way, new specifications for this kind of applications. I will not go through these specifications. It's not the objective of our talk today. So now arriving to wireless communications and cellular networks. We can understand now the evolution, in parallel to these new cases, of course. So this is here what we have today. We have these generations, and now just two words regarding, the majors in these wireless communications. Of course, 3G. In 3G, we introduced wideband through CDMA, and thanks to these wideband communications, we started obtaining a couple of megabit per second. In fourth generation, and thanks to OFDM and MIMO, multiple antennas communications, we actually we had basic services related to IoT and V2X communications. Of course, in the beginning, it was just V2V or V2I, but in the 2015-16, we had X to everything. Regarding 5G, we will detail a little bit this 5G, in particular, extended use case possibilities and innovative products should be delivered in this 5G. So please, in the 5G point of view, and in particular for the 3GPP, standard, we have three pillars. Of course, first off, the EMBB, what we call high data rates, enhanced mobile broadband communications. For this, let us now define what's a pillar. A pillar is a vision of the 5G, which will which will be used by maybe more than one of these new cases. So what is EMBB? The basic version of the 5G. It was simply more than 4G. So compared to 4G, faster data rates, less latency, more reliability, and maybe enhanced coverage ranges. The second pillar is all, the second pillar concerns, of course, all use cases directly concerned by the latency, all these critical, communications. And here we are speaking about maybe 100% reliability, 1 millisecond latency, or even less. Today we are speaking about 0.1 millisecond latency and a packet error ratio of 10⁻⁵. And the last pillar is about the densification of equipments. And here, of course, we are speaking about, between others, machine to machine, device to device, or IoT devices. So here, of course, large number of devices, low power, low cost, and low complexity, in addition to, of course, the use cases related to this pillar, in particular, of course, under the strong constraints of power consumption and cost. So we will also speak about something new, which is 5G RedCap. Researchers now are speaking about a new pilot. It's not standardized, of course, but we speak about reduced capacity of all these pillars. This is why we call 5G RedCap, and here we can consider, a compromise of these three pillars. So here an example of use cases in ITS systems and how we can do this mapping between pillars and use cases quickly. All use cases related to extended sensors, collective perception, video sharing, of course, EMBB. Here we are about latency and remote driving. Here, for example, densification, of course, we speak about software updates and dynamic sharing. So what is behind now 5G? So this will present the works going on actually now in side organizations, standardizations. So we started by EMBB release 15, 2018. Now we are here. So EMBB, URLLC, and the third pillar published by the release 17, and today we are in 5G advanced. So what is expected is in the earlier 2027, some maybe basic 6G recommendations will be edited. So we speak about 6G basic, like here 5G basic, or we will have this 5G advanced on again for maybe 1 year more or 2 years. And first services, 6G services, are expected to be commercialized in the earlier 2030 or 31. So now let us go through the 6G vision. I still have maybe 25 minutes, it's okay. So 6G vision. So the predictions of up to 10,000 times increase in wireless traffic compared to 5G. We will see why. Actually, we will support new services, including all applications of telemedicines. And you know, all of us, I mean, we are now watching some, or we hear about operations through, I mean, wirelessly, using maybe robots or something like that. Anyway, so we have new services. We still have new group of services to be also added to ITS, and we will have also smart city applications. So all these new use cases or group of use cases will require, of course, the following. So let us please go to what is done actually and what is expected through the 6G. So today, 6G is in the process of pre-standardization. So all what we will present here, please, we have to be careful because these are some visions of the players, major players and researchers in the area, but nothing is already standardized. So regarding the first pillar for 6G now, we are speaking about EU MBB, which is enhanced ultra-mobile broadband, and of course, the same thing, higher capacity networks to accommodate massive number of devices, okay? Applications such as telemedicines, autonomous vehicles, smart cities, so we need reliability, availability, security, and also we have to enhance the radio range. The second pillar, EMMC, enhanced massive machine communications. In 5G, we used to have massive machine type communications. So here we have, of course, new services expected for IoT. I will give you an example. Today, I have just published an offer for a PhD supporting by an industrial. And the topic was IOVT and not IoT. What is IOVT? Internet of Video of Things. So now IoT is not a sample data sent through sensors. Actually, IoT today will be, or tomorrow will be, of course, based on video sequence transmissions. So here, I mean, quickly, we speak about a huge number of devices per kilometer square, and of course, a spectrum efficiency will be huge, of course. So the major challenge will be here, the power consumption. So main challenge is extended battery life, so minimizing signaling overhead and optimizing hardware implementation. What does that mean? Intelligence artificial here will play a major role, of course, to reduce the signaling overhead. So database and intelligence artificials will be major here player in order to reduce this phase. And what I will explain is through a specific project and the specific enabling technologies, which has been forming and millimetric wave for rail later. And we will understand why intelligence will be here crucial. So the last pillar, EURLLC, enhanced ultra reliable low latency communications, and here we are about no latency. So 0.001 millisecond, of course, with 100% reliability but here, please, I just will mention something. No, I mean, the concept of cell will be here, will disappear. Sorry, will be completely broken. So we will have a free cell. What does that mean? The cells, like we know with, I mean, zone and coverage zone will be completely replaced by the new vision of a free cell. So no cells borders, and the base stations will be, of course, replaced by access points with the help of some PCUs on buildings. And this is another subject. Of course, I will not go through this today. So, like a resume, please, we can see now the KPI, what we call, I mean, the key performance indicators for the 6G. So by moments and by maybe zone, we will reach 1 terahertz communication. And this is, of course, the vision. So, of course, from the standardization point of view, till the 5G, we used to have different groups for the standardization. A group is in charge of modulation, group is in charge of channel coding, and so on. Here, of course, we will see the cross relationship in anticipated to 6G through defining of groups. Actually, a group's indications should all be met at once. So, polyvalence, one group will be, must be, should be aware of all applications, and one researcher working inside a group should be, I mean, should have knowledge in wireless, in math, in intelligence of computer vision, etc., etc. Now, I'm about the last part of my presentation, so I still have, I think, 15 minutes. They are sufficient to concretely, I mean, give you an example of enabling technologies and how to map these enabling technologies with new use cases, in particular from the railway area. So just before, and quickly, please, I will present some future enabling technologies for 6G. I will start by full duplex. Okay. What is full duplex? Actually, up to now, we have, or all previous generations were or are only half duplex. So that does mean a transmission schemes in both, I mean, transmitter and receivers are separated either in time, like we can see here. We have different time slots on the same frequency for the transmission and the reception. So in that case, we lost, of course, here, half of these time resources. All in frequency. So we share time here, time slots, but we are on different frequencies. Like that, we speak about uplink and downlink. So we have, I mean, only half frequency resources. And here, of course, we are, in both time and frequency division duplex. So the loss here is more than here. Have a look, please, on this new, scheme or configuration. Here we are about to send and to receive on the same frequency band and at the same time. So we are speaking about full duplex communications. So systematically, we double the number of available resources. So if we can do that, what does that mean? If this emitter can send and the receiver of the same equipment to which this emitter belongs will receive on the same frequency, we will not need anymore uplink and downlink. So we send and receive at the same frequency band. We double the frequency resources. And if we do that at the same time, we speak about full duplex communications. Well, the problem is, this is good to say that, but the problem is when we send and we, I guess I have to, yeah. The signal, X1, so X1 is also received by the own receiver of the sender. So X1 is here, and here is, I mean, designed to receive not X1, but X2. And X1 is 135 dB upper than the expected signal, I mean X2. So we speak about self-interferences, and this is a major challenge in this communication. So 2 words about this. So we have here 2 possible configuration of antennas, either, I mean, 2 antennas, 2 separate antennas for a device, or 1 antenna with a isolator and circulator. So in this direction, emitter, and in this one, receiver. Anyway, let us take this configuration. So self-interferences not only received by this one directly, but also they are reflected by the first obstacle, and we have the problem double here. Okay, so we have self-reflected, and we have the noise of the radio channels. So this is the challenges, how to deal with self-interference cancelers, how to deal with self-interferences. So we deal with SIC, self-interference cancelers. If we can do that, we have full duplex communications. In that case, the delay is 0, and we are about 0.01 maybe end-to-end delay. Okay. Another enabling technologies, no orthogonal multiple access. So quickly, please, up to now also we used to work with orthogonal multiple access techniques, TDMA, FDMA, CDMA, or FDMA. Oh, the problem here, the number of users is limited to the number of orthogonal resources. If we still working under this orthogonality, no way to reach 1 terahertz communications. So we have to break this orthogonality. Breaking the orthogonality, we speak about NOMA, no orthogonal multiple access. Quickly, please. Now we have 2 users. We have a base station. So the 2 users will share time and the frequency, but the base station will send a superposition signals with the red part to reach user 1, the here vert 1 to reach the user who is close to the base station. From user 1 point of view, the vert component is not a problem. It can be seen as an interferences because the red part is really huge. But for this one, it's a real problem and real challenge. Why? Because it will receive, in addition to his small part of energy, the whole energy in red color. So no way to detect user 2. We have to do what we call estimation of this one and we here subtract from the old signal this one. So we are about SIC also. So serial interferences, cancellers, this is the major. Just here, please, we have a comparison between OMA and NOMA. So OMA orthogonals, we have one bandwidth for user. All users share the same bandwidth. We can see how NOMA can, improve the spectrum efficiency and the sum rate, the throughput of the network. Now, the last part really, a concrete example with concrete use case and concrete new technologies. And this is for, again, railway, but it could be also for vehicular communications. So I will explain what is the use case quickly. The use case is how to do train-to-train communication in order to ensure either virtual coupling or virtual decoupling. So again, we will need also train-to-infrastructure communication. So train-ground communication and the train-to-train communication, this is the objective. The new use cases, again, virtual coupling and virtual decoupling. So we will go through the beamforming and one new enabler, which is millimetric waves. Please to keep in mind this communication should be also maintaining while the train take maybe some curves or some how to say, maybe through tunnels or while doing some curvature and not on straight rails. So I will not speak about specific radio environments for rails because it's not the subject, but please keep in mind that doing that on railways is the most sophisticated case. The channel is the more severe one, and the noise is not Gaussian at all. And we have to take into consideration also the correlations. So let us go through the solution. What is or what are millimetric wave communications? Here we have the microwave region, millimetric wave region, starting from 30 giga up to 300 gigas, and here we have the terahertz region. So let us focus on this region between 30 and 100 gigahertz communication, gigahertz. So, of course, the main advantage is when frequency increases, the data transmission, will also increases. The drawback when frequency increases, the lambda waveform is smaller, and the problem will be the attenuation, high path loss, in addition to the penetration problems while millimetric waves will face maybe wood or any other materials. So the major is sensibility to blockage, and the millimetric wave is blocked because of both attenuations, absorptions, and penetration. So, but we need millimetric waves, no way to use spectrum under 6 gigahertz because the spectrum is fully used. So what is beamforming? Beamforming to tackle the problem of blockage of this millimetric wave communications. So please have a look on this picture. So we have here a CPU, let us say base station, and this base station is serving these users. Okay. So superposition of waves from multi antennas, because this base station is MIMO or massive MIMO based. That does mean it has a lot of antennas. So the beamforming, the objective is how to do this superposition, and the way to do that is, first of all, to master, this is the base station, how to control the antennas here. This is the base station, the antennas, through fast shifters, which are here. So we will, through these fast shifters, have a set of possible beams, the same thing at the user side. So the beamforming is how to use fast shifters in order to obtain the best selected pair of beams. When we do that, this will be decided. So the antenna here will send on this or through this beam. The antenna here will receive through this beam. So now we will go through this operation, how to do this beamforming. This is a small example. Uniform safety code book. So the one is used actually today from the state of the art, which is very heavy. We will see why not. Why? First of all, we will divide the entire space into beams. We have a step of 1 degree or 2 degrees, it depends. Okay, then possible fast shifters of course, M antennas. Then we will define the azimuth and elevation parameters for each beams. So possible weights will be the elevation, and this beam's index will be the azimuth plane. Like that, we have two coordination. First one azimuth and the second one elevation, and we have completely the mastering the fast shifter and the antenna. So the problem here is when we have to do these two coordination together, we will do the chronicle product and we will have a 3D code book, and this is very heavy. So no way to do that easily. So we have two manner to do, either with exhaustive search. So exhaustive search, all the possibilities, we select the better, and of course, after a training uplink, so base station user, training phase, and then we will have the best pair. It is sent to the user, and we have the connection here. I still have maybe 5 minutes. Here, what we can do. We can do a local research either than exhaustive research. That does mean, first of all, I will do the training steps. We will take a beam at time t. Then, with the time after, I will not do the exhaustive. I'll just be limited to the neighboring beams, because the probability to obtain the, good spectrum efficiency here is important. So like that, we can choose the beam, the pair of beam quickly, but on the cost of of course, the accuracy. So to finish, I have to introduce the channel model 3GPP for 5G and 6G at time I HT, but at time here I plus 1, it's HT plus 2. So the in addition, we have multipath, and we have also all majors related to the reflections and multipath environment. This is why we need to do to update the azimuth and the elevation coordinations each time slot. It's unbelievable. It's very, very heavy. So this is why we will propose. It's my the last part. Still have 2 minutes. This is what we have just proposed to the standards. We will. Okay, this is a comparison between exhaustive and local. Exhaustive, of course, is better, but it's very long. So the more important is here. This is what we have just proposed through this project. So this is the train, this is the infrastructure, and we have here a camera. So through computer vision and image feature extractions, we can find out either the line of sight or what is just neighbor the line of sight. So for Dr. Agus, you know very well this picture. This is the tramway of Valenciennes. Okay. So now we do that, sorry, for time slot T, for time slot T plus, respecting 3GPP, and probably updating the line of sight or neighbors will not be a problem, because probably at T plus 1, the train will be not so far from the position of it when it was in the T. So like that, we can reduce drastically, of course, the exhaustive and local research, and we can go through really the better choice of the adequate pair of beams immediately without any problem. I will not comment on these results. They are under, study to adapt this method, but we are here and between, exhaustive and local, but okay, so and I will finish my presentation. Just I click here maybe to show you how this is applied directly in demonstrators. This is one of our projects, and this train is driven wirelessly through this driver, so remote driving, but the driver is on board inside the box, and he is driving, but not through millimetric wave, through satellite and Wi-Fi communication.
I'm sorry, Professor Iyad. The screen is still in the slide, not in the YouTube.
Sorry, so I think it is okay. So is it okay?
Yeah. Okay.
Yes, I finished. This is my last slide. So is it okay, Dr. Agus?
Yes. Perfect.
Okay. So this is a train in surround Paris. 40 up 50 kilometers per hour, and the portion is about 55 kilometers, and it is completely driven wirelessly. So the driver is here. This is the driver on board, but inside a box, sorry. And the wireless interface is based on satellite communications, because we have as a partner satellite and communication center, and by wireless communication. So, now, measurements are done to do what I presented now, how to focus on a couple of pair directly based on computer vision, and this will finish my presentation. So thank you very much. If you have questions, I will be happy to answer.
Thank you very much, Professor Iyad, for the very informative presentation regarding the current and future technology in 6G. And before we continue with question and answer, I can give some point from the Professor Iyad presentation that the important use case for new technology 6G is especially in intelligent transportation system and in health or telemedicine that require
smart cities also. Smart cities.
And smart city, and yet with the consideration of high data rates, high reliability, and low latency. And then the other point is the evolution of in mobile wireless communication is comprised of 2 and 3 pillars. That's high data rates, and then URLC, and massive type communication machine. Yes. And then the other one is there are 2 important enabling technology. There's full duplex and NOMA, and the Professor Iyad presentation is concluded with the demonstration, very comprehensive about 6G. And I invited question from the participant. If there is a question, yes.
May I can add something, please, for attendees who are familiar with the current and the future enabling technologies. We still have one major technology, but we have no time to speak about. It could be a subject of a talk. New waveforms. Now how to replace maybe OFDM by new waveforms based on filtering waveforms in the time domain. So we can speak about FBMC, OQAM, another waveforms, but mathematically it's complicated and we need more time. So we still have new waveforms, of course, as enabling technologies. Thank you very much.
Okay, thank you very much, Professor Iyad. So I invited question from the participant. Any question? So while waiting a question from participant, I have a question, Professor Iyad. If yes. So from the presentation, you said that 6G will not replace the current standard, but it is complement from the current standard, right? Or I'm wrong?
It's not complement. 6G, we are now, we speak about 6G, of course, which is expected through discussions inside organization standardization. Maybe 2027, we may have a basic release, or which will be, of course, on the border between 5G evolution and 6G, like 5G actually, because EMBB in 2017, release 15, a lot of colleagues, researchers, they were considering this release as a part of 4G evolution.
Okay. Okay, thank you very much, Professor. So there's one question, maybe Dr. Asif, please.
Yes,
question.
okay. Can you hear me?
Yes, of course.
Yes, perfect.
Yeah, just have one simple question. I hear your presentation, and you didn't mention about reconfigurable intelligent surface or RIS. So I'm curious about your view
Thank you very
about
much.
that technology for as an enabler technology for 5G or 6G.
Thank you very much for this excellent question. Actually, I will give you immediately why. Actually, this is, I mean, the beamforming. And we cannot dissociate RIS from beamforming. RIS is a kind of beamforming, actually. So we are doing through code book design, okay? But actually, in parallel, we have this R, not only RIS, but meta surfaces also, when we have the major difference between the two. RIS, so you receive one beam and you may reflected a lot of beams. In meta surfaces, we are, I mean, about to completely, how to say, get rid of these fast shifters through electronics. So, in my opinion, these RIS are coming, and they are a kind of this, as you can see here, this beamforming. Okay, either you do the beamforming with, I mean, code book design and with fast shifters and with antennas, or you have your RIS, okay, and you receive one beam, and RIS will dispatch your beams in more than one directions. So it is related, but I cannot present everything here. I just gave an example, and in this example, my objective was to do this mapping between what's going on in the technological point of view and in the real life through real use cases. So actually we have RIS. I also did not mention SDR and cognitive, okay? Don't mention waveforms. All these are enabling, but RIS, it's not enabling technologies, it's inside massive and millimetric waves and terahertz, a mean of. Is it okay?
Okay, can you repeat what is the difference? What is the difference with the meta surface? You mentioned about meta surface there.
Yes, the difference, we have either passive RIS reflectors or active. Either you consume or you don't consume. Okay, so we use meta reflected surfaces in our lab. Okay, in that case, you can, well, I will not monopolize. If you have have a look please here. We can continue discussing. This is my email page web, and we can discuss this later. Okay, What I would like to say, my objective was to discuss enabling technologies. RIS is not an enabler. It's inside one of these enablers. Is it okay? So this is why I
Okay.
but I'm working on RIS a lot. Okay. If you need anything, we can discuss with pleasure.
Okay, thank you. Thank you,
you
Professor Iyad.
very much,
Thank you.
Dr. Asif and Iyad, this opportunity to cooperate in the set. Okay, actually we have one more question, but I afraid that time is up for this session. So maybe we can conclude our nice talk here that we have, for me, myself, I get a lot of insight about 6G. Thank you very much, Professor Iyad, for the very nice presentation. So we can conclude our talk here, and let me give appreciation for Professor Iyad Dayo from UPHF France for the giving keynote speech for ICRAMET 2023. So let me give appreciation for a token of appreciation for you, and we hope we can continue our discussion for all participants. You could reach Professor Iyad out to this email and web site. And thank you very much, Professor Iyad.
Thank you very much. So
Okay.
just
So,
one thing, as you can see, I'm not in France because it's winter now. I'm in Tunisia, so I'm doing my talk from Tunis.
Okay.
Sunny.
You're not in not in France. Okay.
I'm actually invited in Indonesia, and I do that from the EPT in Indonesia. Okay.
Okay.
Tunisia. In Tunisia, sorry.
Oh, in Indonesia. Okay.
Thank you
Okay.
very much.
Okay. Have a
Thank
nice
you. It
trip
was
in
with
Indonesia.
pleasure.
Okay.
With pleasure.
Okay.
Thank
Thanks.
you very much. Assalamu alaikum.
So, this is from the committee that give token appreciation awarded to Professor Iyad Dayo from INSA, Host of France, and University Polytechnic, Host of France, in recognition for delivery of keynote talks to 20th International Conference on Radar, Antenna, Microwave, Electronics and Telecommunication. So we hope we can see you in the future. Okay, thank you. Bonjour. Assalamualaikum. So I give the session back to the Miss Dita. Please, time is yours.
Thanks to Dr. Agus Subekti and also Professor Iyad Dayo for having delivered our final keynote talk session. So now we are starting the closing ceremony of ICRAMET 2023. Our technical program committee, Dr. Widya Budiawan, will announce the best presenter and best paper of ICRAMET 2023. Please welcome Dr. Widya.
Okay, thank you, Ms. Dita, and good afternoon, ladies and gentlemen. So it is with great pleasure for me that we announce the recipients of the Best Paper Award and the Best Presenter Award at this conference. Before we extend our sincere gratitude to the distinguished panel of judges for their meticulous assessment and invaluable contribution in selecting the best paper and the best presenter. Then, after careful evaluation and peer review, the committee is delighted to recognize Safda Sahin and Tolga Girisi from TOBB University of Economics and Technology, Ankara, Turkey, for their paper entitled A Novel Radar Receiver for Joint Radar and Communication System as the best paper in the 2023 ICRAMET. Congratulations. Okay, next, okay, we carry on. Next, we present award to Asif Aminullah Fathan from Nagoya Institute of Technology, Nagoya, Japan, for the presentation titled Design of K-band Metasynthesis Filter as the best presenter in the 2023 ICRAMET. Congratulations. Okay, so that's all for the award this year ICRAMET, and I give back to Ms. Ardita. Thank you very much.
Congratulations for the winners, and also thanks to Dr. Widya Budiawan and also the technical program committee who has worked tirelessly for the ICRAMET 2023. Now nearing to the end our events, we will have some words from the chair of ICRAMET 2023, Dr. Yuliar Firdaus.
Thank you, Ms. Adita. Good afternoon. Assalamualaikum warahmatullahi wabarakatuh, ladies and gentlemen. First of all, congratulations to the award winners, the best paper and the best presenter. I believe we have come to the end of the 12th ICRAMET conference. We had successfully hosted the event and the plenary breakout session, and all presentations were delivered with minimum technical issues. We had a wonderful patron and keynote speaker. So we had one patron session from Mr. Fun Yen, where he explained interestingly about the long-range measurements with the microwave and RF. And then we had four keynote speakers from Professor Azrul Azmi. He explained about the fiber optic sensor and then its application. Afterwards, we had the presentation from Professor Josafat about the microwave remote sensor and its application. And then we had this, today we had the third keynote speaker from Professor Seto Kensu, where he explained about this high-level synthesis programming. And finally, just now we had this Professor Iya Dayub, wonderful explanation about the 6G communication application. And then we had also 80 presenters from actually 82 accepted papers. So we had 11 paper presented from the antenna device and techniques track. And then we had 17 paper from control system robotics and mechatronics. And then we had this 14 paper presented in the track of electronic materials, component and circuits. We had 3 papers in the remote sensing and radar system, 3 in the RF and microwave theory, and 18 in the signal and image processing techniques. And then also we had 14 papers presented in the wireless and wired communication paper. Also, our appreciation for all the speakers and participants' contribution. I think we had this engaging and lively discussion throughout the plenary and parallel sessions. We had this almost over 143 participants in the Zoom, and maybe some also in the YouTube, streaming YouTube. I think this opportunity will give us a lot of new knowledge and also learning, and hopefully also for some people it will add a networking or future collaboration. We know new people from this conference, and I hope with this it will initiate a growth in our understanding for research and innovation development in the future. So the conference is over, but the publication process is ongoing. So I hope for the authors, the participation for preparing the final manuscript for publication is still needed. So we hope the cooperation from the authors for this preparing this final publication. So finally, we would like to thank the technical co-sponsor, which is the IEEE Indonesia section, and also the financial sponsors like gold patron from Andritsu and Unitronic Jaya, and then also the bronze patron from PT Iramitra Perdana, PT Serviam Abadi Muni, PT RTI, PT Dynatech, CV Nugarada Abadi, and then PT MSG and PT NTP. Also, I would like to say thanks to the advisory board, Pak Budi, Pak Yusuf, Pak Ruli, also all the moderators who are involved in this 2 days conference. Also, we would like to say thanks to all the reviewers who already reviewed all the papers submitted to this conference. And last, I would like to say thanks to the public relation of BRINS who helped to support this conference. The last, I would like to say thanks to the organizing committee. I cannot say all the names, but I will just show all the pictures here. And without their support, I think this conference will not be successful. I think that's all from me. I will give the opportunity to head of Research Center of Electronics to close this conference. That's all from me. Assalamualaikum warahmatullahi wabarakatuh.
Thanks to Dr. Yuliar Firdaus also for the lots of work and time you have put in for ICRAMET 2023. I would also like to thank and appreciate the contributions of all the speakers, panelists, attendees for making this event a success. I also hope the publication process will run smoothly and successfully. And now I would like to invite Dr. Yusuf Nurwijayanto as the head of Research Center for Electronics to officially conclude the 2023 International Conference on Radar, Antenna, Microwave, Electronics, and Telecommunications. Please join me in welcoming Dr. Yusuf Nurwijayanto.
Thank you, Ms. Ardita. Okay, first of all, good afternoon, everyone. Assalamualaikum warahmatullahi wabarakatuh. Basically, in this opportunity, I would like to say thanks you to a lot of people in here. First of all, I would like to say thanks to our technical co-sponsor, IEEE Indonesian section, and the sponsors this event, Andritsu and PT Unitronic, PT Eramitra, PT Radar Telecommunication Indonesia, PT Servian, PT NTP, CV Nugarada, PT Dynatech, and also PT MSG. We would like to show gratitude in the support from the ICRAMET Advisory Board, especially in the chairman of National Research and Innovation Agency, Dr. Laksana Trihandoko, and chairman of Research Organization for Electronics and Informatics, Dr. Eng Budi Prawara. And then we would like to thank our distinguished keynote speakers and patron who share their valuable experience and information at the plenary sessions, all the presenters, moderators, all the authors, reviewers, and all parties who have contributed their best effort and assistance in organizing this event and ensuring the success of it. Finally, thanks you to all of you for coming. Without your participation, it is not really fun to have a conference. No, there are also some people who have done all the hard work, especially thank you to the organizing committee who has prepared tirelessly the conference. We hope that the ICRAMET 2023 is able to impact all of us to greatly foster and empower the society through sustainable electronics and telecommunication innovation. To conclude, let me officially close the 12th International Conference on Radar, Antenna, Microwave, Electronic and Telecommunication, ICRAMET 2023, we'd say Alhamdulillah, praise be to the Almighty God. Thank you for the great contribution and looking forward to seeing you in the ICRAMET 2024. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh. Thank you. See you.
Close.
Thank you.
Terima kasih.
Untuk
Bujur.
Terima kasih. Thank you very much.